Hey there, welcome to Simplilearn's AWS Full Course. AWS skills are huge in demand right now. Companies everywhere are looking for people who know how to work with cloud technology and they're willing to pay you top dollar for it. So what exactly does AWS solution architecture do? They're the ones who design and build the cloud systems that power companies like Netflix, Airbnb, and even NASA. Pretty cool job, right? In this course, we are covering everything. We'll start by basics and work our way on hands-on cloud projects. You will learn how to think like a cloud architecture and even get ready for a certification along the way. Whether you're just starting out or want to upgrade your skills, this is your ticket into the world of cloud computing. Ready to build something amazing in the cloud? Let's get started. If you're looking to future-proof your tech career, this professional certification program in cloud computing and DevOps by E&ICT Academy, IIT Guwahati is perfect choice. In just 8 months, you will gain hands-on experience across AWS, Azure, and Google Cloud, master DevOps, tools like Jenkins, Docker, Kubernetes, and work on 30+ real-world projects. What makes this program stand out? You'll get official Azure certification, IIT-G issued credentials, access to live masterclasses, and even a campus immersion opportunity. Plus, with AI-powered job assistance, resume building, and interview prep, you are set up. Whether you're upskilling or making a career switch, this program offers everything you need to thrive in the cloud and DevOps space, with IIT backend credibility and practice learning that actually sticks. So hurry up and enroll now. The course link is mentioned in the description box below.
We're going to talk about AWS here. By the way, I'm Sam. I work as a cloud architect and technical author with Simplilearn. In this section, we're going to talk about what is cloud computing and how things were before AWS, and we're going to talk about what is AWS and the benefits of AWS and the products and services that Amazon offers as of now. And then finally, we're going to end this session with a project that is going to help us understand how to create a Jenkins build server for continuous integration. And in this project, we will learn about how to deploy and host Jenkins, an open source automation software predominantly used for CI/CD, otherwise continuous integration and continuous development. So what is cloud computing? Cloud computing is the on-demand delivery of compute resources through a cloud platform accessed via the internet, and it's also a pay-as-you-go service. Be it compute capacity or database or storage, in cloud we access them through the internet, and that too on a pay-as-you-go pricing model. Let's talk about how things were before AWS existed. Expedia, as we know as the people logistic company or the company that helps people move around the world with ease, has a certain problem before they decided to migrate to AWS. And migrating to AWS was a solution to their problem. Back then, booking ticket was an unpleasant experience compared to what it is now. It generally would take a long time to book a ticket. And sometimes it would time out if there is a promotion or if a huge sale announced, and if the environment is not scaled up to meet the demand. And sometimes it would time out if there is a promotion or if a huge sale announced and they could not scale up the environment and keep up with the speed of the promotion. That's when they got introduced to AWS, and with the AWS power to increase the capacity of the environment on the fly, solved their scaling issue. Instead of waiting on the new hardware to arrive and wondering what to do with the hardware when the promotion is over, with AWS we can quickly scale up the environment when there is a need and scale down the environment during lull periods. Now, that being said, let's talk about what is AWS. Amazon Web Services, or in short AWS, is a secure cloud service platform offering compute power, database, content delivery, and other functionality that you would need to help your business scale and grow. AWS is a very secure cloud platform, and such security cannot be imagined in on-premises without spending a fortune. Almost any type of applications can be created and deployed in the cloud, which includes the latest IoT applications, machine learning, artificial intelligence, and so on. And the best part is we can avail the service from anywhere as long as we have an active internet. and all this is availed on pay-as-you-go subscription. Now let's talk about the benefits of AWS. AWS Cloud Platform is very easy to use. One needs no complicated programming or compute knowledge to access and use this environment. Even with less programming and compute knowledge, one could become a pro in accessing and maintaining the cloud. The products and services offered are very flexible in nature, and that provides room for us to easily integrate the service to other services in AWS and services outside AWS. Cloud in general is a very reliable service, and AWS in specific is very reliable. Cloud in general is very reliable, and when we talk about AWS, it's very true. A statistic says that about 95% of the cloud computing in the whole world is run on AWS due to AWS reliable nature. The services in AWS are scalable by nature, and most of the services provide click button scaling. Services in AWS are very cost effective, and it becomes very true when you start using more. Services in AWS are very cost effective, and it becomes very true when you start using more services in AWS are very cost effective, and it becomes more true when we start using more, since when we start using more service, the per unit price drops down even further. Security in the cloud is at its highest with encryption and multi-factor authentications and being able to audit the logs. One can be sure that when one hosts a service in AWS, they are hosting it in an environment which has been built with enterprise security in mind. Alright, let's now talk briefly about the different products and services available in the cloud. Some of the products and services available in the cloud are compute, storage, database, migration services, networking and content delivery, developer tools and services available for managing the AWS environment, tools needed for machine learning development, analytic tools needed for security and identity compliance, tools needed for mobile application services, tools needed for IoT and gaming development are some of the products that are available in AWS. Alright, let's first talk about compute service. Now, compute service, it enables us to develop, deploy, run and scale our applications and workloads on the cloud. You might agree with me that compute service is the fundamental of any applications, and AWS provides many options to use those compute services in the cloud, starting from EC2, which is a VM in the cloud, to Lambda, which is serverless computing in the cloud, to compute service. Compute service also includes container services and services that help batch processing and deploying applications and load balancing the request when we run our applications on multiple servers, and services that help batch processing and developing applications and load balancing the request when we run our applications in multiple servers. We're going to talk about two compute products in specific. Let's talk about EC2. EC2 is a service with a resizable compute capacity in the cloud that allows business subscribers to run application programs in the computing environment. And the best part here is EC2 is resizable. Anytime there is more demand, I can simply resize my computer to meet the demand. On the other hand, Lambda is a serverless compute service used to execute backend codes. It really helps us to focus on the core competencies like application building the code. Let's talk about storage service for a while. AWS storage is known for its durability and availability, with S3 being the object storage for the internet, where users or application can directly upload and download the content from the internet, and EBS being a durable block storage that gets attached to the EC2 instance, and Glacier being the archival solution in the cloud, and Storage Gateway being the gateway for storing data locally and having a backup in the cloud in case of disaster. Let's talk about two important storage service products in the cloud, which is S3. Now, S3 is an web-based cloud storage service. It's designed for online backup and archiving of data. And the best part about S3 is that it provides 11.9 durability, which means once we store the data in S3, the chances of losing the data is nearly zero. EBS, on the other hand, provides persistent and resizable and migratable storage to the VMs or EC2s that we can run in the cloud. Now let's talk about the database offerings in the cloud, beginning with RDS for SQL and DynamoDB for NoSQL and Elasticache for web caching services and Amazon Redshift for petabyte scale data warehousing services. AWS Database Service provides all the database service needs we might have. Let's talk about two database services in specific. RDS. RDS is an web service that is designed to simplify the setup, operation, and scaling of the relational database in the cloud. And DynamoDB is a fast and flexible NoSQL database service which is well known for its low latency and scalability performance. Network and Content Delivery Service contributes to the infrastructure as a service side of the cloud. It provides a secure cloud infrastructure and connects our physical network to our private virtual network with low latency and high transfer speeds. And under Networking and Content Delivery Services, VPC is Virtual Private Cloud Networking in the cloud. Route 53 is the DNS service in the cloud. And Direct Connect is a service that connects our on-premises with AWS environment through point-to-point cables. And CloudFront is Content Delivery Network or caching service throughout the world. Let's talk about VPC for a while. VPC, it enables us to launch AWS resources into a virtual network that we define in the cloud. VPC resembles very similar to our office network with subnets, firewalls, private zones, public or DMZ zones, and a lot more. We can also create a VPN connection between on-premises and cloud environment through this VPC. And Route 53, it is a scalable and highly available domain name system web service that helps to route the end users to the internet application. Now AWS is a domain registrar as well, and here we can buy domain names for our organization and use them to mask the IP addresses behind it. And by the way, if you didn't know already, DNS is the one that translates human readable names like www.xyz.com into the numeric IP address. Let's talk about developer tool services. Now, developer tool services in Amazon provides services where developers can store an application source code and automatically build, test, and deploy applications on AWS, out of which AWS CodeStar enables us to quickly develop, build, and deploy applications in AWS. And Code Build is a fully managed build service that compiles source code, runs tests, and produces software packages that are ready to deploy. And Code Deploy, on the other hand, is a service that automates software developments to a variety of compute services, including Amazon EC2, Amazon Lambda, and even instances running on premises. And AWS Code Pipeline is a continuous integration and continuous delivery service for fast and reliable application and infrastructure updates. Let's talk about CodeStar. CodeStar is a service designed for developers where they can quickly deploy, build, and develop applications on AWS. AWS CodeStar provides a unified user interface enabling us to easily manage our software development activities in one place. With AWS CodeStar, we can set up our entire continuous delivery tool chain in minutes, allowing us to start releasing codes faster. And not only that, AWS CodeStar makes it easy for you or your whole team to work together securely, allowing you to easily manage access and add owners, contributors, and viewers to our project. And not only that, AWS CodeStar project comes with a project management dashboard, including an integrated issue tracking capabilities provided by Jira software. With the AWS CodeStar project dashboard, we can easily track progress across our entire software development process, from our backlog of work items to teams' recent code deployments, so on and so forth. AWS Code Build, on the other hand, is a cloud service that enables an IT developer to build and test code with continuous scaling. Now here you pay only for the build time that you have used. Now Code Build is a fully managed service that helps compiling source codes and run tests and produce software packages that are ready to deploy. With AWS Code Build, there is no need for us to provision, manage, and scale our own build servers. Code Build scales continuously and processes multiple builds concurrently. So our builds are not left waiting in the queue because it's processed concurrently. Let's talk about security, identity, identity and compliance services available in Amazon. In general, the security, identity and compliance services in Amazon helps us to maintain a secure environment in Amazon by providing services for user authentication, for limiting the access to certain set of users on the AWS environment, out of which IAM, or Identity and Access Management, it's a product that enables us to manage access to AWS services and resources, that enables us to manage access to AWS resources and services in a secure fashion. Using IAM, we can create and manage AWS users and groups and use permissions to allow and deny their access to AWS resources. On the other hand, KMS, or Key Management Service, is a managed service that makes it easy for us to create and control the encryption keys used to encrypt our data. And Cognito, it lets us to add user sign up, sign in, and access control to our web and mobile apps quickly and easily. And WAF, or Web Application Firewall, helps us to protect our web applications from common web exploits that could affect application availability, that could compromise security or consume excessive resources. And WAF, it gives us good control over which traffic to allow or block to our applications by sort of defining customizable web security rules. We can use WAF to create custom rules that block common attack patterns such as SQL injections or cross-site scripting, and we can also create rules that are designed for our specific application. Out of all the four, Identity and Access Management, it helps us to control access to AWS services and resources for our users. With the Identity and Access Management, I can restrict user access, or I can give a user complete access to the environment. If it's an admin, I can assign complete access, and if it is a user, I can provide some privileged access, or less, or degraded, or no access, depending on the role that the user plays in the organization. And KMS is a service that helps us to create and control the encryption keys used to encrypt the data. And also we can use hardware security model, HSM, to protect the security of our data in the cloud. Also, we can use hardware security model to protect the security of the key itself. And let's talk about the management tools and services available in Amazon. Management tools and services, it helps us to manage, monitor, and automate all the resources running in the AWS infrastructure, beginning with CloudWatch, a service which monitors the environment by receiving logs and creating a dashboard and sending alerts as needed, and CloudFormation, a service through which we can deploy new environments using just templates, and autoscaling, a product that lets us to handle the dynamic traffic with ease by dynamically scaling up and scaling down the environment as needed. And CloudTrail is another product or another monitoring tool that helps us to monitor or collect the logs of all the API calls to our environment and provides a searchable tool based on keywords and timestamps. Let's talk about CloudWatch a bit more detail. Now, CloudWatch is a monitoring service for AWS. With CloudWatch, we can track the metrics, we can collect and monitor log files, we can also enable CloudWatch to set alarms and automatically react to changes in the AWS environment. CloudWatch can also monitor AWS resources such as EC2 instances, DynamoDB tables, Amazon RDS instances, as well as custom metrics generated by your application and services, and any log files your applications would generate. Now, we can use CloudWatch to get a system-wide visibility into resource utilization, application performance, and operational health. We can use these insights to react and keep your applications running smoothly. And CloudFormation, on the other hand, provides a common language for us to describe and provision all the infrastructure resources in our cloud environment. Now, CloudFormation allows us to set up and model all our AWS resources so that we can spend less time in managing those resources and more time on our application. Now, CloudFormation is really an infrastructure as a code service where I can build an infrastructure based on the portable template I might be carrying. Alright, in this demo session, we'll talk about how to install Jenkins on Amazon Linux EC2 instance. And before that, let's talk about what is Jenkins and what is the purpose of it, why it is used, and all that stuff. Now, what is Jenkins? Now, Jenkins is an open source automation server, and it provides a lot of inbuilt plugins for deploying and automating any project. In short, it's an continuous integration server, and it is used for many purposes, used for tasks that take care of continuous deployment and delivery. And it provides these advantages, like the developer now will not have to focus on fixing errors because errors are automatically handled by Jenkins, and because of that it leads to faster development environment. Alright, so how do we go about doing it? Let's get started. The first thing is to go to our console and launch an EC2 instance. Actually, let me walk you through the steps through the PPT, and then I'll show it in the console. So let me first walk you through the steps in installing a Jenkins server. In this lab, we're going to launch an VM, or a virtual application server, to host our Jenkins installation, and then we are going to deploy Jenkins on top of it and then configure it as an build server. And for this we will need an AWS account to begin with, and then a bit of experience in Jenkins, and then some familiarity on EC2 and how EC2 gets connected to VPC, stuff like that. So when we're all done, this is how the architect is going to look like. Users, they get connected to EC2 instance, which is a Jenkins server, and then there are slaves, build slaves, that can be monitored, that can be used in deployment by the Jenkins server. So let's see how it is done. Alright, so let's first launch a server. Let it be an Amazon Linux instance. I'm going to pick T2 Micro because of the free eligibility, and because this is a lab, that should be more than enough. And I'm going to keep this as default. I'm going to stick with the default VPC, and I'm going to keep all the settings as defaults. And then I'm not going to add a storage. I'm going to keep the storage limited with the root volume. And then for security group, because we're going to access it through the internet, I would like port 80. In fact, since this is a lab environment, and since I'll be tearing it down right after the lab is over, we're going to use all IP, or we're going to use anywhere, all traffic, anywhere. View and launch. And I already have a key pair that I have created. If you're not familiar with creating key pair, launching EC2 instance, you might need to spend some time watching the AWS EC2 video. That would help. So I already have a key pair that's attached to this account in this region. So I'm using that key pair to launch the instance. Alright, and that's my Jenkins server. Alright, so once that is installed, let's log into it. Since this being an Linux instance, I'm going to use putty to log in, and then use the key pair that we have downloaded to log in. And the key pair was right here. Alright, now I'm connected to it. As first thing, we will have to install the Java environment. I'm going to show some commands towards the end. So if you're planning to do labs yourself, you can use those commands. They will be very handy. In fact, I can show it right now as we speak. So these commands are to install Java environment. And it has two versions as we speak, and I've chosen the latest version. So I've typed 2 and I've chosen the latest version in installing Java environment. The second is to install Apache Maven. Let me show you some commands that's used to install Apache Maven. And these commands vary from Linux version to Linux version. So if you're using a different Linux version, just be sure that you're using commands which are respective to that particular version. All right, let's install Apache Maven. Looks like some of them are already installed and it's throwing error for some, but anyway, it's considered an successful installation. And then let's install Jenkins. And the commands to install Jenkins is right here. So these are to install Jenkins, and to download the software and install it, and then start the Jenkins and make sure the Jenkins stays running even after a reboot. So let's run these commands. Alright, now Jenkins should be ready, or the Jenkins server is installed in our EC2 instance and it is ready for us to access. And the default port is port 8080. So let me go to the URL or IP. Let me go to that and then try accessing it using port 8080. There you go. So at the moment it's locked. It requires admin password to log in, and the admin password is present in this particular folder and this particular file in the Linux instance. So let me get that. Okay, one moment. Looks like the admin password is not present. Just give me one quick moment. Okay, it's just a permission issue. Let me check the password in that folder again with the elevated permissions. There you go. There's my password. Alright, once we're logged in, we can install all the suggested plugins. Now that's going to take some time to run and install all the default plugins needed to run a Jenkins server. Alright, it's done. Now, as next thing, it's going to ask for the admin username and password. You can choose as an existing administrator, or you can also create another admin user. In this case, I'm going to create another admin user. Alright, so the Jenkins server is installed. We can use the similar but slightly different procedure on the Jenkins nodes or the slave servers to make them Jenkins slave and respond to the builds that we push, or receive the builds or receive the jobs that we push through this Jenkins server. So we have built this Jenkins server on Amazon EC2. A similar and slightly different procedures can be followed to build Jenkins build servers that can contact Jenkins server to receive jobs and start working. Thank you for watching. I believe you enjoyed the session. I'll meet you in another session. Thank you.
So guys, our first service is Amazon EC2, which stands for Elastic Compute Cloud. So basically what it is, Amazon EC2 basically lets you rent virtual computers, which is servers, in the cloud. You can use them to run your applications without having to buy your own physical servers. And you'd be questioning that why this service is so important. So guys, the reason is that businesses no longer need to invest in expensive physical servers, which can be difficult to maintain and scale. So EC2 allows companies to adjust their computing power based on the current needs, ensuring they only pay for what they use. This flexibility helps companies to save costs during low traffic periods and manage high demand during peak times, all without worrying about maintaining physical infrastructure. Now, let me propose a case study where a company named Airbnb used EC2. So guys, this was the challenge. Airbnb experienced issues with scaling during high traffic periods, such as holidays and during major events, which leading them to system slowdowns and potential outages. Managing their own server was very costly and time consuming, as they had to predict demand and manually add capacity, which often led to over and under poisoning. Now, I'll explain what over and under poisoning is, but let us first look at what are the issues they faced. The first one, they had the scaling issue, which means that high traffic periods during holidays caused slowdowns and outages. Then there was a problem of server management. Managing physical servers was very expensive and complex. Then they had unpredictable demand. It was very hard to predict traffic spikes, which led them to capacity problems. Then there was manual capacity addition. It also required manual intervention to scale up during their resources. And finally, they had over or under poisoning, which meant that often they had many servers or few servers, which led to wasting resources or causing slowdowns. Now, what was the solution, guys? So after moving to Amazon EC2, Airbnb could automatically scale its infrastructure up and down based on the demand. EC2's pay-as-you-go model allowed them to avoid the cost of over-provisioning and handle peak traffic seamlessly. So guys, there is some statistics which I want to share, that Airbnb infrastructure scaled up by 3x during the peak period using EC2's auto-scaling feature, which led them to zero downtime during high-demand seasons. They also reduced infrastructure costs by 20% by paying only for the capacity they needed. Now, let us move to our second service. So guys, our second service is Amazon S3 or Simple Storage Service. What it is, guys? Basically, Amazon S3 is a cloud storage where businesses can store and retrieve any amount of data like documents, videos, and backups. Why it was important, guys? Basically, S3 provides virtually unlimited secure storage that automatically scales with your needs. It eliminates the need for businesses to purchase and manage physical storage hardware. S3 also integrates easily with other AWS services, making it a key component for storing large amount of data like backup application files or even media streaming content. Its high durability is around 99.99%, which ensures that your data is safe and always accessible. Now, let us look at a case study of Netflix. So guys, during 2012, Netflix faced a massive outage due to a failure in their data storage system, resulting in downtime that cost them millions in lost in revenue. Their existing infrastructure could not handle the massive amount of content that required constant maintenance. Now, there are some of the problems with Netflix faced. The first one is massive outage, which means that Netflix experienced a major data storage failure in 2012. Then they had to go through a significant downtime. This outage resulted in millions of dollars in lost revenue. They had inadequate infrastructure. Their existing storage system couldn't handle the large content volume. Then there was scalability issues and also constant maintenance. The infrastructure struggled to scale up with the growing user demand and also caused them a lot of problems. Now, after migrating to Amazon S3, Netflix was able to store massive amount of data. S3's scalability allowed Netflix to handle global content distribution without interruptions or data loss. Now, let me show you some statistics, guys. So, Netflix now streams to over 230 million users globally, with S3 handling 1000 petabytes of video content, approximately. The switch to S3 reduced Netflix data loss risk to near zero and downtime dropped by 90%. So guys, this was one of the case study where Netflix used S3 and this was the amazing result that they got. Now, let us see one of the next Amazon Web Services, which is Amazon RDS or Amazon Relational Database Service. So what it is, guys? RDS is a managed database service that takes care of setting up, maintaining, and backing up databases for you. Why it is important, guys? Because managing databases can be time-consuming. It involves tasks like software updates, backups, and scaling. RDS automates these tasks, freeing up valuable time for businesses to focus on the other core activities. With features like automated backups, multi-zone availability, and easy scaling, RDS helps businesses to ensure their databases are always running smoothly and securely, without the headache of manual intervention. Now, we'll take again the example of Netflix. So guys, during this phase also, Netflix suffered from a critical database outage, leading to a data corruption and millions in losses. Managing on-premises database was very difficult as backups, scaling, and disaster recovery required significant resources and manual effort. Now, these are some of the problems which Netflix faced. The first one was critical database outage, where Netflix experienced a major database failure. Then they had to go through data corruption, where this outage caused significant data corruption. There was massive losses because there was incident resulted in millions of dollars in losses. Then there were some on-premise challenges, like managing their on-premise database was very complex and inefficient. And there was also lack of automation because manual database management increased the risk of failure. So guys, by using Amazon's RDS, Netflix automated database backups, patching, and scaling. RDS multi-agent deployment provided high availability and fault tolerance, which ensured that data losses during the failure outages are very minimal. Now, there is some statistics that Netflix reduced its database recovery time from hours to minutes in using RDS. Their database operational cost also dropped by 50%, and due to the automated management features. So see how this service was very useful for Netflix. Now let us move ahead and try to understand our next service, which is AWS Lambda. But before we discuss this service, just a quick info guys. Simplilearn has got Cloud Architects Master Program. You can master AWS, Azure, Google Cloud with the Cloud Architects course. You will build expertise in AWS, Microsoft Azure, GCP with the Cloud Architect certification course. You will also receive exam vouchers which is included on any Azure course. You will access official AWS authored self-learning content. Plus, you will also master cloud architectural principles, design, and also deploy scalable service on cloud platforms. So guys, hurry up now and join the course. The course link is mentioned in the description box. Now, let us move ahead in a discussion of what is AWS Lambda. So guys, Lambda lets you run your code in the cloud without having to manage servers. Basically, it automatically scales up when needed and only charges for the time your code runs. Why it is important guys? Because Lambda allows businesses to run code without worrying about servers or infrastructure, paying only for the compute time used. This means companies can handle fluctuating traffic without having to over-provision servers, which means that it will help in saving cost and reducing complexity. Lambda is ideal for event-driven applications, where tasks are triggered based on the specific events, such as a file upload or a user action. Now, there is a company called iRobot guys. So, iRobot needed to process large volumes of data from millions of Roomba devices worldwide. Managing servers to handle this real-time data was very complex and expensive, especially when usage fluctuated. Now, there was some problem guys with this, that they had high data volume, they had real-time processing problems, they had a problem of server management, then the cost challenges also came up and the scalability issues. Then iRobot adopted AWS Lambda's serverless architecture to automatically scale based on the number of incoming requests. They no longer had to manage servers or pay for idle time, as Lambda only charges for the exact compute time used. So guys, what was the result? That iRobot saw a 90% reduction in infrastructure cost by using Lambda's pay-per-use model. Lambda processed over 20 million events per day, scaling effortlessly without manual intervention. So guys, these were the success story of iRobot by using the AWS Lambda service. Now let us move ahead and discuss about our next service, which is Amazon CloudFront. So guys, what is CloudFront? Basically, CloudFront is a content delivery network that speeds up the delivery of websites, videos, and other data to the users around the world. Why it is important, guys? Because CloudFront reduces the time it takes to deliver the content to users, particularly those located far from the origin server. This is crucial for businesses that need to provide a fast and seamless experience to global audiences. Whether it's delivering videos, web applications, or large files, CloudFront ensures low latency access, improving the user satisfaction and engagement. So guys, you have heard about a company called Slack. Slack once experienced high latency and slow message delivery for users located far from their data centers. This created delays and inconsistent user experience, especially for global teams collaborating in real time. Now, let us see what were the problems faced by Slack. They had a problem of high latency, where I have told you that users far from Slack's data center experience significant delay in message transmission. The slow message delivery was there. Geographical impact was one of the problems, where the latency issues were more pronounced for global teams collaborating across distant locations. Then, if we talk about real-time collaboration, were also hindered. This delayed caused challenges for teams that rely on real-time communication, which finally affected and disrupting the workflow. And finally, they had inconsistent user experience. So guys, by implementing Amazon's CloudFront, Slack was able to cache and deliver content from edge location closer to the users, reducing latency and improving overall performance. CloudFront's integration with AWS Shield also improved security against potential DDoS attacks. Now, after using this service, Slack reduced the latency by 50% globally, providing real-time messaging to 10 plus million daily active users. They also experienced 40% faster file uploads and improved performance for international teams. So guys, this was a success story of Slack. Now let us move ahead and discuss about our next service, which is Amazon EBS or Elastic Book Store. So guys, what it is? Basically, Amazon EBS provides high performance storage for application running on EC2 instance. It is like a virtual hard drive that you can attach to your EC2 server. Why it is important, guys? Because EBS offers fast, reliable, and persistent storage for applications that require consistent, high-performance storage like databases or big data applications. Businesses can scale storage up or down as needed. EBS automatically backs up the data with snapshots, which ensures minimal downtime and data loss. So guys, there's a company called Expedia, which faced performance issues with their existing storage system. It struggled to handle high volume of transactions during peak booking times, leading to slow response times and frustrated customers. They had performance issues, they had high transaction volume problem, like as I've told you, during the booking busy periods. Then they had slow response time where customer experienced slow response affecting their ability to complete bookings efficiently. Then they had the problem during the peak booking. They faced challenges where the problem was basically the performance issues. Now the customers were also frustrated. So what Expedia did was, Expedia migrated their databases from Amazon EBS, which offered consistent low latency performance and automatic scaling to meet high demand periods. EBS also provided robust snapshots backups for disaster recovery. As a result, Expedia improved booking transaction speeds by 35%, ensuring faster response time during their peak travel seasons. They also increased their data through output by 2x, supporting millions of daily searches queries without the delays. So this was a success story of Expedia, guys. Now you'd be excited to know the next success story. So our next AWS service is Amazon VPC or Amazon Virtual Private Cloud. What is Amazon VPC? Basically, VPC allows businesses to create a secure private network in the AWS cloud, giving them control over how their data and applications interact with the internet. Why this is important, guys? Basically, VPC provides businesses with full control over their cloud network, including IP addresses, subnets, and security. It allows businesses to securely connect their on-premises infrastructure to the cloud and ensures that sensitive data is kept separate from the public internet. For industries like finance and healthcare, this level of security is critical for meeting regulatory compliance. What was the challenge, guys? So there is a company name called Capital One. Capital One needed a secure and scalable cloud solution to manage its sensitive financial data while meeting strict regulatory requirements. Their on-premises infrastructure was expensive to maintain and difficult to scale securely. So guys, they had problems like need for security, scalability challenge, they had a problem of regulatory compliance, they had high maintenance cost, and it was very difficult to scale securely. So guys, by creating an isolated virtual private cloud, Capital One securely migrated its application and data to AWS. VPC gave them full control over their networking environment, ensuring compliance with data privacy regulations while reducing infrastructure costs. Capital One basically reduced their infrastructure management costs by 30% by using the VPC. They achieved 99.99% of uptime for critical applications, thanks to secure, scalable cloud infrastructure of VPC. So guys, this was one success story of Capital One. Now let us look at another Amazon Web Service, which is Amazon IAM or Amazon Identity and Access Management. What it is, guys? Basically, IAM lets businesses control who can access their AWS resources by setting permissions and user roles. It is important because IAM ensures that only authorized individuals can access sensitive resources, reducing the risk of security breaches. It's a critical tool for controlling access in large organizations where multiple teams need different level of access to cloud resources. IAM also supports multi-factor authentication, which adds an extra layer of security. Now, what is the challenge, guys, which a company named Autodesk faced? So Autodesk had a global workforce, and managing users to access various AWS resources was becoming very complex. They needed a way to ensure that only authorized users could access sensitive data and resources while maintaining security across the board. So they faced a problem of complex user access management. Then there was a need for authorized access. Then there was a global workforce challenge which Autodesk faced. Then they had to also maintain their security standards, and they had a problem of access control. They needed a solution on access control, where a more efficient and a scalable system was required by Autodesk to simplify and secure user access management across the AWS resources. So guys, Autodesk implemented AWS IAM to manage permissions and access control across their global team. With IAM, they created detailed user roles and policies, ensuring secure access based on need and reducing the risk of data breaches. So guys, Autodesk reduced unauthorized access incidents by 60% after implementing IAM. They decreased the time spent on access management by 40% thanks to the IAM's centralized control system. And that was possible. So this is how Autodesk solved this problem. Now, let us move ahead and discuss about our next service. This is a very amazing service, guys. Its name is Amazon SQS, or Amazon Simple Queue Service. Basically, Amazon SQS is a messaging service that allows components of systems to communicate with each other by sending and receiving messages between distributed applications. Why it is important, guys? Because SQS allows systems to scale independently by decoupling tasks, meaning different parts of an application can work on their own schedule without being dependent on one another. It's useful for batch processing, event-driven applications, and microservices. I know it sounds a bit of a technical jargon, but these are some of the scenarios where SQS is used. So guys, you have heard about this famous company called Disney Plus. Disney Plus faced challenges in managing their large volume of user requests, especially during their release of popular shows and movies. Handling real-time requests without overloading the system was a constant issue. They faced problems like high user request volume, real-time request handling, then system overload risk was there because the platform constantly struggled with the risk of system overload during peak viewing times. Scalability challenges were also there because handling large number of concurrent users required scalable solution. And also consistent user experience means they ensure to have a smooth and uninterrupted experience for all the users during high demand periods, which was not happening. Now, Disney Plus adopted Amazon SQS to queue and process tasks efficiently, decoupling their application components. This ensured that tasks such as streaming requests were processed smoothly, even during high traffic periods. And finally, Disney Plus handled over 1 million requests per second during peak streaming periods, with SQS ensuring no message was lost. The use of SQS improved systems performance by 25%, enabling Disney Plus to deliver uninterrupted streaming experiences. So guys, this is a success story of Disney Plus. Now let us move ahead and discuss about our final service. Can you guess it, guys? Yes, it is Amazon DynamoDB. DynamoDB is a fully managed NoSQL database service that is fast and scalable. It is ideal for applications that need to handle large amount of data with low latency. So this is the thing. Now you would be wondering why DynamoDB is important. So guys, DynamoDB is very essential for applications that experience rapid growth or fluctuating demand. Unlike the traditional databases, they might struggle to keep up the volumes of traffic, but DynamoDB can automatically scale up to handle millions of requests per second. This is just something which I told you. Let me elaborate this by the story of a company called Lyft. So guys, Lyft needed a database that could handle millions of ride requests in real time. But their traditional database systems could not scale efficiently to meet the demand, leading to slow response time during busy hours. They had problems like real-time data handling, scaling limitations they had high request volume, they had slow response times, and also they needed a scalable solution for this problem. Now, here comes the DynamoDB. Lyft switched to Amazon's DynamoDB, which provided fast, scalable, and serverless architecture with NoSQL database services. DynamoDB ability to handle millions of requests per second ensured that Lyft could match drivers with riders in real time without latency. Now, this is the thing which Lyft has seen. Lyft processed over 2 million ride requests per day with DynamoDB, scaling automatically to meet the peak demand. They improved the response time by 70%, ensuring a smooth experience for both drivers and riders. This is how Lyft solved this problem. What amazing service is DynamoDB?
Hey tech enthusiasts, welcome to yet another informative video from Simplilearn. Imagine you're managing an online store. You need to handle day-to-day transactions, analyze sales trends over the past year, and store massive amounts of raw customer feedback from social media. How do you manage all this data efficiently? This is where databases, data warehouses, and data lakes come into play. I'm pretty sure most of you are well aware of what a database is. A database is a system that stores and organizes data in a structured way, using rows and columns, making it easy to access, manage, and update information. Now, if data can be stored and managed in databases, then what is a data warehouse and a data lake? And why do we need them? So in this video, I will give you a clear understanding of what a database, data warehouse, and data lake is with examples. How are they different from each other and what factors to consider before choosing amongst the three? So let's jump in. So what is a database? A database is essentially a structured collection of data or information that is stored electronically. It serves as a centralized repository where data is organized in a systematic way, often using tables, rows, and columns. So the primary function of a database is to support online transaction processing or OLTP, which means it handles the real-time transactions and operations of businesses or applications. So behind the scenes, a database management system or DBMS manages the database, ensuring data is stored securely and efficiently. So the DBMS also allows users and applications to interact with the data through queries, updates, and modifications. So in common usage, the term database can refer both to the actual data repository and the software system or DBMS that manages it, providing a seamless interface between users and their stored information. Now, there are two types of databases. Relational databases store data in structured tables with fixed rows and columns. This structured approach makes them ideal for applications requiring strong data consistency and complex querying capabilities. On the other hand, non-relational databases, often referred to as NoSQL databases, offer more flexibility by accommodating various data models. So these include JSON for semi-structured data, BSIN, key value pairs for simple data retrieval, tables with dynamic columns for evolving schemas, and graph databases using nodes and edges for connected data relationships. So some of the examples of databases are Oracle, MySQL, and PostgreSQL, and also MongoDB. Now, what is a data warehouse? So a data warehouse functions as a specialized database designed to store structured information gathered from multiple sources, so encompassing both current and historical data. So unlike traditional databases primarily focused on transaction processing, data warehouses are tailored for analytical purposes. So they consolidate data from different systems to facilitate comprehensive analysis, uncover insights, and generate business intelligence through reports and dashboards. So in essence, while a data warehouse is indeed a type of database, it distinguishes itself by its optimized architecture for handling complex queries and facilitating data analytics essential for strategic decision-making in organizations. So a data warehouse serves as a centralized repository designed to store large volumes of both current and historical data gathered from diverse sources. This data ranges from raw, initially ingested information to highly refined, cleansed, filtered, and aggregated data sets. The process of moving data into a data warehouse is managed through extract, transform, load or ETL process, which extract data from its original sources, transform it to fit the warehouse schema, and load it into the warehouse on a regular basis, such as hourly or daily schedules. So this periodic loading means that the data warehouse may not always reflect the most current state of the original systems. So once the data is successfully loaded into the warehouse, business analysts and data scientists can utilize business intelligence tools to connect to the data warehouse. So these tools enable them to explore the data, uncover valuable insights, and generate reports that aid business stakeholders in making informed decisions based on comprehensive data analysis. So examples of data warehouse is Amazon Redshift, Google BigQuery, and IBM DB2 Warehouse. Now, what is a data lake? So a data lake serves as a centralized storage repository for data collected from various sources, preserving it in its original or raw format. So unlike data warehouses that also handle extensive volumes of both current and historical data, data lakes distinguish themselves by their versatility in storing diverse data formats such as JSON, BSON, CSV, etc. So the core objective of a data lake typically revolves around analyzing this data to extract valuable insights. So however, some organizations use data lakes mainly because they offer affordable storage options, storing data in anticipation of future analysis. So data lakes are versatile storage systems that can handle large amounts of structured, semi-structured, and unstructured data. So unlike traditional databases or data warehouses, data lakes don't need data to be organized before storing it, allowing quick accumulation of diverse data types like spreadsheets, JSON files, PDFs, and multimedia. So different users access data differently. Structured data is often used directly by business analysts for insights, while unstructured data requires expertise from developers, data scientists, or data engineers. This set of flexibility lets analysts and scientists discover unexpected patterns and insights, using the data's variety and volume to solve problems that weren't anticipated initially. So data and data lakes can be processed with online analytical processing or OLAP systems and visualized using business intelligence tools, improving data exploration and decision-making capabilities. Some of the examples of data lake are AWS S3, Azure Data Lake Storage Gen 2, Google Cloud Storage, etc. So now let's recap the differences among the three of them. So if your application needs to store data, which is essential for most interactive apps, having a database is crucial. So databases are fundamental for applications in various industries and scenarios. They provide an organized way to store, retrieve, and manage data effectively. For instance, an online store uses a database to handle product stocks and customer orders. Similarly, a healthcare system relies on databases to manage patient information and medical histories. Even social media apps use databases to store user profiles and posts. So without databases, it would be difficult to manage and access data reliably, impacting the functionality and usability of interactive applications. Now, data warehouses are essential when organizations need to store large amounts of historical data and analyze it deeply to gain business insights. Their organized structure makes data analysis straightforward, accessible to business analysts, and beneficial for data scientists. So unlike transactional databases used daily for operations, data warehouses specialize in handling complex queries and generating detailed reports. So this capability supports strategic decision-making based on past trends and patterns. It's important to note that while data warehouses excel in analytics, they aren't suitable for real-time transaction processing or handling multiple users at once. So organizations typically maintain separate databases for day-to-day operations and use the data warehouse specifically for strategic analytics and business intelligence. Now, data lakes are a budget-friendly way to store large amounts of data in its original form. So unlike regular databases or data warehouses that need data to be organized beforehand, data lakes allow storing various data types like structured, semi-structured, and unstructured without immediate restructuring. So this keeps data raw, letting business fully explore and analyze both current and past information, uncovering insights that may not be obvious initially. So data lakes are great for advanced analytics such as machine learning and predicting trends, offering flexibility for experimenting with data. However, they aren't suitable for handling day-to-day transactions or meeting the fast data access needs of operational tasks, which traditional databases and data warehouses specialize in. So I hope now you all know how the three of them differ. Now, having known that, there are some factors to be considered before deciding on which platform to use. So let's look into those. Considerations like the variety and volume of data sources, the way data arrives, and how predictable its structure is are crucial. So data lakes are versatile, handling unstructured data in various formats. On the other hand, data warehouses specialize in structured data from multiple sources. Now, databases perform well with structured data from one source, but may struggle with scalability. Now, the choice between these platforms depends on these factors, shaping their roles in data management and analytics. Now, in a solid data management strategy, choosing when and how to use data models is crucial. In a solid data management strategy, choosing when and how to use data models is crucial. Data lakes offer flexibility by storing raw data alongside metadata, allowing schemas to be applied later during data extraction for analysis. On the other hand, databases and data warehouses use ETL, extract, transform, load processes. Here, raw data is transformed into a predefined structure upon ingestion, called schema on write. This difference shows how data lakes enable agility in exploring data and adjusting schemas as needed, contrasting with databases and data warehouses that prioritize upfront data organization and consistency through fixed schemas. Now, big data is highly valuable for businesses, evident in their investments in data management. As data grows in volume and speed, storage expenses increase. Data lakes are cost-effective because they store data as is, reducing storage needs compared to data warehouses that require extensive processing before analysis. Databases can scale storage capacity to match demand. Now, the choice between a data warehouse, data lake, or relational database depends on users' role, whether they are a business analyst, data scientist, or a part of operations, and their specific organizational needs. So operations teams focused on business insights often prefer data warehouses for structured data analytics, despite higher setup and storage costs. Data scientists prefer data lakes for their flexibility with structured and unstructured data, which supports advanced AI and machine learning. Business analysts skilled in SQL may find relational databases adequate for generating specific trend reports on business segments. So each option serves different needs based on data complexity, analytics requirements, and cost considerations. Now, organizations have different preferences between open source and proprietary software, along with the communities backing them. So data lakes are popular because many use platforms like Hadoop, and there's a growing amount of unstructured data from various company systems and real-time data streams. Another important point is how easy and affordable it is to update systems and when data sources and structures change. Unlike relational databases and data warehouses, which can be expensive to update, data lakes make it simple to adjust, making them flexible for changing data needs.
As cloud adoption continues to increase, with IDC predicting that global cloud spending will reach 1.3 trillion by 2025, there's never been a better time to certify your skills. This AWS Cloud Practitioner certification is for anyone who wants to understand Amazon Web Services cloud better, no matter their technical background. Plus, AWS certified professionals earn an average of $183,000 per year, highlighting the significant financial benefits of becoming certified. So what are you waiting for? In this video, we will cover everything about AWS Cloud Practitioner certification, career goals and objectives, market demands, cost investment, and advantages of the certification. Alright, so let's understand about AWS Cloud Practitioner certification. Alright, so now let's talk about AWS Certified Cloud Practitioner exam. So the AWS Certified Cloud Practitioner exam is an entry-level certification designed for individuals who are new to cloud computing and want to build a foundational understanding of AWS services. This certification is particularly beneficial for those without an IT background, making it accessible to a wide range of people looking to start a career in the cloud. This certification is ideal for business professionals, including sales, product management, and project management roles. It helps them gain a basic understanding of cloud concepts, which enhances their ability to communicate effectively with the technical teams and customers. By understanding the core AWS services, pricing, and support models, these individuals can make decisions and contribute more to their organizations. One of the advantages of AWS Certified Cloud Practitioner exam is the flexibility it offers in testing options. Like candidates can choose to take the exam in person at VU or like testing centers or online with a proctor, making it convenient to fit for various schedules. Alright, now talking about the key details of the exam. So first, that is a level of the exam is foundational. Then talking about the duration, the exam lasts 90 minutes, giving candidates ample time to answer all the questions thoroughly. The format of exam. So it consists of 65 questions which can either be multiple choice or multiple response. This format is designed to test your understanding of AWS services and cloud concepts in a comprehensive manner. Talking about the cost. The exam cost is $100. It's worth noting that additional cost may apply depending on your location and the prevailing exchange rates. Then testing options. So as we already discussed, you can take the exam in person at a person view testing center or online through a proctored exam, offering flexibility to fit your schedule and preferences. So this was about the AWS Practitioner Certification. Now let's have a look at one of its important factors, which is career goals and objectives. So the AWS Certified Cloud Practitioner Certification helps you start with a career in cloud computing by giving you a foundation knowledge of AWS services. So this certification is great for entry-level jobs as it shows employers you understand basic cloud concepts. However, the certification alone isn't enough to secure a job. To maximize your chances, it's important to create cloud projects alongside your studies. Working on cloud projects helps you apply that you have learned and gives you practical experience, making you more attractive to employers. It's also beneficial to stay updated in the new AWS services and continue learning. Building a portfolio of projects can show potential employers that you have hands-on experience, which is highly valued in the job market. Also, for individuals in sales, product management, project management, or other technical roles, the AWS Cloud Practitioner Certification can help them better understand how cloud computing works and how AWS services can be used to benefit their business. This can improve communication and collaboration with the technical teams and customers. Now let's move on and have a look at salary and companies hiring for AWS professionals. So the average salary of an AWS professional in the United States is $133,000 per year. This high-paying job role is in demand across many companies. Notable employers looking for AWS professionals include TCS, Accenture, Mindtree, IBM, Capgemini, and Deloitte, and many more like that. These companies value AWS skills due to the growing need for cloud computing expertise. AWS professionals help business leverage cloud technology for better scalability, efficiency, and the cost-saving purposes. With such a increasing or lucrative salary and demand from leading companies, pursuing a career in AWS professional can be a smart and rewarding choice for you. Alright, now let's talk about the market demands. So don't worry about new AI technologies stealing your future about cloud job. You don't have to worry. The demand for AWS skills in the job market is growing rapidly, with many companies transitioning to cloud computing. The cloud computing market is experiencing explosive growth according to Gartner in 2024. Worldwide end user spending on public cloud services is forecast to total $679 billion. Businesses of all sizes are migrating to the cloud to benefit from its scalability, cost efficiency, and agility. This rapidly adoption has created a significant skill gap. A recent report by Global Knowledge estimates a shortage of over 3 million cloud computing professionals globally. By acquiring AWS skills, you are not just securing a job in today's market, but you are positioning yourself for a successful career in the ever-growing field of cloud computing. Coming to the next one, which is cost investment. So the AWS Certified Cloud Practitioner exam costs $100. This is a straightforward fee for registration and taking the exam. Additionally, while the AWS offer free digital training courses, you might also consider investing in supplementary study materials such as books, online courses, and practice exams. Now, let's discuss the advantages of Cloud Practitioner Certification. One of the coolest perks of getting the AWS Practitioner Certification is the digital badge you receive. It's like a digital trophy that you can proudly display on your social media profiles and email signatures. This badge not only shows off your achievement, but also grants you immediate access to exclusive AWS-sponsored certification events, which can be a great way to network and learn more. Another fantastic benefit of this exam: once you're certified, you get a 50% discount voucher that you can use for recertification or even for taking another AWS certification exam. This means you can keep your skills up to date without breaking the bank. Yes. Alright, the next is, when it comes to recognition, AWS really goes the extra mile. As a certified professional, you will get the invites to special regional appreciation receptions. Plus, when you attend a major events like AWS reInvent or select AWS Summit events, you can use your digital badge to gain exclusive access to the AWS certification launches. These launches are perfect for networking, relaxing, and meeting other AWS professionals. Lastly, you'll also become a part of AWS Certified Global Community. This community, accessible via Intuitive, allows you to connect with other AWS certified individuals from around the world. It is an excellent platform for networking, sharing knowledge, and staying in the loop with latest in AWS. So this AWS Cloud Practitioner Certification opens doors to the world of opportunity in the booming cloud computing market. With its industry recognition and focus on foundation knowledge, this certification is a valuable investment for both aspiring IT professionals and business-minded individuals.
Cloud services are now available to satisfy almost any IT requirement. Although cloud computing services vary greatly, They all have some basic qualities and benefits in common, and they can be classified into a few basic cloud service kinds. Hello everyone, I'm Shamli and I welcome you all to this new video of Simplilearn on cloud computing services. Let me give you an overview of the concepts you are going to go through in this video. First, we will go through what is cloud computing. Then we will have an introduction to cloud computing services, followed by the types of cloud computing services. And at the end, we will look into the features and benefits of cloud computing services. So let's not waste any more time and get started with the video. So what is cloud computing? Cloud computing is the distribution of cloud computing services via the internet, including servers, storage, databases, networking, software, analytics, intelligence to provide faster innovation, more flexible resources, and economies of scale. You usually only pay for the cloud services you use, which helps you cut costs, run your infrastructure more efficiently, and scale as your business grows. Now that we know what cloud computing is, let's proceed with understanding cloud computing services. Cloud computing services provide users with a variety of capabilities, including email, storage, backup, data retrieval, app creation, testing, data analysis, audio-video streaming, software on demand, regardless of the type of service. Although cloud computing is still a relatively new technology, it is now being used by a wide range of organizations, including large enterprises, small businesses, non-profit government agencies, and even individual consumers. So, not all clouds are created equal, and not every sort of cloud computing is appropriate for every situation. A variety of models, varieties, and services have evolved to assist you find the best option for your needs. To begin, one must decide on the type of cloud deployment or cloud computing architecture that will be used to implement your cloud services. Cloud services can be deployed in three different ways: public cloud, private cloud, or hybrid cloud. Now let's dive down deeper into cloud computing services and explore its type in more detail. Cloud computing, unlike a microprocessor, is not a single piece of technology. Rather, it's a system made up of three services: infrastructure as a service, platform as a service, and software as a service. So let's have a better understanding of each, starting with infrastructure as a service. So what is infrastructure as a service? It is a type of cloud computing that uses the internet to provide virtualized computing resources. The cloud provider controls IT infrastructures such as storage, server, and networking resources, and also offers them to subscribe companies via virtual machines, accessible over the internet in the IaaS model. For businesses, it can provide numerous advantages, including the ability to make tasks faster, easier, more flexible, and less expensive. Now, let's have a look at the working of IaaS. Users connect to resources and services across a wide area network, such as the internet, and then use the cloud provider's services to complete the application stack. The user can, for example, log into the infrastructure as a service platform to build virtual machines, install operating systems in each VM, deploy middleware such as databases, create storage buckets for workloads and backups, and install the enterprise workload onto that virtual machine. Customers can then track cost, monitor performance, balance network traffic, solve application difficulties, and manage disaster recovery using the provider's service. So moving ahead, let's go through its advantages and disadvantages. Advantages. Organizations select infrastructure as a service because operating a workload without having to buy, manage, and support the underlying infrastructure is frequently easier, faster, and more cost-effective. A company can rent or lease infrastructure from another company using infrastructure as a service. For workloads that are transitory, experimental, or change abruptly, it is an effective cloud service paradigm. For example, if a company is creating a new software product, hiring an IaaS provider to host and test the application may be more cost effective. Once the new software has been thoroughly tested and refined, the company can move it away from the IaaS environment and into a more traditional in-house deployment. If the expenses of a long-term commitment are lower, the organization could commit the piece of software to a long-term IaaS deployment. Now, disadvantages. Billing can be a challenge for some firms. Despite its flexible pay-as-you-go model, cloud invoicing is quite detailed and it is broken down to reflect specific service usage. When evaluating the invoices for each resource and service involved in application deployment, users frequently experience sticker shock or discover expenses that are greater than expected. Another issue it faces is lack of insight because its providers own the infrastructure. The configuration and performance of that infrastructure are rarely transparent to its consumers. Users may find it more difficult to operate and monitor systems due to the lack of transparency. Users of infrastructure as a service are also concerned about service availability and reliability. The supplier has a big influence on the workload's availability and performance. The workloads of users will be impacted if a provider has network constraint or any other type of internal or external outage. Furthermore, because it is a multi-tenant design, the problem of noisy neighbors might have an adverse effect on users' workloads. So now these are the top infrastructure as a service providers. Linode is a privately held cloud hosting firm based in the United States that offers virtual private servers. Hostwinds, web hosting, cloud hosting, and dedicated server options are all available from Hostwinds. Microsoft Azure is a cloud computing service operated by Microsoft for application management via Microsoft Managed Data Centers. DigitalOcean offers developers cloud service that make it easy to deploy and grow programs that run on several machines at the same time. Alibaba Cloud is a cloud computing firm that serves online businesses as well as Alibaba's own e-commerce ecosystem. So the second service is platform as a service. What is platform as a service? Platform as a service products which are geared towards software development teams include computing and storage infrastructure, as well as development platform layer that includes web servers, database management systems, and software development kits for multiple programming languages. Working of platform as a service. For software development, it does not replace an organization's complete IT infrastructure. It's made possible by the hosted infrastructure of a cloud service provider. A web browser is the most common way for users to access the offerings. Platform as a service such as application hosting and Java development can be supplied via public, private, or hybrid clouds. So now let's look into the advantages and disadvantages. Advantages. The main advantage of platform as a service for users is its simplicity and convenience. Much of the infrastructure and other IT services will be provided by the platform as a service provider, which users can access from anywhere via a web browser. The flexibility to pay on a per-use basis allows businesses to forego the capital costs associated with on-premises gear and software. Many platform as a service solutions are aimed towards software developers. These platform provide computation and storage infrastructures as well as text editing, version management, compilation, and testing capabilities to assist developers in swiftly and efficiently developing new software. Coming to the disadvantages, platform as a service, on the other hand, can cause issues with service availability and resilience. Customers may suffer as a result of a service outage or other infrastructure interruption, which might result in costly productivity losses. Its suppliers, on the other hand, will typically deliver reasonably high uptimes. Another widespread problem is vendor lock-in, which occurs when users are unable to simply transition many of their services and data from one platform as a service solution to another. When choosing a provider, users must consider the business risk of service outages and vendor lock-in. Internal changes to a platform as a service product could also be a problem. The impact on users might be tough and disruptive. If a platform as a service provider ceases supporting a programming language or chooses to use a different set of development tools. So let's have a look at the top platform as a service provider. IBM Cloud Computing refers to a set of cloud computing services for businesses provided by IBM, a technology corporation. Red Hat is a collection of tightly integrated Red Hat technologies for building cloud infrastructure and developing cloud-native apps on premises. Elastic Beanstalk, AWS Elastic Beanstalk, is an Amazon Web Services application deployment orchestration solution. Salesforce offers CRM services as well as enterprise applications for customer service, marketing, automation, analytics, and application development. And Software AG Cloud is an open and independent cloud platform that serves as your one-stop shop for all software AG has to offer in the cloud. Now coming to the next service, which is software as a service. So what is software as a service? Customer relationship management or CRM, marketing automation, and business analytics are just a few of the application level services offered by software as a service companies. So how does it work? The provider gives consumers network-based access to a single copy of an application that the provider designed expressly for software as a service distribution in the software on demand model. The source code for the program is the same for all clients, and new features or functionalities are rolled out to all the users at the same time. The data of each model's customer may be stored locally in the cloud or both locally in the cloud, depending on the service level agreement. Coming to its advantages, customers subscribe to a software as a service solution rather than buying and installing software or additional gear to support it. Many firms can now budget more effectively and predictably by converting costs to recurrent operating expenses. You can also cancel software as a service subscriptions at any time to avoid incurring recurring fees. Its systems are frequently customizable and can be connected with other corporate applications, particularly when using software for the same vendor. Vertical scalability is a feature of cloud services like software as a service, which allows clients to access more or fewer services or features on demand. Disadvantages of software as a service. When providers endure service delays, impose undesirable modifications to service offerings, or suffer a security breach, all of these things can have a significant impact on customers' ability to use the software as a service offering. Customers should be aware of their software as a service provider's SLA and ensure that it is followed. If the provider adopts a new version of an application, it will roll it out to all of its clients, whether or not they want it. This may need the organization allocating additional training time and resources. Switching vendors can be tough, as it is with any cloud service provider. Customers must migrate massive volumes of data when switching vendors. Furthermore, some vendors use technologies and data types which can make transferring client data between cloud providers even more difficult. So coming to the top companies that provide software as a service, Adobe is a collection of Adobe incorporation programs and services that provide user with access to software for graphic design, video editing, web development, and photography, as well as a set of mobile apps and certain optional cloud services. SAP is a platform as a service designed by SAP SE for developing new applications and enhancing existing ones in a secure cloud computing environment managed by SAP. Google Cloud. Google Cloud Platform is a set of cloud computing services provided by Google that run on the same infrastructure as Google's internal products, such as Google Search, Gmail, Drive, and YouTube. Freshworks Cloud Platform allows users to manage their identities and access across all of their Freshworks products. And Atlassian, advanced features such as a 99.9% uptime SLA, unlimited storage, and premium support provide teams the confidence to scale reliably. Now that we have all the in-depth information about different types of cloud computing services, let's move ahead and explore its benefits and features, which makes it so popular and convenient. First, the supplier hosts and maintains the site in their own facility. The cloud hosting provider acquires, hosts, and maintains the necessary hardware and software. Users avoid the construction expenditures and maintenance problem that would be incurred if the service was established on-premise. Second, self-service using a web-based interface. Through a web interface, service users can initiate certain service functions as well as increase or reduce their service consumption level with little or no intervention from the service provider. Third is, you must pay to utilize the facility. Users of the service only pay for the services they use. When compared to the typical method of building on-site IT capacities targeted for the highest usage situations and then having that capacity to go unused for the most of the time. This can result in significant cost savings. And the fourth one is scalability that comes close to being infinite. Cloud computing service providers usually have the infrastructure in place to deliver their services at a large scale. That means that cloud service consumers can readily accommodate business expansion or periodic surges in service usage. Well, this is all about cloud computing services.
Hello everybody, welcome to Simplilearn's AWS S3 Tutorial for Beginners. My name is Kent, and today I'm going to be covering these following points. I'm going to be covering what is cloud computing. I'm going to be showcasing what AWS is in terms of cloud computing, and I'm also going to be covering the core fundamental service of the Simple Storage Service, which is a object storage service. We're going to be covering the benefits of the Simple Storage Service, better known as S3, what objects and buckets are, and we're going to be seeing how things are working in the background and implementing that in terms of lab assisted demonstrations in order for you to see what those features of S3 are. And then we'll perform a wrap up of the material we've done in a conclusion. So let's get started. What is cloud computing? So here is a definition of cloud computing, but I'm going to paraphrase it. Cloud computing is nothing more than you gaining access to infrastructure through web services with a pay-as-you-go model. Now, this is a very, very different model than we're traditionally involved in on an on-prem data center. So when I mean on-prem, I'm saying on-premise. Okay, so you'll hear that a lot, on-prem. Now, when we are on on-premise data center, we have to provision lots of infrastructure even before we get started with deploying any type of application, whether it be a mobile application, a web application, etc., etc. So every application needs some sort of underlying infrastructure, whether that be bare bone servers, databases. They're obviously going to be needing some types of storage, etc., etc. So all this is something that we have to kind of fight against in order just to get started with deploying our application. So this takes usually, traditionally, depending on the size of the company, about 3 months to set up. So what if we could leverage all this infrastructure as a service, and just through some API call, that's what the web services is all about, we could provision a server or we could provision a database within minutes and then deploy any type of application that we want to on top of that stack, and also take advantage of any storage that we may want. We may want object level storage, which is what we're going to cover. We may want an elastic file system, right? So there are different types of storages that we're eventually going to look at as you go down your learning path with Simplilearn. So cloud computing is really about provisioning of all these kinds of services, but not only at the infrastructure level. We're going to see how we could move up the stack and get entire platforms as a service, or even softwares as a service. So what is AWS? Well, AWS is really a cloud computing platform that will offer us many services through these API calls. Some are, again, just bare infrastructure like a service. Other can be a service as a software, for example, email. So here we have an example of the public data storage. This is S3, the simple storage service icon that you're going to see over and over again. This is a representation of an actual bucket in S3. So this will become more clear as we continue the slide deck and actually reinforce this with some hands-on lab. But as you can imagine, you may want to provision a private software-defined network in the cloud. And so we can do that in AWS. We can provide load balancing. We could provide scalability in terms of auto-scaling groups that will respond to increased demand as your application, let's say, becomes more popular. You want that infrastructure to grow elastically. So doing this on premise is traditionally not only extremely expensive and thus prohibitive, but very difficult to implement physically speaking as well. So by going with a cloud provider like AWS, we can severely reduce the expense and the complexity of setting all of this up, because we're trading capital expense for variable expense. So capital expense is about you procuring all the hardware that you need beforehand and the budget being approved before even getting that hardware in through your door, right? And then you have to configure it. So there's that complexity factor. Whereas if you're doing this through AWS, you can within minutes just provision all of that very quickly. So you're also not paying for everything all up front. You're paying this with a pay as you go model. So very different. We're now removing what's called undifferentiated lifting, which is everybody has to do the same thing, but it's not really bringing any value to their end product. We all have to buy servers and configure them and scale them, etc., etc. So if we remove that element and have AWS handle that, we can concentrate on our business, which is our application, and improving that application and responding more to our clients' request. We can be more agile, more flexible. So all of this leads to these points that we see here on this slide. Much easier to use, much easier to get our application to market. We're actually going to be leveraging the physical security that AWS implements for us. They have data centers all over the world that we're going to plug into, and that physical security is already implemented for us. There are varying levels of security that we're going to get into through our AWS journey, but right off the bat, you know that you have physical security. Of course, we're going to be talking about storage in this demonstration or in this slide deck over here. But the nice thing is we only pay for what we use. So that's that variable expense that I was talking about that we've traded for capital expense. We can easily set up databases. We can easily automate our backups and have those backups stored in the cloud through that S3 storage that we're going to get into. Okay, so lots of benefits of going through AWS here. And it's also comprehensive and simple to use. Comprehensive meaning that there are hundreds and hundreds of services. It's going to be actually quite time consuming for you to just know what each service does in general, but you'll get there through your journey. It's all about sticking with it and learning something new every day, which is what Simplilearn is all about. Over here, we have infrastructure as a service, platform as a service, and software as a service. So these are three different types of distinctions we have in the cloud industry to basically cover what's going on here on the right-hand side. So on-premise, you're traditionally involved in everything from networking, which is you, for example, buying the switches, the routers, the cabling, everything all the way up the stack to deploying your application, and you see everything in between there. Okay, so this is a very time-consuming job. Not only that, but it costs a lot of money because you have to buy all these machines up front, and you have to have the individuals with the right knowledge to maintain all of this stack. All right, so different individuals in different teams maintaining this whole on-premise data center. You may also have different data centers deployed globally. So you can imagine the cost overhead of this. So everything in green is basically you're managing it. Now we can offset that and ask AWS to handle part of this stack over here. So on this second column over here, we see infrastructure as a service, which basically says, AWS, I want you to handle all the networking, my software-defined network. I want you to handle my storage, elasticity. I want you to handle my compute power, my virtual machines. I want you to handle even administrating those machines at a physical layer as well. And I want you to physically secure them. So this will allow you more time to focus on all the green up here. Of course, we can move up the stack and say, I even want AWS to take on more responsibility. And that would be more of a platform as a service where AWS would also install and maintain the operating system for you. So you can imagine things like new versions of operating systems, security patches, maintenance patches, all of the like, and any middleware or runtime that you have on top of that. Think of something like the Java virtual machine, perhaps, that needs to be updated. Now, you wouldn't be responsible for maintaining all of what's in orange over here. You would only be responsible for deploying your application and making sure that your data is saved and secured, right? So again, platform as a service is a more hands-off approach. So think of it as you wanted to set up a CI/CD deployment environment for your development team, and you want it to be very involved in just handling your application code and making sure that it was properly compiled, built, tested, and deployed, right? Well, this could be implemented as a platform as a service. Or you could take your code as a zip file and give it to AWS's service called Beanstalk, which would automatically deploy your code and make sure that it's highly available, scalable, and fault tolerant across all of the orange stack over here, right? So more of a hands-off approach. Of course, we can go all the way up the stack and tell AWS to take care of everything for us and just ask for a service, much like a utility, like electricity or water. We might want to say, we just want an email software service, and we're not really concerned about how the underlying operating system or servers or network are configured for that. We just want to use the software as a service. We don't want to administrate anything else. We just want to be sort of like an end user to it. So AWS will manage everything underneath the hood. So there are varying types of services. You pick and choose whichever one makes more sense for you and your team. So what is S3? S3 stands for Simple Storage Service, and it is an object storage service in Amazon. What this means is that it doesn't matter what kind of file you upload to S3, it will be treated as an abstraction, meaning an object. So you can upload a PDF file, you can upload a JPEG file, you can upload a database backup. It doesn't really matter. All that is abstracted away by the use of storing it within an object. We're going to talk more about what composes an object, but by doing so, what happens is S3 allows us to have industry leading scalability. So it doesn't matter if you're going to make a request for that database backup, let's say that object, 5 times or 10,000 times, that request, that demand will scale. The underlying infrastructure that is implemented behind the scenes is handled for you. So in a sense, it's kind of like a serverless service, a storage service where you're not implicated in handling anything underneath the covers. You're just uploading your objects and accessing them later on. In terms of data availability, very powerful as well, because it takes those objects and will replicate them across at least 3 availability zones. Of course, these availability zones have 1 or more data centers attached to them. So you have lots and lots of copies of your objects distributed globally, or at least at a regional, in a regional area. You can do this as well globally if you enable global replication. And you will see that your level of durability will skyrocket, and you're just not going to worry about losing an S3 object. Data security, well, we can encrypt our data at rest, our objects at rest. We can encrypt it in transit. We can also come up with security policies at the bucket level, which we're going to talk about what a bucket is very, very, very soon. These are going to be implemented through what's called IAM policies, and you're going to be able to control who or what has access to your objects. And of course, because everything is handled underneath the covers, all the servers, all the storage nodes are cloud optimized for the best possible performance. So let's continue on our journey on what is S3. We're going to take a look at what is a bucket and what is an object. As you can see here, you have inside this bucket, which is a logical container for an unlimited amount of objects. You could have objects of different shapes and sizes. Like I said, you could have pictures, database backups, etc. So this is what's being represented here by different shapes. And you can think of a bucket really as almost like a folder where objects or files are placed within them. So there are many ways for us to place objects within a bucket. We can do this through the AWS console, which I'll be showing you very shortly. We can do this via the command line interface, or we can do this through a software development kit. At the end of the day, all those 3 options go through an API, right? So it's all about picking the right method that is best suited for whatever kind of end user or application that needs access to these buckets and to these objects. Now, once you've got the data or objects within this bucket, you can control pretty much how the data is accessed, how it's stored, whether you want it to be encrypted, and how it's even managed. So you can have organizations that have specific compliance needs. For example, any objects that are placed in there, perhaps some PDFs, are not to be modified or not to be touched for 90 days. Let's say we can imply object locks if we want to. We can imply security guards. We can also, for example, record all API actions that try to access, to list, to delete any kind of API operations on those objects at the bucket level or on the object level, we can record if that is some sort of organizational compliance need for auditing or for whatever internal auditing reason that you may have. So continuing on here, you can see that there are many organizations that use S3. One in point is Amazon itself. S3 is so popular and so durable that Amazon internally uses it to store its own data. You're guaranteed, almost that you're not going to lose any object in there because it has what we call 11 nines durability. Now, 11 nines durability is really an extreme amount of durability where it's mathematically almost impossible for you to lose an object once you placed it in S3. You're in fact more liable to get hit by a meteorite than you are to lose an object in S3, statistically speaking, which is a pretty incredible statistic, but it's true. So if we continue here with the benefits of S3, some of these I've already described, but let's talk about the full picture here. We see the performance, scalability, availability, and durability of S3 are really first class in the industry. Again, durability, we were talking about that 11.9. So what that really means is 99.9999 in total. If you count all the nines, that's 11 of those nines. So most durable in the industry by far. And again, because everything is handled underneath the covers, it's a serverless service. They ensure the scalability and availability and the performance of the inner workings of that object level storage. Now, cost is of course always important, and S3 really shows up here with first class support again for cost. It's got very, very low cost. We can have object level storage for let's say a terabyte of object level storage for as little as $1 a month. So again, it will depend on the kind of storage class. We're going to have a discussion on different types of storage classes that we might want to transition or move over our objects from one storage class to the next, depending on how frequently accessed that data is. As you know, data over time seems to get less and less accessed as your needs shift from one place to another. We're going to talk about that coming up very soon. So we're going to want to really focus on that to reduce our end of the month costs for storage with S3. Of course, security is always at the forefront, and we want to make sure that we either simply secure by encrypting everything right off the bat, either at rest, in transit, or we want to put an object lock or just maintain security at the bucket level, maintaining, let's say, who or what has access to that data. Because by default, no one has access to the data unless we open up the door. And also we want to make sure that we don't give public access to our bucket for obvious reasons of giving away important information by mistake. So AWS makes it extremely difficult for you to accidentally do this. And I'm going to show this in a demonstration lab coming up very soon. And we can also query in place, which is very interesting. So you can imagine you putting, let's say, a file that's in CSV format or a JSON format or Parquet format, some sort of structured format or semi-structured format in S3, and you can actually use SQL queries on the spot to filter that data in place at the bucket level. You can also have other services that may want to extract some business intelligence from that data in your S3 bucket directly as well. So some other more advanced querying operations can take place at the S3 level. So this you will learn during your journey with Simplilearn as you're covering all the AWS technology stacks. And here, the most widely used storage cloud service in the industry. Because of all the points that we just covered, it really is the #1 storage or object level storage solution in the industry. Let's now take a look at objects and buckets in S3. So the objects are really the fundamental entities that are stored in S3, or the lowest common denominator, which means that we're not really interested in what kind of data is within the object at the layer of S3, because S3 doesn't have direct access to the data within an object. Like I said before, it's an abstraction of the data. So we don't know if it's a cat picture, if it's a backup of your database. It's just treated as a fundamental entity, aka the object. Now, every object is associated with metadata, so data about itself, things like what's the name of the object, what's the size, the time and date that the object was uploaded. Things of that nature are categorized as metadata. So S3 does have direct access to that. Now, the data within that object, of course, is accessible by other services. So it's not that once you've uploaded it, you've totally lost the data and it's only can be treated as an object. It's just that at this layer, it's simply just assigned metadata and a version ID, a unique version ID. And if you re-upload the exact same object a second or third time to S3, it will have its own version ID number. So a new unique version ID number will be generated. So really what buckets are their logical containers to store those objects. So of course, at an extremely high level, a bucket would be like your root file system, if you want to think about it like that. But that doesn't mean you can't go into this bucket and create separate folders. Now, when you create separate folders in a bucket, because you might want to logically organize all your objects, you might be fooled by the fact that you think this is a hierarchical storage system, when in fact it is not. And I'll talk about that in a second. So you cannot store an object without first storing it into a bucket. So of course, the first step would be for us to create a bucket and then upload objects within that bucket. So an object cannot exist without its container or its bucket. So there's no Windows Explorer view like we're used to in an operating system, because this is not a hierarchical view. No matter if you create folders within folders within folders, in fact, S3's internal architecture is a flat hierarchy. What we do instead is we assign prefixes, which are treated as folders, in order to logically organize our objects within our buckets. And I'm going to showcase a prefix in one of the demonstrations coming up very soon. So when you create, or when you're working with S3, first of all, you're working at a regional level. You're going to have to pick a region. For example, you might pick US East 1 region or US East 2 region, and the bucket that you're going to be creating will be replicated across several availability zones, but within that region. Also, that data, those objects, can be accessed globally because S3 uses the HTTP protocol. HTTP protocol is very permissive. Everybody knows how to administrate it and work with it. So we just need to give access to that object in terms of a permission policy and give it the proper URL, or give whoever needs access to it the proper URL, and they can access that via HTTP globally. So first, when you're creating a bucket, you have to select the region, and the object will live within that region, but that doesn't mean that it still can't be accessed globally. So let's now take a minute, go over to the AWS console, and actually let me showcase how to create objects and buckets. So for our first lab, we're going to be going and creating an S3 bucket and uploading an object to it. So we first have to log into the AWS console, which we have up here in the address bar. Let's click on either create free account if it's your very first time, or as in my case, already have an account, and we're going to sign in here. You're going to have to pass in your IAM username, password, and your account ID, of course. Once you've logged in, you can search for the simple storage service, S3, either by coming up here in the search box and typing S3 and you'll find it there. That's probably the easiest way. Or if you want, you can take a look at all the services and it'll be under storage over here, the first one. Okay, so pick whichever method you see best for yourself. Once we're here, we want to create our first bucket. Now I've already have a couple of buckets here, so we're going to go on and create a new bucket. The very first thing is you have to specify a bucket name. Now this bucket name has to be globally unique. If you take a look here at the region that we're in, it doesn't actually select a specific region. It selects the global option, which means that this bucket will become globally accessible. So that is why it needs to have a unique name, much like a DNS name has to be unique for your website, right? So I'm going to come up here and pick a name that I think is going to be unique. So I'm going to say Simplilearn S3 demo. All right, let's take a look at if that's going to work out. Of course, we have to pick a region, but it is globally accessible. So you either pick a region that's closest to your end users, or in our case, since we're just doing a demonstration, we can do whichever is closer to us right now. Okay, and we're going to skip these options for now. We're going to come back to them later on. We're just going to create the bucket. Now hopefully that was a unique name and allowed me to create that, and it looks like it did. So if I scroll down, you can see that it clearly got created over here. Now we're going to click on that and we're going to start uploading objects to this bucket. So let me click on the upload button, and you can either select one or more files, or you can select an entire folder. So I'm going to just go and select a specific cat picture that I have here. Okay, and again, we'll go through some of those other options later on, and we'll just click upload. Now this should take no time at all because of the fact that it's a very small object or file that's being uploaded. So it has succeeded. We can close this up. And we see now clearly that the object is in our bucket. If we go to properties, we can see the metadata associated with this bucket. We can see the region that it's in. We can see the ARN, which is the Amazon resource name, which uniquely identifies this resource, this bucket, across the globe. So if ever you needed to reference this, let's say in an IAM policy or whatever other service needed to communicate with S3, you would need this ARN. It's a very important piece of information. And of course, we have the creation date. Some high level metadata. So objects, as we have covered already, consist of not only the data itself, but the metadata. So there's lots of metadata, and there's a lot of other features that we can go here and enable very easily. And this will be the basis of the future demonstrations that I'm going to do. All right. So just to recap what we just did, we created a unique bucket, give it a name of Simplilearn S3 demo, and uploaded our first object to it. So let's now take a look at the inner workings of the Amazon S3. When we upload an object into a bucket, we have to select which one of these storage classes the object will reside in. So you see I have 6 storage classes here at the bottom, and each have their own characteristics that we're going to get into. By default, if you don't specify anything, it'll get placed in what's called the S3 standard storage class, which is the most expensive out of all these storage classes. Once your object gets colder, and what I mean by colder is your access patterns diminish, meaning that you're accessing that file less and less over the course of time, so it gets colder, you will transition that object from one tier to the next, all the way to, for example, S3 Deep Archive. So again, Deep Archive signifies extremely cold, so maybe you're only referencing this data once a year, once every couple of years. And so you want to have the cheapest possible storage available. So right now you can get about 1 terabyte of storage per month for about $1 a month with S3 Glacier Deep Archive. So you are going to be very interested in knowing how to transition from one or more of these storage classes over time in order to save on your storage costs. That's really why we're doing this. So let's go through some of these storage classes. By default, like I said, whenever you upload an object, you automatically get placed into the standard storage class. So any files that you're working on frequently, daily, this is the best fit for it. You've got the highest level of accessibility and durability as well. Not that the others don't have the same level of durability. However, we'll see how when you transition from one storage tier to the next, some characteristics do change in order for you to save on some costs. We're going to go through some of those. Now, this would be considered hot data, right? Data that's used all the time, maybe just by you, maybe by everybody, right? So that's the perfect place to place it in the standard storage class. Now, over time, like I said, you may find yourself working less and less, perhaps on a document that was due by the end of the month. That document was submitted, and then afterwards, you don't work on that document anymore. Perhaps you're only working on revisions based on feedback from your colleagues that are asking you to make some corrections or some amendments. And so only those corrections or amendments come in perhaps once a month. And so in that case, you might find yourself finding a justification for moving that document from the standard tier to the standard IA or infrequently accessed tier. Maybe any objects not modified for more than 30 days are a good fit for that. And that's really the criteria for IA, inactive access, is that S3 or AWS itself recommends to only put objects in there if they haven't been accessed for at least 30 days. So you get a price reduction, a rebate for putting objects that are not accessed frequently in here. Of course, if you remove objects, let's say before the 30-day limit, then you are charged a surcharge for retrieving an object that you said was infrequently accessed, but it really was not. So bear that in mind. If you're going to place objects in infrequent access, be somewhat reasonably assured that you're not going to be going there and accessing them. You can still access those files, no problem, just as quickly. They have the same level of accessibility and durability. However, like I said, anything less than 30 days, you'll get a price ding on that. If you want to have long-term storage, we're talking about Amazon Glacier. So this is more anything over 90 days that hasn't been modified, or 180 days. There's two subcategories of Amazon Glacier that we're going to get into. And this is the cheapest storage by far. And Amazon Glacier doesn't really operate through the AWS console as the same as the standard and the infrequent access. You can't really upload objects to Glacier via the console in the browser. You can only do so, let's say, through the command line interface or through an SDK. The only thing you can do on the web console with Glacier is actually create what's called a vault, which is a logical container for your archives. But then after that, you have to go through the CLI or the SDK to do the rest of the work there. If we continue on, there's some gray areas between the S3 standard and the Glacier. One is the one zone infrequently accessed storage class. So if we go back to the regular standard and IA storage class, all of these objects are stored across a minimum of 3 availability zones. If you want a further price reduction, you can store your objects in a one zone IA storage class, which means that instead of taking that object and replicating it across 3 or more availability zones, it will only store it in a single availability zone, therefore reducing the level of availability that you have to that object. So in this case here, if that single availability zone would go down, for example, you would not have access to that object. Once it would come back up, of course, you would. The other thing is if there was an immense catastrophe where the actual availability zone was destroyed, well, of course, then your object is also gone. So if that's something that doesn't worry you because you have already many copies of this object maybe lying around on premise, then this is a good option for you because it's data that you're willing to lose access to for short periods of time if ever that single availability zone goes down. So it's about an extra 20% off the price from already the normal IA standard price. There is another one called the standard reduced redundancy storage. This one is kind of getting phased out as we speak because the same price for this storage class is about the same amount you're going to pay for the normal IA standard class. What this does is, again, is a good fit for your objects that you're not really worried about losing if there is some sort of catastrophe that happens in an availability zone. There's less copies of it that are stored. And so if that data center and that availability zone goes down, then you lose your object. So of course, it offered at the time the highest price reduction possible, but now the difference between this one and the normal IA standard storage class is so small in terms of price that you're probably not going to migrate to or navigate to this storage class. But it is still there in the documentation, and it may very well come up still in the certification exam, so at least be aware of that. Let's now take a look at some individual features of S3, starting off with lifecycle management. So lifecycle management is very interesting because it allows us to come up with a predefined rule that will help us automate the transitioning of objects from one storage class to another without us having to manually copy things over. Of course, you could imagine how time consuming that would be if we had to do this manually. So we're going to see this very soon in a lab. However, let me discuss how this works. So once it's basically a graphical user interface. It's very, very simple to use once you come up with these lifecycle management rules. But you're going to define two things. You're going to define the transition action and the expiration action. So the transition action is going to be something like, well, I want to transition an object from, maybe it's all objects, or maybe it's just a specific type of object in a folder, example, that has a specific prefix, from one storage class, let's say standard, to standard inactive or infrequent access. Maybe only after 45 days, after at least a minimum of 30 days, like we spoke of before. And then maybe after 90 days, you want to transition the objects in IA to right away Glacier Deep Archive, or 180 days. You come up with whatever combination you see fit, okay? It doesn't have to be sequential from S3 to IA to one zone, etc., because like we discussed before, it depends what kind of objects that you're interested in putting in one zone, objects that you don't really mind losing if that one availability zone goes down. So you're going to be deciding those rules. It ends up that this even is not a simple task because you have to monitor your usage patterns to see which data is hot, which data is cold, and what's the best kind of lifecycle management to implement to reap the benefits of the lowest cost. So you have to put somebody on this job and make the best informed decisions based on your access patterns, and that is something that you need to consistently monitor. So what we can do is we can instead opt for something called S3 Intelligent Tiering, which basically analyzes your workload using machine learning algorithms. And after about a good 30 days of analyzing your access patterns, we'll automatically be able to transition your objects from S3 standard to S3 standard infrequent access. Okay, it doesn't go past the IA one, it doesn't go after the Glacier and whatnot. Okay, so it can then offer you that at a reduced price overhead. So there is a monitoring fee that is introduced in order to implement this feature. It's a very nominal, very, very low monitoring fee. And the nice thing is if ever you take out an object out of the infrequent access before the 30-day limit, as we spoke of before, you will not be charged an overhead charge because of that. Why? because you're using the intelligent tiering. You're already paying an overhead for the monitoring fee. So at least in that sense, the intelligent tiering will take the object out of IA and put it back into the S3 standard class if you need access to it before the 30 days. And in that case, you won't be charged that overhead. So that is something that is very good to do in order not to have to put somebody on that job. So yes, you're paying a little bit of overhead for that monitoring fee, but at the other side of the spectrum, you're not investing in somebody working many hours to monitor and put into place a system to monitor your data access patterns. So let's take a look at how to do this right now. Let's implement our own lifecycle management rules. So let's now create a lifecycle rule inside our bucket. First off, we're going to need to go to the management tab in the bucket that we just created. And right on the top, you see right away, lifecycle rule. We're going to create lifecycle rule and we're going to name it. So I'm just going to say something very simple, like simply learn lifecycle rule. And we have the option of creating this rule for every single object in the bucket, or we can limit the scope to a certain type of file, perhaps with a prefix like, I could see one right now, something like logs. So anything that we categorize as a log file will transition from one storage tier to the next as per our instructions. We're doing this because we really want to save on costs, right? It's not so much of organizing what's your older data versus your newer data. It's more about reducing that storage cost as your objects get less and less used. So in this case, logs are a good fit because perhaps you're using your logs for the first 30 days, you're sifting through them, you're trying to get insights on them, but then you kind of move them out of the way because they become old data and you don't need them anymore. So we're going to see how we can transition them to another pricing tier, another storage tier. We could also do this with object tags, which is a very powerful feature. And in the lifecycle rules action, you have to at least pick one of these options. Now, since we haven't enabled versioning yet, what I'm going to do is just select transition the current version of the object between these storage classes. So as a reminder of what we already covered in the slides, our storage classes are right over here. So the one that's missing is obviously the default standard storage class, which all objects are placed in by default. So what we're going to say is this. We want our objects that are in the default standard storage class to go to the standard inactive access storage class after 30 days. And that'll give us a nice discount on those objects being stored. Then we want to add another transition. And let's say we want to transition them to Glacier after 90 days. And then as a big finale, we want to go to Glacier Deep Archive. You can see the rest are grayed out. Wouldn't make sense to go back. And maybe after 180 days, we want to go there. Okay. Now there's a little bit of a warning or a call to attention here. They're saying if you're going to store very small files into Glacier, not a great idea. There's an overhead in terms of metadata that's added, and also there's an additional cost associated with storing small files in Glacier. So we're just going to acknowledge that. Of course, for the demonstration, that's fine. In real life, you don't want to store very big tar files or zip files that had, one or more log files in there. Okay, that would bypass that surcharge that you would get. And over here, you have the timeline summary of everything we selected up above. So we have here after 30 days, the standard inactive access, after 90 days, Glacier, and after 180 days, Glacier Deep Archive. So let's go and create that rule. All right, so we see that the rule is already enabled, and at any time you could go back and disable this if ever you had a reason to do so. We can easily delete it as well, or view the details and edit it as well. So if we go back to our bucket, now what I've done is created that prefix with the /logs. Since we're not doing this from the command line, we're going to create a logs folder over here that will fit that prefix. So we're going to create logs, create folder, And now we're going to upload our, let's say, Apache log files in here. So we're going to upload one demonstration Apache log file that I've created with just one line in there, of course, just for demonstration purposes. We're going to upload that. And now we have, we're going to just close that. And now we have our Apache log file in there. So what's going to happen, because we have that lifecycle rule in place, after 30 days, any file that has the logs prefix, or basically is placed inside this folder, will be transitioned as per that lifecycle rule policy that we just created. So congratulations, you just created your first S3 lifecycle rule policy. Let's now move over to bucket policies. So bucket policies are going to allow or deny access to not only the bucket itself, but the objects within those buckets to either specific users or other services that are inside the AWS network. Now, these policies fall under the category of IAM policy. So IAM stands for Identity and Access Management. And this is a whole other topic that deals with security at large. So there are no services in AWS which are allowed to access other services or data, for example, within S3 without you explicitly allowing it through these IAM policies. So one of the ways we do that is by attaching one of these policies which are written in a JSON format. So it's a text file that we write. At the end of the day, that's the artifact, and that's a good thing because we can use that artifact and we can configuration control it in our source control and version it and put it alongside our source code. So when we deploy everything, it is part of our deployment package. So in this case here, we have several ways of doing this. We can use what's called the policy generator, which is a graphical user interface that allows us to simply click and point and populate certain text boxes, which will then generate that JSON document that will allow us to attach that to our S3 bucket. And that will determine, like I said, which users or services have access to whatever API actions are available for that resource. So we might say we want certain users to be able just to list the contents of this bucket, not necessarily be able to delete or upload new objects into that bucket. So you can get very fine-grained permissions based on the kind of actions you want to allow on this resource. So in order to really bring this home, let's go and perform our very own lab on this. Let's now see how to create an S3 bucket policy. Going back to our bucket, we're now going to go into permissions. So the whole point of coming up with a bucket policy is that we want to control who or what, the what being other services, have access to our bucket and our objects within our bucket. So there are several ways we can go about doing this. Let's edit a bucket policy. One, we can go and look at a whole bunch of pre-canned examples, which is a good thing to do. Two, we could actually go in here and code the JSON document ourselves, which is much more difficult, of course. So what we're going to do is we're going to look at a policy generator, which is really a form-based graphical user interface that allows us to generate, through the answers that we're going to give here, the JSON document for us. First question is, we got to select the policy type. Of course, we're dealing with S3, so it makes sense for us to create an S3 bucket policy. The two options available to us are allowing or denying access to our S3 bucket. Now, in this case here, we could get really fine-grained and specify certain kinds of services or certain kinds of users. But for the demonstration, we're just going to select star, which means anything or anybody can access this S3 bucket. All right. Now, depending on also the actions that we're going to allow. So in this case here, we can get very fine-grained, and we have all these checkboxes that we can check off to give access to certain kind of API action. So we can say we want to give access to, just deleting the bucket, which obviously is something very powerful, but you can get more fine-grained. As you can see, you have more of the getters over here, and you have more of the listing and the putting new objects in there as well. So you can get very fine-grained. Now, for demonstration purposes, we're going to say all actions. So this is a very broad and wide-ranging permission, something that you really should think twice about before doing. We're basically saying we want to allow everybody and anything, any service, all API actions on this S3 bucket. So that's no small thing. We need to specify the Amazon resource name, the ARN of that bucket specifically. So what we're going to do is go back to our bucket, and you can see here the bucket ARN. Okay, so we're just going to copy this, paste it in this policy generator, and just say add statement. You can see here kind of a resume of what we just did, and we're going to say generate policy. And this is where it creates for us, and make this a little bit bigger for us, it creates that JSON document. So we're going to take this, we're going to copy it, and we're going to paste it into the generator. Okay. Now, of course, we could flip this and change this to a deny, right? Which would basically say we don't want anybody to have access, or anything, any other service to have access to this S3 bucket. We could even say /* to also encapsulate all the objects within that bucket. So if I save this right now, you have a very ironclad S3 bucket policy, which basically denies all access to this bucket and the objects within. Of course, this is on the other side of the spectrum, very, very secure. So we might want to, for example, host a static website through our S3 bucket. So in this case here, allowing access would make more sense, right? So if I save changes, you see that we get an error here saying that we don't have permissions to do this. And the reason for that is because it realizes that this is extremely permissive. So in order to give access to every single object within this bucket, as in the case that I was stating of a static website being hosted on your S3 bucket, it would be much better to also at first enable that option. So I'm just going to duplicate the tab here. And once you go back to the permissions tab, one of the first things that shows up is this block public access setting, right? Right now it's completely blocked, and that's what's stopping us from saving our policy. We would have to go in here, unblock it, and save it, right? And it's also kind of like a double clutch feature. You have to confirm that just so you don't do that by accident, right? So now what you've effectively done is you've really opened up the floodgates to have public access to this bucket. It's something that can't be accidentally done. It's kind of like having to perform these two actions before the public access can be granted. Now, historically, this was something that AWS was guilty of, was making it too easy to have public access. So now we have this double clutch. Now that this is enabled or turned off, we can now save our changes here successfully. And you could see here that now it's publicly accessible, which is a big red flag that perhaps this is not something that you're interested in doing. Now, if you're hosting a public website and you want everybody just to have read access to every single object in your bucket, yes, this is fine. However, please make sure that you pay very close attention to this type of access flagged over here on the console. So congratulations, you just got introduced to your first bucket policy, a permissive one, but at least now you know how to go through that graphical user interface through the policy generator and create them and paste them inside your S3 bucket policy pane. So let's continue on with data encryption. So any data that you place in S3 bucket can be encrypted at rest very easily using an AES 256 encryption key. So we can have server-side encryption. We could have AWS handle all the encryption for us, and the decryption will also be handled by AWS when we request our objects later on. But we could also have client-side encryption where we, the client that are uploading the object, have to be responsible for also passing over our own generated key that will eventually be used by AWS to then encrypt that object on the bucket side. Of course, once that happens, then the key is discarded, the client key is discarded, and you have to be very mindful that since you've decided to handle your own encryption, client-side encryption, that if ever you lose those keys, well, that data is not going to be recoverable in that bucket on the AWS network. So be very careful on that point. We can also have a very useful feature called versioning, which will allow you to have a history of all the changes of an object over time. So versioning sounds exactly how it's named. Every time you make a modification to a file and upload that new version to S3, it will have a brand new version ID associated with that. So over time, you get a sort of stack of a history of all the file changes over time. So you can see here at the bottom, you have an ID with all these ones, and then an ID with 121212. So eventually, if ever you wanted to revert back to a previous version, you could do so by accessing one of those previous versions. Of course, versioning is not an option that's enabled by default. You have to go ahead and enable that yourself. It is an extremely simple thing to do. And so there may be a situation where you already have objects within your buckets and you only then enable versioning. Well, versioning would only apply to the new objects that would get uploaded from the point that you enabled versioning. The objects that were there before that point will not get a specific version number attached. In fact, they will have a sort of null marker version number that will get attached to them. It's only after that you modify those objects later on and upload a new version that they will get their own version numbers. So right now, what we're going to be doing is a lab on actual versioning. So let's go ahead and do that right now. In this lab, we're going to see how to enable versioning in our buckets. Enable versioning is very easy. We're simply going to click on our bucket, go into properties, and there is going to be a bucket versioning section. We're going to click on edit and enable it. Once that's done, any new objects that are uploaded to that S3 bucket will now benefit from being tracked by a version number. So if you upload objects with the same file name after that, they'll each have a different version number. So you'll have version tracking, a history of the changes for that object. Let's actually go there and upload a new file. I'll upload one called index.html. So we're going to simulate a situation where we've decided we're going to use an S3 bucket as the source of our static website to deploy one. And in this index.html file, if you take a look right now, let's take a look at what's in there. You can see that we have welcome to my website and we're at version 2. Okay, so if I click on this file right now and I go to versions, I can clearly see that there's some version activity that's happening here. Okay, we have here at 1456, which is the latest one is on the top, the current version, we have a specific version ID. And then we have a sort of history of what's going on here. Now, I purposely enabled versioning before and then tried to delete versioning or disable versioning. But here's the thing with versioning. You cannot disable it fully once it's enabled. You can only suspend it. right? Now, suspending means that whatever version numbers those objects had before you decided to suspend it will remain. So you can see I have an older version here that has an older version number. And at this point here, I decided to suspend versioning. And so what it does, instead of disabling the entire history, it puts what's called a delete marker. Okay. You could always roll back to that version if you want. Now, in the demonstration, when we started it together, I enabled it again. So you can see this is actually the brand new version number as we did it together, but you don't lose the history of previous versioning if ever you had suspended it before. So that's something to keep in mind, right? And it'll come up in the exam where they'll ask you, can you actually disable versioning once it's enabled? And the answer is no, you can only suspend it and your history is still maintained. Now, we have that version there, and let's say I come to this file and I want to upgrade this, I don't know, I say version 3, right? And now what's going to happen is if I click on this version, just as the current one with version 2, and I open this, we should see version 2, which is fine. That's expected. If we go back to our bucket and upload that new version file that has version 3 in there, the one I just modified, we should now see in that index.html file a brand new version that was created under the versions tab. And there you go, 1458, just 2 minutes after. You can see here we have a brand new version ID, right? And if I open this one, you can see version 3. So now you have a way to enable versioning very easily in your buckets. And you also have seen what happens when you want to suspend versioning, what happens to the history of those versions files before. Just to actually go back here to the properties where we enabled versioning in the first place, if I want to go back in here and disable it, like I said, you can't disable, you can only suspend. And that's where that delete marker gets placed, but all your previous versions retain their version ID. So don't forget that, because that will definitely be a question on your exam if you're interested in taking the certification exam. So congratulations, you just learned how to enable versioning. Let's move on to cross-region replication, or CRR as it is known. There will be many times when you find yourself with objects in a bucket and you want to share those objects with another bucket. Now that other bucket could be within the same account, could be within another account within the same region, or could be within a separate account in a different region. So there's varying levels of degree there. The good thing is all of those combinations are available. So CRR, if we're talking about cross-region replication, is really about replicating objects across regions, something that is not enabled by default because that will incur a replication charge because it's syncing objects across regions. Of course, you are spanning a very wide area network in that case, so there is a surcharge for that. Now, doing so is quite simple to do, but one of the things that we have to be mindful of is to give permissions for the source bucket, which has the originals, to allow for this copying of objects to the destination bucket. So if we're doing this across regions, of course, we would have to come up with IAM policies, and we would also have to exchange credentials in terms of IAM user credentials, in terms of account IDs and the such. We're going to be doing a demonstration in the same account, in the same region, but largely this would be the same steps if we were going to go cross region. So this is something you might find yourself doing if you want to share data with other entities in your company. Maybe you're a multinational and you want to have all your log files copied over to another bucket in another region for another team to analyze, to extract business insights from. Or it might just be that you want to aggregate data in a separate data lake in an S3 bucket in another region, or in like I said, it could be even in the same region or in the same account. So it's all about organizing, moving data around across objects, across these boundaries. And let's actually go through a demonstration and see how we can do CRR. Let's now see how we can perform cross-region replication. We're going to take all the new objects that are going to be uploaded in the Simplilearn S3 demo bucket, and we're going to replicate them into a destination bucket. So what we're first going to do is create a new bucket, okay? And we'll just tack on the number 2 here. And this will be our destination bucket where all those objects will be replicated to. We're going to demonstrate this within the same account, but it's the exact same steps when doing this across regions. One of the requirements when performing cross-region replication is to enable versioning. So if you don't do this, you can do it at a later time, but it is necessary to enable it at some point in time before coming up with a cross-region replication rule. All right, so let me create that bucket. And now after the bucket is created, I want to go to the source bucket and I want to configure under the management tab here a replication rule. So I'm going to create a replication rule, call it Simplilearn rep rule. And I'm going to enable this right off the bat. The source bucket, of course, is the Simplilearn S3 demo. We could apply this to all objects in the bucket or perform a filter once again. Let's keep it simple this time and apply to all objects in the bucket. Of course, caveat here, this will only now apply to any new objects that are uploaded into this source bucket and not the ones that are already pre-existing there. Okay. Now, in terms of a destination bucket, we want to select the one we just created. So we can choose a bucket in this account, or if we really want to go cross region or another account in another region, we could specify this and put in the account ID and the bucket name in that other account. So we're going to stay in the same account. We're going to browse and select the newly created bucket. And we're also going to need permissions for the source bucket to dump those objects into the destination bucket. So we can either create the role ahead of time, or we can ask this user interface to create a new role for us. So we'll opt for that. And we'll skip these additional features over here that we're not going to talk about in this demonstration. We're just going to save this. So that will create our replication rule that is automatically enabled for us right now. So let's take a look at the overview here. You can see it's been enabled. Just to double check, the destination bucket is the demo 2. We're talking about the same region. And again, here we could opt for additional parameters like different storage classes in the destination bucket that object is going to be deposited in, et cetera, et cetera. For now, we just created a simple rule. Now, if we go back to the original source bucket, which we're in right now, and we upload a new file, which will be a transactions file in a CSV format, once this is uploaded, that cross-region replication rule will kick in and will eventually, right, it's not immediate, but will eventually copy the file inside the demo 2 bucket. Now I know it's not there already, so what I'm going to do is pause the video and come back in 2 minutes, and when I click on this, the file should be in there. Okay, so let's now double check and make sure that object has been replicated. And there it is, been replicated as per our rule. So congratulations, you just learned how to perform your first same account S3 bucket region replication rule. Let's now take a look at transfer acceleration. So transfer acceleration is all about giving your end users the best possible experience when they're accessing information in your bucket. So you want to give them the lowest latency possible. You can imagine if you were serving a website and you wanted people to have the lowest latency possible. Of course, that's something that's very desirable. So in terms of traversing long distances, if you have your bucket that is in, for example, the US East 1 region in the United States, in the Virginia region, and you had users, let's say in London, that want to access those objects, of course, they would have to traverse a longer distance than users that were based in the United States. And so if you wanted to bring those objects closer to them in terms of latency, then we could take advantage of what's called the Amazon CloudFront Delivery Network, the CDN network, which extends the AWS backbone by providing what's called edge locations. So edge locations are really data centers that are placed in major city centers where our end users mostly are located, more densely populated areas, and your objects will be cached in those locations. So if we go back to the example of your end users being in London, well, they would be accessing a cached copy of those objects that were stored in the original bucket in the, for example, US East 1 region. Of course, you will get most likely a dramatic performance increase by enabling transfer acceleration. It's very simple to enable this. Just bear in mind that when you do so, that you will incur a charge for using this feature. The best thing to do is to show you how to go ahead and do this. So let's do that right now. Let's now take a look at how to enable transfer acceleration on our Simplilearn S3 demo bucket. By simply going to the Properties tab, we can scroll down and look for a heading called Transfer Acceleration over here, and very simply just enable it. So what does this do? This allows us to take advantage of what's called the Content Delivery Network, the CDN, which extends the AWS network backbone. The CDN network is strategically placed into more densely populated areas, for example, major city centers. And so if your end users are situated in these more densely populated areas, they will reap the benefits of having transfer acceleration enabled because the latency that they will experience will be severely decreased. So their performance is going to be enhanced. If we take a look at the speed comparison page for transfer acceleration, we can see that once the page is finished loading, it's going to do a comparison. It's going to perform, first of all, what's called a multi-part upload, and it's going to see how fast that upload was done with or without transfer acceleration enabled. Now, this is relative to where I am running this test. So right now I'm actually running it from Europe. So you can see that I'm getting very, very good results if I would enable transfer acceleration and my users were based in Virginia. So of course, now I have varying differences in percentage as I go closer or further away from my region where my bucket or my browser is being referenced. So you can see here, United States, I'm getting pretty good percentages. As I go closer to Europe, it gets lower, of course, but still very, very good. Frankfurt, again, this is about probably the worst I'm going to be getting here since I'm situated in Europe. And of course, as I go look more towards the Asian regions, you can see once again it kind of scales up in terms of better performance. So of course, this is an optional feature. Once you enable it, as I just showed over here, this is a feature that you pay additionally for. So bear that in mind. Make sure that you take a look at the pricing page in order to figure out how much this is going to cost you. So that is it. Congratulations. You just learned how to simply enable transfer acceleration to lower the latency from the end user's point of view. We're now ready to wrap things up in our conclusion and go over at a very high level what we just spoke about. So we talked about what S3 is, which is a core service, one of the original services published by AWS in order for us to have unlimited object storage in a secure, scalable, and durable fashion. We took a look at other aspects of S3 in terms of the benefits. We mainly focused on the cost savings that we can attain in S3 by looking at different storage classes. Now, of course, S3 is industry recognized as one of the cheapest object storage services out there that has the most features available. We saw what goes into the object storage in terms of creating first our buckets, which are our containers, high-level containers in order for us to store our objects in. Again, objects are really an abstraction of the type of data that are in there, as well as the metadata associated with those objects. We took a look at the different storage tiers, the default being the standard, all the way till the cheapest one, which is the Glacier, which are meant for long-term archived objects. For example, log files that you may hold on to for a couple of years, may not need to access routinely, and will have the cheapest pricing option by far. So we have many pricing tiers, and if you want to transition from one tier to the next, you would implement a lifecycle policy or use the intelligent tiering option that can do much of this for you. We took a look at some very interesting features, starting from the lifecycle management policies that we just talked about, all the way to versioning, cross-region replication, and transfer acceleration. So with this conclusion, you are now ready to at least start working with S3. Hello everybody, my name is Kent, and today we're going to be covering AWS Identity and Access Management, also known as IAM, tutorial by Simplilearn. So these are the topics which we'll be covering today. We'll be defining what AWS security is, the different types of security in AWS, what exactly is identity and access management, the benefits of identity and access management, how IAM works, its components, its features, and at the end, we're going to do a great demo on IAM with multi-factor authentication and users and groups. So without any further ado, let's get started. So let's get started with what is AWS security. Your organization may span many regions or many accounts, and you may encompass hundreds, if not thousands, of different types of resources that need to be secured. And therefore, you're going to need a way to secure all that sensitive data in a consistent way across all those accounts in your organization while meeting any compliancy and confidentiality standards that have to be met. So for example, if you're dealing with healthcare data or credit card information or personal identification information like addresses, this is something that needs to be thought out across your organization. So of course we have individual services in AWS, which we will explore in this video. However, in order to govern the whole process at an organizational level, we have AWS Security Hub. Now, AWS Security Hub is known as a CSPM, which stands for a Cloud Security Posture Management Tool. So what does that really mean? Well, it's going to encompass, like I said, all these tools underneath the hood in order to bring a streamlined way for you to organize and adhere to these standards across your organization. It'll identify any misconfiguration issues and compliance risks by continuously monitoring your cloud infrastructure for the gaps in your security policy reinforcements. Now, why is that important? Well, these misconfigurations can lead to unwanted data breaches and also data leakages. So in order to govern this at a very high level, like I said, we need to incorporate AWS Security Hub that will automate and manage all these underlying services for us in order to perhaps take automated action. We call that remediary actions. And you can approve these actions manually, or you can automate those actions as you see fit across your organization. So let's delve a little bit deeper into what is AWS security, and then we'll start looking individually at some of these services. And so our organization has special needs across different projects and environments. So of course, the production, development, test environments, all are going to have their own unique needs. However, it doesn't matter which project or which business unit we're talking about and what are their storage backups needs. They should all be implemented in a concise, standardized way across your organization to meet that compliancy we were just talking about. So we want to automate all these tedious manual tasks that we've been doing, like ensuring that perhaps our buckets in S3 are all encrypted or all our EBS volumes are encrypted. And we want to have an automated process in place in order to give us time on other aspects of our business, perhaps our application development, to bring better business value. And that allows us to grow and innovate the company in a way that's best suited for it. So let's take a look at the different types of AWS security. Now, there are many different types of security services out there. However, we're going to concentrate primarily on IAM in this video tutorial. So I like to think of IAM as the glue between all AWS services, because by default, we don't have permission for any one service to communicate with another. So let's just take, for example, an EC2 instance that wants to retrieve an object from S3. Well, those two services could not interact unless we interacted with IAM. So something that's extremely important to learn. And by the end of this video tutorial, you'll be able to understand what IAM is. We have Amazon Guard Duty here, which is all about logs. Basically aggregates all logs from, example, CloudTrail, which we still haven't talked about. It's at the end of this list over here. But instead of looking at CloudTrail individually, Guard Duty will actually take a look at CloudTrail will take a look at your VPC flow logs, and we'll take a look at your DNS logs and monitor that account and your network and your data access via machine learning algorithms. And it'll ID any threat where you can automatically remediate the workflow that you've approved. So for example, if you know of a malicious IP address that's making API calls, well, those API calls are registered in CloudTrail, right? So this machine learning algorithm will be able to detect that and take action. So this is really governed at a higher level than you having to individually inspect all your DNS logs, flow logs, and CloudTrails individually and take action through some scripting fashion that you've come up with. So Guard Duty manages all that. We have Amazon Macie, which once again uses machine learning, but also uses pattern matching. Pattern matching can be used with matching kind of libraries that are already in place, or you can come up with your own pattern matching, and that's used to discover and protect your sensitive data. So for example, if you had healthcare data, also known as HIPAA compliancy, or credit card data that's lying around, well, Macie will discover it and will protect it. So as your data grows across your organization, that might be harder and harder to do in your own way. So Macie really facilitates discovering and protecting that, so you can concentrate on other things. AWS Config is something that kind of works in tandem with all the other services. It's able to continuously monitor your resources configurations and ensure that they match your desired configuration. So for example, maybe you state that your S3 bucket should be encrypted by default, all of them, or you want to make sure that your IAM user access keys are rotated. And if they're not, then take remediary action. So a lot of these automated remediary actions, right, are basically executed via AWS Config. So you'll see the AWS Config actually used by other services underneath the hood. And then you have CloudTrail. CloudTrail is all about logging every single type of API call that's made. So it'll always record the API call, who made it, from what source IP, the parameters that were sent with the API, the response, all that data, which is really a gold mine for you to investigate if there's any security threat. And again, this trail over here, and there can be many, and there's lots and lots of data generated by these trails, can be analyzed by these other services, specifically Guard Duty here, that automates that process so you don't have to. So let's get to the next one, which is, what is identity and access management? So what is IAM? Like I said, IAM is the glue between all AWS services. It will allow those services to communicate with each other once you put IAM into place. The other thing is it allows us to manage our AWS users, which are known as IAM users, and group them together into groups to facilitate assigning and retrieving or removing permissions from them instead of doing it on an individual scale. So of course, if you had 200 IAM users and you wanted in one shot to add a permission to a group that contained 200 IAM users, well, you can do that in one operation instead of 200. Now we do have a distinction between IAM users and end users. End users use applications online, whereas IAM users are your employees in your organization that are interacting directly with AWS resources. So for example, an EC2 instance would be a resource that, let's say, a developer would be interacting with. And traditionally, those are resources that are used full-time from 9 to 5, let's say, 5 days a week, 365 days a year, okay? Now, sometimes those users have to have elevated permissions for a temporary amount of time, and that is more suited for a role. And that will eliminate the need to create separate accounts just for, type of actions that are needed for, let's say, an hour a month or 2 hours a week or something like that. Something like backing up an EC2 instance, removing some files, doing some cleanups. Traditionally, you don't have those permissions as a developer, but you can be given temporary permissions to assume this role. So it's kind of like putting a hat on your head and pretending you're somebody that you're usually not for a temporary amount of time. Once you take off the hat, you go back to being your old boring IAM user self, which doesn't have access to performing backups or cleanups and stuff like that. So the roles interact with a service called a secure token service, which gives us specific keys, specifically an access key, a secret key, much like a username and password. And then we have a token key, which only gives you access to this role, this elevated permission, for 1 to 12 hours. So we'll talk more about roles as we go on through this video tutorial, but it's important that you at least remember at this point, even if you don't know all the details, that roles have to do with temporary permissions, elevated permissions. So what are the benefits of IAM? Well, across our organization, we're going to have many accounts, and like I said, hundreds if not thousands of resources. So scalability is going to be an issue if we don't have a very high level visibility and control over the entire security process. And once we have a tool like, for example, Security Hub, which we saw on the first slide, we can continuously monitor and maintain a standard across our organization. So very, very important to have that visibility. And we do when we integrate with AWS Security. Now, we also need to eliminate the human factor, right? So we don't want to manually put out fires every single time. Of course, there will be times when something new occurs that we've never seen before that will be needed. However, once an occurrence happens and reoccurs, we can obviously come up with a plan to remediate the action. So once we automate, we can definitely reduce the time to fix that reoccurring error, or it could be a new error that we don't have to interact with because we're using machine learning algorithm services like I was talking about, like GuardDuty or Macy. And we can really reduce the risk of security intrusions and data leakage and such by using IAM to facilitate this. Of course, you may have many compliance needs. You may be dealing with applications that use healthcare data or credit card information for payments, or you might be dealing with a government agency, let's say in the US, that has certain compliancy requirements that needs assurances that if their data is stored on the cloud, that you're still following the same compliance controls that you were, let's say, on premise. So we have a very, very long list of compliance requirements that each AWS service adheres to. And you can go on the AWS documentation online and you could figure out if, for example, DynamoDB is compliant with HIPAA compliancy. And it is. And so you can be assured that you can use that. So AWS itself has to constantly maintain these compliancy controls in place, and they themselves have to pass all these certifications. And that gets passed on to us. So much less work for us to implement these compliance controls. We can just inherit them by using AWS's security model by IAM. And last but not least, we can build the highest standards for privacy and data security. Now, having all this on our own on-premise data center poses security challenges, especially physical security challenges. You have to physically secure the data center. You might have security personnel that you need to hire, 24/7 camera surveillance, et cetera, et cetera. So just by migrating to the cloud, we can take advantage of AWS's global infrastructure. They're very, very good at building data centers. That's part of their business, and securing them. So of course we have a shared security model in place. However, you can rest assured that at least as the lowest common denominator, physical security has been put into place for us. Again, as other services are used, more managed services or more higher end services used in AWS, more and more of that security model will be AWS's responsibility and less yours. We will always have a certain type of responsibility for our applications, but we can again use these high-level services to ensure that our ability to encrypt the data at rest and in transit are always maintained by coming up with specific rules that need to be adhered to. And if those rules are not adhered to, then we have remediary actions that take place in order to maintain, again, that cross-account or organizational-wide security control. Okay, so lots of benefits of using IAM. And let's now take a look at exactly how IAM works and delve deeper into authentication and authorization. So there are certain terms here that we need to know about. One of them is principal. Now, principal is nothing more than an entity that is trying to interact with an AWS service, for example, an EC2 instance or an S3 bucket. Now, that could be a user, an IAM user. It could be even a service, or it could be a role. So we're going to take a look how principals need to be specified inside IAM policies. Authentication. So authentication is exactly how it sounds. Who are you? Could be something as simple as username and password, or it could involve an email address. Example, if you're the root user of the account when you're creating the account for the very first time. Other normal users will not need to log in with their user email. It'll only be the root user that needs that. You could also have developer type access, which needs access, let's say, via command line interface or a software development kit, also known as an SDK. Now, for those kind of access points, we're going to need access keys and secret keys, or public-private keys, let's say, if you want to even authenticate and log in through SSH to an EC2 instance. So there are many different types of authentication that we could set up when creating IAM users based on what kind of access they need. Do they just need access to the console? Do they need access to just services in terms of as a programmatic need? So those are different types of authentication. And then we have the actual request. Now, we could make a request in AWS through various ways. We're going to be exploring that via the console, the AWS console. However, every button you click, every drop-down list you select, that invokes an API call behind the scenes. So everything goes behind a centralized, well-documented API. Every service has an API. So if you're dealing with Lambda, let's say, well, Lambda has an API. If you're dealing with EC2, EC2 has an API. Now, you could interact with that API, like I said, via the console indirectly. You could use a command line interface. You can use an SDK for your favorite programming language like Python. So all of them get funneled through, all your requests get funneled through an API. But that doesn't mean you're allowed to do everything just because we know who you are and you have access to some keys, let's say, to make some API calls. You have to be authorized in order to perform certain actions. So maybe you're only authorized to communicate with DynamoDB, and also maybe you're only authorized to perform reads and not writes. So we can get some very fine-grained authorization through some IAM policies in order to control not only who has access to our AWS, but what they're allowed to do. So very fine-grained actions, read actions, write actions, both, maybe just describe or list some buckets. So depending on the AWS user that's logged in, we can control exactly what actions, because every API has fine-grained actions that we can control through IAM. And of course, many different types of resource. When we're coming up with these policies, all these actions can be grouped into resources. So perhaps we can say, well, this user only has access or read-only access to S3, specifically these buckets, and can write to DynamoDB table, but cannot terminate or shut down an EC2 instance. So all these kind of actions can be grouped into resources on a per resource basis based on the kind of role you have in the projects or in the company. So now let's take a look at the components of IAM. We've already seen that we can create IAM users and that how they are different than your normal end users. Now those entities represent a person that's working for an organization that can interact with AWS services. And some of those permissions that we assign through what's called identity-based policies to such a user will have permissions, for example, that are always necessary every time that they're logged in. So perhaps this user, Tom, always needs access to the following services over here, for example, an RDS instance or an S3 bucket, etc., etc. And sometimes they will need temporary access to other services, for example, DynamoDB. So in those cases, there would be a combination of normal IAM policies assigned to the user and certain assume role calls done at runtime in order to acquire this temporary credential, elevated permission. There is also the root user, which is different than your typical super user administrator access. There are some things that a root user can do that an administrator access cannot. For example, a root user, first of all, logs in with their email address and can also have the option to change that email address, something that is very tightly coupled to the AWS account. So you cannot change the email address with an administrator account. The other thing a root user can do is they can change the support contract. They can also view billing information or taxes information, VAT information, for example. So the best thing to do, the best practice is that once you've created your AWS account, you are obviously the root user. The best thing to do is to enable multi-factor authentication, store away those keys in a secure location, and your first administrative task should be to create an administrator super user, from which that point on you will log in as only an administrative user, and you will create other type of administrative users, and those administrative users will create other IAM users. So never log into your AWS account as a root user unless you need to access that specific functionality that I said that is over and above a super user administrator account. So here we have a set of IAM users, and we could assign to them directly IAM policies, which give them access to certain services. However, the best practice is to create groups, which is just a collection of IAM users. And suppose we have a developer group and a group of security administrators. Of course, we could assign different types of policies to that group, and every user that is assigned to the developer group will inherit those IAM permissions. Makes it much easier to manage your IAM users this way. And for the fact that also you can have users that can be assigned to groups, as you can see here, but what's not shown here that is possible as well is you could have a user that is part of two groups at the same time. The thing that you cannot have, though, is the notion of subgroup. So I can't extend this group and create a smaller group of developers out of this big group here. So we don't have hierarchical groups, but we do allow users to partake in different groups at the same time. So they will inherit those permissions, those IAM policy permissions from, for example, if user A was part of developers and user A was part of security, they would inherit these two policy statements over here. Now, there is another type of IAM policy, and that is called a resource-based policy. So resource-based policies are not attached directly to, for example, users, but they're attached more to resources like an S3 bucket, for example. And so when you have such a case, a user group can't be designated as a principal to a group. That's just one of the restrictions. However, there are other ways to get around that. As I said, when you think of an IAM role, I want you to think that these are temporary credentials that are acquired at runtime and are only good for a specific amount of time. Now, an IAM role is really made up of two components. We have what's called a trust policy. So who do you trust to assume this role? Who do you trust to even make an API call to assume the role? After that, we have an IAM policy. Once you've been trusted to assume the role and you get those temporary tokens, what are you allowed to do? Maybe you're allowed to have read-write access to the DynamoDB. So here we have no long-term credentials that are connected to role. You do not assign a role to a user. The user or service will assume the role via API call via the secure token service, STS. And with those temporary credentials, we'll then be able to access, for example, an EC2 instance if the IAM policy attached to the IAM role says that you can do so. So your users and your applications perhaps running on an EC2 instance and the AWS services themselves don't normally have access to the AWS resources, but through assuming a role, they can dynamically attain those permissions at runtime. So it's a very flexible model that'll allow you to bypass the need to embed security credentials all over the place and then have to maintain those credentials and make sure they're rotated and they're not acquired by anybody trying to find a security hole in your system. So from a maintenance point of view, they're really an excellent tool to use in your toolbox, your security toolbox. So let's take a look at the components of IAM. We have the IAM policy over here, which is really just a JSON document. And that JSON document will describe what this user can do if it's attached directly to it, or if the IAM policy is attached to the group, whatever user is attached to that group will also have the same policy inherited. So these are more long-term credentials in terms of, or permissions rather, that are attached to your login for the duration of your login, whereas roles are, as we've already stated, temporary. And again, once you've established a trust relationship, then we can assign a policy, for example, a policy that gives you only read-only access to a CloudTrail to a role. Now, it's up to the user to assume that role either through the console or through some programmatic means. Whichever way is performed, the user will have to make a direct or indirect call to STS for the assume role call. Now, these permissions are examined by AWS when a user submits a request. So this all happens at runtime dynamically. So when you change a policy, it will take effect pretty much immediately as soon as the user makes the next request. That new security policy, whether you just added or removed the permission, will take immediate effect. So what we're going to do now is just really quickly go to the AWS console and actually show you how an IAM policy looks like. So I've just logged into my AWS management console, and if I search for identity and access management, it should be the first one to show up. I'll just click on that. And I want to show you actually how these IAM policies look like. If you go to the left-hand side here, there's an entry for policies, and there are different types of policies that we can filter out. So let's filter them out by type. We have customer managed, we have AWS managed, and more in line with job functions that AWS managed also. So we're going to take a look at AWS Managed. All that means is that AWS has created and will actually update, maintain these pre-established and already vetted identity policies, IAM identity policies. So I could further down maybe look at all the S3 policies that are available, and we can see there are some that allows only read-only access. There are some that will give us full access. And there are, of course, other types here that we're not all going to explore, but let's just easily kind of take a look here at the full access. You can see it's just a JSON document. And of course, you cannot modify it since this is a managed policy. However, you can copy it and modify it. And in that case, it will become your own version of it. And so it'll be customer defined. And so when you go here and you do a filter, you can filter on your own customer managed policies. So over here, we are simply allowing certain actions, right? We talked about actions before that were based on API. So here we have an API that starts with S3. So this is for the S3 API. And instead of filtering out exactly specifically what API calls are there, we're basically saying all API calls. So star representing all API actions. And again, there is another category of S3 which deals with object Lambda, and we are allowing all operations on that specific API as well. We could, if this was our own customer managed policy, actually scale down on which resource, which bucket, let's say, or which folder in a bucket this would apply to. But in this case, since this is a full access, we're basically being given permission to execute every single API action under S3 for all buckets. We're going to see in the lab or the demonstration at the end of this tutorial that I'm going to show you how to scale that down. Okay, so that's how an IAM policy looks like. And if you want to assign an IAM policy to a user, well, stay tuned for the demonstration at the end of the video tutorial. What's not at the end of the video tutorial is really how to create a role. So I'll show you what a role is here. Again, there's a whole bunch of roles already set up that we can go and take a look at here. But we can go and create our own role as well. And I might create a role, for example, that gives in EC2, let's choose EC2, access to S3. So if I click EC2 and click Next Permissions, I can actually assign the S3 permission right over here. It's just a policy, just like we took a look at. Obviously assign it a tag and review it. And I'm just going to call this my EC2 role to S3. Create the role. And because I selected EC2 as a service, it automatically will include that in the trust policy. So now when I go and I create an EC2 instance, I can attach this role to that EC2 instance, and that EC2 instance will automatically be able to, if we're using the Linux 2AMI, let's say, have access to, or full admin access to, any S3 bucket in the AWS account. So let's go take a look at where we would actually attach that role on the EC2. So when you're creating an EC2, let's just say we go here, we say launch an EC2 instance, and we'll pick this AMI over here because it'll already include the packages necessary to perform the assume role call to STS for us, so we won't have to code that. And we don't have to embed any credential keys in order to get this running, which is really good, which is the whole point of what I'm doing, because by assuming a role, I don't have to manage that. And I'm just going to pick the free T2 micro. And it is here, once you pick whatever you need, whatever VPC and whatnot, that you come to the IAM role and you select the role to be assumed dynamically. Now I have a whole bunch of them here, but this is the one that I had created here, my EC2 role to S3. And if I go and I launch this EC2 instance, and then I had an application, let's say, that needed to contact S3, or even if I went on the command line of the EC2 instance, I would be able now to communicate with the S3 service because they being AWS, would actually use this role to perform an assume role call to get those temporary STS tokens for me, which will then allow me to access my IAM policy, which gives me full access to S3, and off I go. So this is a great way, like I said, to avoid having to administrate any embedded keys in this EC2 instance. And I could take this role away at any time as well. So there you have it, a little demonstration on how to create a role, how to attach it to an EC2 instance, and also how managed and customer managed policies look like in IAM. Of course, there is also the fact that we have multiple accounts, and so we could assign a policy that will also allow a user in another account access to our account. So cross-account access is something that's very well needed, and also is a feature of IAM. So when you need to share access to resources from one account to another in your organization, we are in need of an IAM policy to facilitate that. So also roles can come into play here for that. By also assigning granular permissions, we can make sure that we implement the concept or the best practice of the least privilege access. And also we have secure access to AWS resources, because by default, again, we have the principle of least privilege, and no service can communicate with another until we enable it via IAM. So very, very secure out of the box. Of course, if you want to add an additional layer of authentication, of security, we have multi-factor authentication rather, and that'll allow you to ensure through a hardware device, perhaps let's say a hardware token device, or your cell phone that has some software that generates a code, that will allow you to identify you are actually the person that is typing the username and password, and not somebody who's actually stolen your username and password. So at the end of this video tutorial, we will show you, or I will show you how to enable that. And of course, identity federation is a big thing, where your users may have been defined outside of AWS. You may have thousands of users that you've already defined, let's say in an Active Directory or in an LDAP environment on-prem, and you don't want to recreate all those users again in AWS as IAM users. So we can tie in, we can link the users, your user database that's on-prem, or even users that have been your user account that's been defined, let's say on a social site like Facebook or Twitter or Google, and tie that into your AWS account. And there is an exchange of information, there is a setup to do, but at the end of the day, it is either a role in combination with an IAM policy that will allow to map what you're allowed to do once you've been authenticated by an external system. So this has to do with perhaps like I said, LDAP or Active Directory, and you can tie that in with AWS SSO. There are many different services here that can be leveraged to facilitate what we call identity federation. And of course, IAM itself is free. So it's not a service per API request. AWS is very concerned to put security first, and so IAM is free. It's just the services that you use. For example, if you're securing an EC2, of course, that EC2 instance falls under the current pricing plan. So of course, compliance, like I mentioned, is extremely important, making sure that it's business as usual in the cloud. And so, for example, if you were using the payment card industry data security standard to make sure that you're storing and processing and transmitting credit card information appropriately, in order to do your business, well, you can be assured that the services you use in AWS are PCI DSS compliance. And there's many, many other types of compliance that AWS adheres to as well. So password policies, of course, are important. By default, we do have a password policy in place, but when you go to the IAM console, you're free to update that password policy, make it more restrictive based on whatever policy you have at your company. So many features, and so I think we're ready now to go into a full demonstration, and I will show you how to incorporate IAM users, groups, and also multi-factor authentication. So get ready, let's do it. I'm going to demonstrate now how to attach an S3 bucket policy via IAM. I've already created a bucket called Simplilearn S3 IAM demo. And what we're going to do is we're going to attach a bucket policy right over here. We're going to have to edit it, of course. And the basis of the demonstration will be to allow a user that has MFA, so multi-factor authentication, set up to have access to the contents of a folder within this bucket. So of course, now I have to create a folder. Just simply call it folder 1. Create that folder. And now I'm going to go into that folder and upload a file so that we can actually see this in action. So I'm going to select a demo file that I prepared in advance called demo file user2 MFA. I'm going to upload that. All right. And now what's going to happen is eventually when I create our 2 IAM users, one will have access to view the contents of this file, which should look like something very simple. If I open this up within the console, you'll be able to see, well, it's pretty small right now. I'll make this a little bit bigger, of course. It says this is a demo file which user2-MFA should only be able to have access to. So what's left to do now is to create 2 users, one called user1 and one called user2-MFA, and that's what we're going to do right now. Let's head over to IAM. Identity and Access Management. And on the left-hand side here, we're going to click on Users. You can see here I don't have much going on. I just got an administrator user, so I want to create 2 new users. We'll start with one at a time. So one called User1. Now by default, we have the principle of least privilege, which means this user is not allowed to do anything unless we give them access to either the console right over here, which I will do right now. And also if they were a kind of programmatic user that needed access to specific keys in order to interact with the APIs via the command line interface or the software development kit, for example, if you were a Java developer. So in this case, that is not what I want. So I'm just going to assign console access, and I'm also going to create a default password for this user. But I will not allow them to reset it on the first login, just for demonstration purposes. Now over here, we have the chance to add the user straight to a group, but I'll only do that later on at the end of the demonstration. For now, I want to show you how to attach to this user an IAM policy, which will give them access to specific services. So if I type in S3 full access here, this is an administrative access to an S3 bucket. If you take a look at the JSON document attached or representing that IAM policy, you can see that it is allowing all API actions across S3, star, and also object lambda across all buckets. And I say all buckets because the star represents all buckets. So it is a very broad permission, so be very careful when you're actually assigning this to one of your users and make sure that they deserve to have such a permission. So I'm not going to assign any tags here, but I'm just going to review what I've done. You can see here I've just attached an S3 full access permission to this one user, and I'm going to create that user now. Of course, now's the time for me to download the CSV file, which will contain those credentials. If I don't do it now, I will not have a second chance to do this. And also to send an email to this user in order for them to have a link to the console and also some instructions. I'm not going to bother with that. I'm just going to say close. And now I have my user 1. You can see here that it says none for multi-factor authentication. So I have not set anything up right now for them. And that's what I want to do for this second user that I want to create, called user2-MFA, or MFA rather. All right. So now I want to do the same exact thing as before. I'm going to assign a custom password. And I'm going to go through the same steps as we saw before. I'm going to attach an existing managed policy that AWS has already vetted for us. Review, create. Now, right now, they're exactly the same. So I have to go back to user 2 and set up multi-factor authentication. And to do that, you have to go in the Security Credentials tab. And you'll see here, assigned MFA device. We have not assigned any yet, so we're going to manage that right now. And we have the option to order and get an actual physical device that's uniquely made for performing multi-factor authentication. However, we're going to opt for the virtual MFA device, which is a software that we're going to install on our cell phones, let's say. So I can actually open this link just to show you the very many options that we have for that. They're right over here. I'm going to go with Google Authenticator. So go to the App Store on your Android device and you can download that. Of course, if you have an Android device. If not, you have other options for iPhone and other softwares for each one of those. So I'll let you do that. Once you've installed that software on your cell phone, you can come here and show the QR code. Now, what that is going to do is you're going to need to go to your phone now, and I'm going to my phone right now as we speak, and I'm going to open up that MFA software, in this case, the Google Authenticator, and I'm going to say there's a little plus sign at the bottom. I'm going to say scan QR code. I'm going to point my phone to this square code here, this QR code, and it's going to pick it up. I'm going to say add account. There's a little button there, add account, and it's going to give me a code. So I'm going to enter that code right now. So once I've entered the code, I have to wait for a second code, and that's because this code on the screen of my cell phone is going to expire. It's only there for about 20 to 30 seconds. Once that token expires, it refreshes the display with another token. So I have another token now. That's only good for a couple of seconds again. And now I'm going to say assign MFA. What this does is it completes the link between my personal cell phone and this user right now. So now that this has been set up, we can see we actually have an ARN to this device, which we are going to possibly need depending on how we write our policies. In our case here, I'm going to show you a way to kind of bypass having to put that. So now we've got those two users, one with an MFA device and another one without. Okay, so now the lab is going to be, or the demonstration rather, is going to be how do we allow user 2 MFA access to this file in folder 1 and not allow user 1. The distinguishing factor will be that user 2 has an MFA set up and user 1 doesn't. So based off of just that condition, that'll be the determining factor if they can view the file or not. So let's get back to S3 and actually create this IAM bucket policy and see how it's done. So back we are in our bucket, and now we have to go to permissions in order to set up this bucket policy. We're going to click on edit over here, and we're going to click on policy generator to help us generate that JSON file through a user interface. Of course, we're dealing with an S3 bucket policy. Now, what we're going to do is we're going to deny all users and services, so star. S3 is grayed out here because we selected S3 up here. We want to deny all S3 API actions. We're not going to go and selectively go down the list. The specific bucket and the folder. So in this case here, we're missing the Amazon resource name. So we have to go back here and we have to copy the ARN of our bucket, right? So we're going to copy that, come back, Control V, and we're going to, of course, have to specify the folder as well. So I'm going to just do /folder1, and then I'm also going to do /star for all the objects in that folder, okay? So here's the MFA condition that I want to add though, because we cannot assign the MFA condition up here. We have to say add conditions. Very powerful feature here. That's optional, but very powerful. We want to look for a condition that says Boolean if exists, or bool if exists. All right. So there's got to be a key value pair that exists, and there are many, but we're going to look for one that is specifically known as multi-factor authentication present. And we want to make sure that value is equal to false. So I'm going to add that condition, and then I'm going to add that statement. And I want to generate the policy just to show you now how that user interface has generated this JSON document for us that we're going to attach to our S3 bucket. What I want to do is I want to take this in its entirety, copy it, and go back to our S3 bucket that's just waiting for us to paste our policy in here. Okay, so let's see what's actually going on here. We've created a policy. Again, this policy could have any ID. It's just an ID that was given by the user interface. You could name that whatever you want. Of course, something that makes total sense. And then we have one or more statements, and then we only have actually one statement. And again, you can select any ID here. That was just auto-generated by the IDE. We're saying that all actions on the simple storage service, I say all again because of the star, are denied specifically on this resource, which is our bucket and the folder named folder 1 and all the objects within that folder under the certain conditions. So the condition is if you have a Boolean value of false associated with a key called multi-factor authentication present, and it has to exist, okay? Then if that value is equal to false, you don't have access to the objects in this folder, which means that if you do have MFA set up, you will be allowed access to the contents of this folder. So if we assign this and apply this to all principals, which would encompass user1 and user2-MFA, then, let me just apply this, that would mean that user 1 would not be able to see the contents of our object inside folder 1, and user 2-MFA would. So let's go take a look and log into, let's log out first, and then when we're going to log back in, we're going to log in as the individual user 1 and user 2-MFA and prove this is actually the case. So I am now logging back in as user 1 that we created moments ago. And of course, if I, for example, go see a service like EC2, we don't have access to EC2. We've just given ourselves access to S3. So this makes total sense. We're just going to go see what we have access to, which is S3. Should be able to list and describe all the buckets there because we've been given pretty much administrative access. Now, if we go here to our created bucket and go inside folder 1 and want to actually open up this document, we can see now that that's not happening, okay? And that's because of that condition that is checking if we actually have a value of true for that MFA key that we specified, okay? So this is expected, and this is exactly what we wanted. Now what we're going to do is we're going to log out once again, and we're going to do the same thing, but with user2-MFA. Let me log back in. And then specify the new password we created. Now, of course, now I have an MFA code, right? Because I've set that up for user 2. So back on my cell phone I go. I am opening up the Google Authenticator application, and I have in front of me a new Amazon Web Services code that is only good for, like I said, maybe 20 seconds. So it's a little nerve-wracking. If you're not good under pressure, you're going to choke. So I just entered the code, and I have to wait for that to actually work. Now, it looks like I actually didn't check off not to recreate the password. So unfortunately, I must have missed that check mark. So I wanted to kind of avoid this here. So I'm going to start over and create a brand new password. little painful for, demonstrations, but it's good for you guys to see how that actually looks like. So because I've set up my MFA device properly, I am able to log in after I enter that MFA code. And once again, if I go to EC2, now I haven't been given the permissions for EC2. I've only been given the permissions for S3. So nothing changes here. I'm going to go to S3. And I'm going to go into folder 1 of our bucket in question. And I'm going to see if I have access now to opening up and seeing the contents. And here I have the contents. This is a demo file which user2MFA should only be able to have access to. So that worked. So now you guys know how to create a bucket permission policy that is also known as a resource policy because it's assigned to the resource, it's assigned to the bucket. And let me actually show it to you one last time. Here it is. And that'll only allow us to have access to the contents of folder 1 if we have multi-factor authentication set up in our account. So that's really good. The last thing I want to show you now is how to maybe create IAM users in a better way in terms of not having to assign over and over again the same permissions like you saw me do for user 1 and user 2. Of course, now I cannot do anything IAM. Why? Because I'm user 2. I don't have access to IAM. So once again, I'm logging out and we're going to actually see the best practice in terms of how do I assign IAM policies to a group and then assign users to that group in order to inherit those permission policies. So let's get to it. Let's sign up first. So let us go back to IAM and we're going to be creating our first group. We're going to simply create the button or click on the button create group and we'll come up with a group called testers. We have the ability to add existing users to this group. So we will add, for example, user 1 only to the testers group. And we can also add permissions to this group. So we're going to go here and add, for example, the EC2 full permissions, create group. And what's going to happen now, if we go take a look at testers, we can see we have that one user that we added, and we also have the permissions associated with that group. So this means now that any new users we create will automatically inherit whatever permissions the group has, which is really good for maintainability. So for example, let's say we were to create many new testers. So let's say user 3 over here. Now, of course, I'm going to have to go in this case through the same steps as I did before. I'm just going to remember this time not to forget to uncheck that. And instead of attaching policies directly, I'm going to say, well, I want to inherit the policy permissions that were assigned to the group. So I'm going to say this user is going to be part of the testers group. And of course, I'm just going to skip through the remaining repetitive tasks that I've already described. And this user 3 now is already going to have the permissions to access EC2 that they've gained through the group testers. Whereas if we go back to user 1, this user also has the permissions from the group, but has a unique permission added to itself. So in this case, you do have the option of doing that. You have the option of adding a permission over and above that is assigned to the group to yourself directly. So this is really good, adding permissions to groups when you have, of course, lots of users in your company, in your organization. And instead of going to them and adding permissions after permission, you can centrally access this in one or manage this in one place. So for example, if I go back to my roles, groups rather, in my testers, and let's say I forgot to add a permission to all the users in this group. So let's say there was 20 users attached to this group. Okay, I'm not going to bore you with creating 20 users. we have 2 now. That's good enough to show the demonstration. And let's say now I need to add another permission, right? So in this case here, I'm going to add a permission For example, let's say based on DynamoDB, right? So I'm going to give full access to DynamoDB. I'm going to add that permission. And what's going to happen now is if I go back to my users, for example, user 3, I'm going to see that user 3 automatically has inherited that permission, and so has user 1. All right, show 2 more, and there they are. So in this case, it really allows for you to easily manage a lot of users in that group, because you can simply go to one place, which is the group, and add and remove policies as you see fit, and the whole team will inherit that. So it saves you lots of work, and that is the best practice. So there you have it, guys. You have learned in this demonstration how to create users, how to create groups, how to add users to groups and manage their policies in terms of best practice. And you've also learned how to attach to an S3 bucket a policy that allows you to permit access based off of if a user has multi-factor authentication set up. And we showed you how to actually set that up when creating an IAM user. So again, permissions tab is where this all happens. Hope you enjoyed that, put that to good use, and I'll see you in the next demonstration. So I hope you enjoyed that demonstration. We're just going to wrap things up in a summary and kind of see what was looked at throughout the tutorial. We first started with what is AWS security. We took a look at how important it was across our organization to maintain best practice and also standardize that practice across accounts organization. We took a look at the topmost services, in which we concentrated then after on IAM. And we took a look at what IAM was in terms of IAM users, groups, long-term credentials that are applied as IAM policies, and then the concept of a role. We took a look at the benefits of IAM and the actual terminology used with working with IAM. Of course, principal being an entity that is either a user or a service itself that can gain access to an AWS resources. And we actually saw the different types of authentication and what we can do to implement authorization via IAM policies and also through the use of roles. So we took a look how to organize our users into groups and what actually goes into acquiring a role through a demonstration. We took a look at how to actually create a role and attach that role to an EC2 instance. And then we took a look at the high-level features of IAM, which allowed us to either grant access to another IAM user from another group, implement multi-factor authentication like we just did in the demonstration, or ensure ourselves that we are following all the compliancy standards that have been adhered to by whatever project we're working on, and that AWS is there to support us. So
in today's job environment, being certified marks the difference between getting your dream job and losing it. If you're a fresher or just someone who's starting up, it's highly likely that you're confused in choosing the right certification. I'm going to help you figure it out. I'm Rahul from Simplilearn, and today we're going to talk about AWS certifications. So what exactly is an AWS certification? It represents a degree of expertise in AWS. It is obtained after passing one or more exams provided by Amazon, and each different role, like the SysOps administrator, developer, or solutions architect, has a different exam associated with it. This in turn helps employees demonstrate and validate technical cloud knowledge, which means that the people who are certified actually know what they're talking about. I have seen a common misconception among people where they believe that just because they're certified, they're entitled to a job. That's not true. Now, without proper practice or hands-on experience, the certification is wasted on you. So remember, just because you're certified does not mean you'll get a job. It only makes the job application process slightly easier relative to someone who's not been certified. Now, why is AWS given so much importance? Some of the important reasons are: an AWS certified individual gains credibility for their skills in AWS. They also gain access to free practice exams which help them prepare for the next AWS certification. There's an increase in monetary compensations, which only means that they get paid more, and you gain recognition for your knowledge and skills in AWS. Right now we're in the AWS certification website, whose link will be in the description, and now we're going to talk about the types of AWS certification. As you can see here, there are 3 levels of AWS certification. There's the foundational level, associate level, and professional level certification. Now, the foundational level certification only requires you to have a basic understanding of how the AWS cloud works. The AWS Certified Cloud Practitioner is optional for the architect path, developer path, and operations path. It is mandatory for the specialty certifications like the advanced networking, big data, and security certifications. Now, the associate level certifications are mid-level certifications for a technical role. Now, a professional certification is the highest level of certification that you can have for a technical role. Now, you have the solutions architect for the architect path and the DevOps engineer certification for both the developer and operations path. So how do you decide which of these certifications is suitable for you? So you've seen here that AWS provides various certifications for a number of job roles like SysOps administrator, solution architect, developer. So you need to make the right choice, taking into consideration the areas of your interest and the experience level that you have. Now we're going to talk about each of these certifications in detail. So first, let's talk about the AWS Certified Cloud Practitioner. Now we all understand that AWS is a widely recognized product in the market. So this certification helps you validate how well you know the AWS cloud. So this is just the basic understanding. Now, it is optional for the developer path and the operations path. I would suggest it's a good idea to start here because it forms a solid bedrock on all the other things that you're going to learn soon. Now, more importantly, it does not require any technical knowledge of other roles such as development, architecture, administration, and so on. So it's a great place to start for newcomers. Now you have the architect role certifications. Now, this is for you if you're interested in becoming a solutions architect or a solution design engineer or someone who just works with designing applications or systems on the AWS platform. Now, first we have the AWS Certified Solutions Architect Associate Level Certification. Now, this certification is for you if you want to show off how well you can architect and deploy applications on the AWS platform. Now, it is recommended that you have at least a year of experience working with distributed systems on the AWS platform. At the same time, it's also required that you understand the AWS services and be able to recommend a service based on requirements. You need to be able to use architectural best practices and you need to estimate the AWS cost and how you can reduce them. Next up, you have the AWS Certified Solutions Architect Professional Level Certification. Now, you will not get this certification unless you're done with the AWS Certified Solutions Architect Associate Level Certification. This is to show off your technical skills and experience in designing distributed applications on the AWS platform. Now, this does require you to have 2 years of experience working with cloud architecture on AWS. At the same time, it also requires you to be able to evaluate requirements and then make architectural recommendations. You also need to provide guidance on the best practices on architectural design across a number of different platforms. The developer level certifications are for you if you're interested in becoming a software developer. Now, the AWS Certified Developer Associate certification is to test how well you know how to develop and maintain applications on the AWS platform. It does require you to have a year or more of hands-on experience to design and maintain AWS-based applications. Like any software developer role, it is necessary that you know in depth at least one high-level programming language. It's also necessary that you understand the core of AWS services, uses, and basic architectural best practices. You need to be able to design, develop, and deploy cloud-based solutions on AWS platform, and you need to understand how applications can be created. You need to have experience in developing and maintaining applications for a number of AWS services like Amazon SNS, DynamoDB, SQS, and so on. Now for the AWS Certified DevOps Engineer Professional Level Certification. Note here that this certification is exactly the same as the one you have under the operations role. So both of them are the same thing. So here it tests your ability to create, operate, and manage distributed applications on the AWS platform. Now it is necessary or it is mandatory to have the AWS Certified Developer Associate certification or the AWS Certified SysOps Administrator certification with 2 or more years of hands-on experience in doing the same in AWS environment. It requires you to be able to develop code in at least one high-level language. You need to be able to automate and test applications via scripting and programming, and to understand agile or other development processes. The operation certifications are for you if you want to become a SysOps administrator, systems administrator, or someone in a DevOps role who wants to deploy applications, networks, and systems in an automatable and repeatable way. The AWS Certified SysOps Administrator Associate certification tests your knowledge in deployment, management, and operations on the AWS platform. Now, you need to have 1 or more years of hands-on experience in AWS-based applications. You need to be able to identify and gather requirements, then define a solution to be operated on AWS. You need to be able to provide guidance for the best practices through the life cycle of a project as well. Now, the specialty certifications are for you if you're well versed in AWS and want to showcase your expertise in other technical areas. The AWS Certified Big Data certification showcases your ability to design and implement AWS services which can help derive value from a large amount of complex data. You are, however, required to have completed the foundational or associate level certification before you can attempt this. You need a minimum of 5 years of hands-on experience in the data analytics field as well. Next, we have the AWS Certified Advanced Networking certification. This validates your ability to design and implement AWS solutions as well as other hybrid IT network architectures at scale. This also requires you to have completed the foundational or associate level certification. You need to have a minimum of 5 years of hands-on experience architecting and implementing network solutions. And lastly, we have the AWS Certified Security certification. It helps showcase your ability to secure the AWS platform. You're required to have an associate or cloud practitioner level of certification, a minimum of 5 years of IT security experience, and 2 years of hands-on experience securing AWS workloads. Now say I wanted to schedule an examination. So for example, I want to do the Solutions Architect certification. So first I would go there. Now here I can click on register now and the process continues, or I can click on learn more. By doing this, again I can schedule the examination here. I can also get access to other data like the number of questions available, the cost of an examination, the portions I need to study, and so on. Now let's talk about the Solutions Architect certification with a little more detail. Now this certification exam costs $150 and the practice exam costs $20. Now here I can schedule the examination or download the exam guide. I've already downloaded the exam guide and here it is. Now this exam guide tells you about what you need to learn and what is expected from you. Here they want you to define a solution based on requirements and provide guidance in its implementation. It is also recommended that you know about how the AWS services work, 1 year of hands-on experience with distributed systems on AWS to identify and define technical requirements and so on. The rest is available in the exam guide. And most importantly, they tell you the main content domains and their weightages. Now we have 5 domains. First domain is to design resilient architectures, which holds 34% of weightage. At domain 2, you have to define performant architectures. 3 is to specify secure applications and architectures, cost-optimized architectures, and 5 to define operationally excellent architectures. Now, like you've seen here, we've selected one certification and learned it in detail. You can do the same for any of these other certifications. You can press learn more and download their exam guide and learn everything that you need to know.
Here we're going to talk about Amazon ECS, a service that's used to manage Docker containers. So without any further ado, let's get started. In this session, we would like to talk about some basics about AWS, and then we're going to immediately dive into why Amazon ECS and what is Amazon ECS in general, and then it uses a service called Docker. So we're going to understand what Docker is. And there are competitive services available for ECS. ECS is not the own and only service to manage Docker containers. But why ECS? Advantage of ECS. We will talk about that. And the architecture of ECS. So how it functions, what are the components present in it, and what are the functions that it does. Each and every component, what are all the functions that it does. All those things will be discussed in the architecture of Amazon ECS. And how it works, how it all connects together. That's something we will discuss. And what are the companies that are using ECS? What were the challenge and how ECS helped to fix the challenge? That's something we will discuss. And finally, we have a wonderful lab that talks about how to deploy Docker containers on an Amazon ECS. So let's talk about what is AWS. Amazon Web Service, in short called as AWS, is an web service in the cloud that provides a variety of services such as compute power, database storage, content delivery, and a lot of other resources, so you can scale your business and grow, not focus more on your IT needs and the rest of the IT demands. Rather, you can focus on your business and let Amazon scale your IT, or let Amazon take care of your IT. So what is that you can do with AWS? With AWS, we can create, deploy any application in the cloud. So it's not just deploying. You can also create your application in the cloud. It has all the tools and services required, the tools and services that you would have installed in your laptop or you would have installed in your on-premises desktop machine for your development environment. The same thing can be installed and used from the cloud. So you can use cloud for creating, and not only that, you can use the same cloud for deploying and making your application available for your end user. The end user could be internal users. The end user could be in the internet. The end user could be kind of spread all around the world. It doesn't matter. So it can be used to create and deploy your applications in the cloud. And like you might have guessed, now it provides service over the internet. That's how your users worldwide would be able to use the service that you create and deploy, right? So it provides service over the internet. So that's for the end customer. And how will you access those services? That's again through the internet. It's like the extension of your data center in the internet. So it provides all the services in the internet. It provides compute service through the internet. So in other words, you access them through the internet. It provides database service through the internet, over the internet. In other words, you can securely access your database through the internet and a lot more. And the best part is this is pay as you go, or pay only for what you use. There is no long-term or beforehand commitment here. Most of the services does not have any commitment. So there is no long-term and beforehand commitment. You only pay exactly for what you use. There's no overage, there's no overpaying, right? There's no buying in advance, right? You only pay for what you use. Let's talk about what ECS is. So before ECS, before containers, right? ECS is a service that manages Docker containers, right? It's not a product or it's not a feature all by itself. It's a service that's dependent on Docker container. So before Docker containers, all the applications were running on VM or on a host or on a physical machine, right? And that's memory bound, that's latency bound. The server might have issues, on and on, right? So let's say this is Alice and she's trying to access her application, which is running somewhere in her on-premises, and the application isn't working. What could be the reason? Some of the reasons could be memory full, the server is currently down at the moment, we don't have another physical server to launch the application, a lot of other reasons. So a lot of reasons why the application wouldn't be working in on-premises. Some of them are memory full issue and server down issue, very less high availability, or in fact single point of failure and no high availability, if I need to tell it correctly. With ECS, the services can kind of breathe free, right? The services can run seamlessly. Now how is that possible? Now, those things we will discuss in the upcoming sessions. So because of containers and ECS managing containers, the applications can run in a high available mode. They can run in a high available mode, meaning if something goes wrong, right, there's another container that gets spun up and your application runs in that particular container. Very less chances of your application going down. That's what I mean. This is not possible with a physical host. This is very less possible with a VM, or at least it's going to take some time for another VM to get spun up. So why ECS, or what is ECS? Amazon ECS maintains the availability of the application and allows every user to scale containers when necessary. So it not only meets the availability of the application, meaning one container running your application or one container hosting your application should be running all the time. So to meet that high availability, availability is making sure your service is running 24/7. So container makes sure that your services run 24/7. Not only that. Suddenly if there is an increase in demand, how do you meet that demand? Right? Let's say you have like 1,000 users. Suddenly the next week there are like 2,000 users. Right. So how do you meet that demand? Container makes it very easy for you to meet that demand. In case of VM or in case of physical host, you literally will have to go buy another physical host, or add more RAM, add more memory, add more CPU power to it, right? Or kind of club 2-3 hosts together, clustering. You would be doing a lot of other things to meet that high availability and also to meet that demand. But in case of ECS, it automatically scales the number of containers. It automatically scales the number of containers needed, and it meets your demand for that particular hour. So what is Amazon ECS? The full form of ECS is Elastic Container Service, right? So it's basically a container management service which can quickly launch and exit and manage Docker containers on a cluster. So what's the function of ECS? It helps us to quickly launch and quickly exit and manage Docker containers. So it's kind of a management service for the Docker containers you will be running in Amazon or running in the AWS environment. So in addition to that, it helps to schedule the placement of container across your cluster. So it's like this. You have two physical hosts, joined together as a cluster. And ECS helps us to place your containers. Now, where should your container be placed? Should it be placed in host 1? Should it be placed in host 2? So that logic is defined in ECS. We can define it. You can also let ECS take control and define that logic. Most cases you will be defining it. So schedule the placement of containers across your cluster. Let's say two containers want to interact heavily. You really don't want to place them in two different hosts, right? You would want to place them in one single host so they can interact with each other. So that logic is defined by us. And these container services, you can launch containers using AWS Management Console, and also you can launch containers using SDK kits available from Amazon. You can launch through a Java program. You can launch container using an .NET program. You can launch container using an Node.js program, as in when the situation demands. So there are multiple ways you can launch containers through Management Console and also programmatically. And ECS also helps to migrate application to the cloud without changing the code. So anytime you think of migration, the first thing that comes to your mind is that how will that environment be? Based on that, I'll have to alter my code. What's the IP? What is the storage that's being used? What are the different parameters I'll have to include? The environment parameters of the new environment. With containers, now that worry is already taken away, because we can create an pretty exact environment. The one that you had on premises, the same environment gets created in the cloud. So no worries about changing the application parameter, no worries about changing the code in the application. Right? You can be like, if it ran in my laptop, a container that I was running in my laptop, it's definitely going to run in the cloud as well, because I'm going to use the same container in the laptop and also in the cloud. In fact, you're going to ship it. You're going to move the container from your laptop to Amazon ECS and make it run there. So it's like the very same image, the very same container that was running in your laptop will be running in the cloud or production environment. So what is Docker? We know that ECS helps to quickly launch, exit, and manage Docker containers. What is Docker? Let's answer that question. What is Docker? Now, Docker is a tool that helps to automate the development of an application as a lightweight container so that the application can work efficiently in different environments. This is pretty much what we discussed right before the slide. I can build an application in my laptop or in on-premises in a container environment, Docker container environment, and anytime I want to migrate, right, I don't have to kind of rewrite the code and then rerun the code in that new environment. I can simply create an image, a Docker image, and move that image to that production or the new cloud environment and simply launch it there. Right? So no compiling again, no relaunching the application. Simply pack all your code in a Docker container image and ship it to the new environment and launch the container there. That's all. So Docker container is a lightweight package of software that contains all the dependencies. So because, when packing, you'll be packing all the dependencies. You'll be packing the code. You'll be packing the framework. You'll be packing the libraries that are required to run the application. So in the new environment, you can be pretty sure, you can be guaranteed that it's going to run because it's the very same code, it's the very same framework, it's the very same libraries that you have shipped, right? There's nothing new in that new environment. It's the very same thing that's going to run in that container. So you can be rest assured that they are going to run in that new environment. And these Docker containers are highly scalable and they are very efficient. Suddenly you wanted like 20 more Docker containers to run the application. Think of adding 20 more hosts, 20 more VMs, right? How much time would it take? And compared to that time, the amount of time that Docker containers would require to kind of scale to that amount, like 20 more containers, it's very less, or it's minimal or negligible. So it's a highly scalable and it's a very efficient service. You can suddenly scale number of Docker containers to meet any additional demand. Very short boot up time because it takes it's not going to load the whole operating system. And these Docker containers, they use the Linux kernel and features of the kernel like C groups and namespaces to kind of segregate the processors so they can run independently any environment, and it takes very less time to boot up. And the data that are stored in the containers are kind of reusable. So you can have an external data volume, and I can map it to the container, and whatever the space that's occupied by the container and the data that the container puts in that volume, they are kind of reusable. You can simply remap it to another application. You can kind of remap it to the next successive container. You can kind of remap it to the next version of the container, next version of the application you'll be launching, and you don't have to go through building the data again from the scratch. Whatever data the container was using previously or the previous container was using, that data is available for the next container as well. So the volumes that the containers uses are very reusable volumes. And like I said, it's isolated application, so it kind of isolates by its nature. It kind of, by the way it's designed, by the way it is created, it isolates one container from another container, meaning anytime you run applications on different containers, you can be rest assured that they are very much isolated. Though they are running on the same host, though they are running on the same laptop, let's say, though they are running on the same physical machine, let's say, running 10 containers, 10 different applications, you can be sure that they are well disconnected or well isolated applications. Now let's talk about the advantages of ECS. The advantage of ECS is improved security. Its security is inbuilt in ECS. With ECS, we have something called as a container registry. That's where all your images are stored, and those images are accessed only through HTTPS. Not only that, those images are actually encrypted, and access to those images are allowed and denied through identity and access management policies, IAM. And in other words, let's say two containers running on the same instance. Now one container can have access to S3 and the others, or the rest of the others, are denied access to S3. So that kind of granular security can be achieved through containers when we mix and match the other security products available in Amazon, like IAM, encryption, accessing it using HTTPS. These containers are very cost efficient. Like I've already said, these are lightweight processes, right? We can schedule multiple containers on the same node, and this actually allows us to achieve high density on an EC2 instance. Imagine an EC2 instance that's very less utilized. That's not possible with a container, because you can actually dense or crowd an EC2 instance with more container in it, so to best use those resources. In EC2, straightforward, you can just launch one application. But when we use containers, you can launch like 10 different applications on the same EC2 server. That means 10 different applications can actually feed on those resources available and can benefit the application. And ECS not only deploys the container, it also maintains the state of the containers, and it makes sure that the minimum set of containers are always running based on the requirement. That's another cost efficient way of using it, right? And anytime an application fails, and that has a direct impact on the revenue of the company, and ECS makes sure that you're not losing any revenue because your application has failed. And ECS is a pretty extensible services. It's like this: in many organizations, there are majority of unplanned work because of environment variation. A lot of firefighting happens when we kind of deploy the code from one, or kind of move the code or redeploy the code in a new environment. A lot of firefighting happens there. Right? This Docker containers are pretty extensible. Like we discussed already, environment is not a concern for containers, because it's going to kind of shut itself inside a Docker container, and anywhere the Docker container can run, the application will run exactly the way it performed in the past. So environment is not a concern for the Docker containers. In addition to that, ECS is easily scalable. We have discussed this already, and it has improved compatibility. We have discussed this already. Let's talk about the architecture of ECS. Like you know now, the architecture of ECS is the ECS cluster itself. That's group of servers running the ECS service, and it integrates with Docker, right? So we have a Docker registry. Docker registry is a repository where we store all the Docker images or the container images. So it's like three components. ECS is of three components. One is the ECS cluster itself. Right? When I say ECS itself, I'm referring to ECS cluster of servers that will run the containers. And then the repository where the images will be stored, right? The repository where the images will be stored, and the image itself. So container image is the template of instructions which is used to create a container, right? So it's like, what's the OS? What is the version of node that should be running? And any additional software do we need? So those questions gets answered here. So it's the template of instructions which is used to create the containers. And then the registry is the service where the Docker images are stored and shared. So many people can store there, and many people can access, or if there's another group that wants to access, they can access the image from there, or one person can store the image and the rest of the team can access, and the rest of the team can store image, and this one person can pick the image from there and kind of ship it to the customer or ship it to the production environment. All that's possible in this container registry. And Amazon's version of the container registry is ECR. And there's a third party. Docker itself has a container registry, that's Docker Hub. ECS itself, which is the group of servers that runs those containers. So these two, the container image and the container registry, they kind of handle Docker in an image format, just an image format. And in ECS is where the container gets live, and then it becomes an compute resource and starts to handle requests, starts to serve the page and starts to do the batch job, whatever your plan is with that container. So the cluster of servers, ECS, integrates well with the familiar services like VPC. VPC is known for securing. VPC is known for isolating the whole environment from rest of the customers, or isolating the whole environment or the whole infrastructure from the rest of the clients in your account, or from the rest of the applications in your account, on and on. So VPC is a service that provides or gives you the network isolation. ECS integrates well with VPC. And this VPC enables us to launch AWS resources such as Amazon EC2 instance in a virtual private network that we specify. This is basically what we just discussed. Now let's take a closer look at the ECS. How does ECS work? Let's find answer for this question. How does ECS work? ECS has got a couple of components within itself. So these ECS servers can run across availability zone. As you can see, there are two availability zones here. They can actually run across availability zones. And ECS has got two modes, Fargate mode and the EC2 mode. Right here we're seeing Fargate mode, and then here we're seeing nothing. That means it's an EC2 mode. And then it has got different network interfaces attached to it, because they need to be running in an isolated fashion, right? So anytime you want network isolation, you need separate IP, and if you want separate IP, you need separate network interface card, and that's what you have, elastic network interface card, separate elastic network interface card for all those tasks and services. And this runs within an VPC. Let's talk about the Fargate service. Tasks are launched using the Fargate service. So we will discuss about tasks. What is Fargate? Now, Fargate is a compute engine in ECS that allows users to launch containers without having to monitor the cluster. ECS is a service that manages the containers for you, right? Otherwise, managing containers will be a full-time job. So ECS manages it for you, and you get to manage ECS. That's the basic service. But if you want Amazon to manage ECS and the containers for you, we can go for Fargate. So Fargate is a compute engine in ECS that allows users to launch containers without having to monitor the ECS cluster. And the tasks the task that we discussed, the task has two components. You see task right here. So they have two components. We have ECS container instance and then the container agent. So like you might have guessed right now, ECS container instance is actually an EC2 instance, right, capable of running containers. Not all EC2 instances can run containers. So these are like specific EC2 instances that can run containers. They are ECS container instances. And then we have container agent, which is the agent that actually binds those clusters together, and it does a lot of other housekeeping work, right? Kind of connects clusters, makes sure that the version needed is present. So it's all part of that agent, or it's all job of that agent. Container instances is part of Amazon EC2 instance, which run Amazon ECS container agent. Pretty straightforward definition. And then a container agent is responsible for communication between ECS and the instance, and it also provides the status of the running containers. Kind of monitors the container, monitors the state of the container, make sure that the container is up and running, and if there's anything wrong, it kind of reports it to the appropriate service to fix the container, on and on. Right? So container agent, when we don't manage container agent, it runs by itself, and you really don't have to do anything to make the container agent better. It's already better. You really won't be configuring anything in the agent. And then Elastic Network Interface Card is a virtual interface network that can be connected to an instance in VPC. So in other words, Elastic Network Interface is how the container interacts with another container, and that's how the container interacts with the EC2 host, and that's how the container interacts with the internet, external world. And a cluster is a set of ECS container instances. It's not something that's very difficult to understand. It's simply a group of EC2 instances that runs that ECS agent. And this cluster handles the process of scheduling, monitoring, and scaling the request. We know that ECS can scale, the containers can scale. How does it scale? That's all monitored and managed by this ECS cluster. Let's talk about the companies that are using Amazon ECS. There are a variety of companies that use ECS clusters. To name a few, Okta uses ECS cluster, and Okta is a product that uses identity information to grant people access to applications on multiple devices at any given point of time. They make sure that they have a very strong security protection. So Okta uses Amazon ECS to run their Okta application and serve their customers. And Abima is a TV channel, and they chose to use microservices and Docker containers. They already had microservices and Docker containers, and when they thought about a service that they can use in AWS, ECS was the only service that they can immediately adapt to. And because in Abima TV the engineers have already been using Docker and Docker containers, it was kind of easy for them to adapt themselves to ECS and start using it, along with the benefits that ECS provides. Previously they had to do a lot of work, but now ECS does it for them. Right. Similarly, Remind and Ubisoft, GoPro are some of the famous companies that use Amazon ECS and get benefited from its scalability, get benefited from its cost, gets benefited from its Amazon managed services, get benefited from the portability that ECS and the migration option that ECS provides. Let's talk about how to deploy a Docker container on Amazon ECS. The way to deploy a Docker container on ECS is, first we need to have an AWS account, and then set up and run our first ECS cluster. So in our lab we're going to use the launch wizard to run an ECS cluster and run containers in them. And then task definition. Task definition tells the size of the container, the number of the container. And when we talk about size, it tells how much of CPU do you need, how much of memory do you need. And talking about numbers, it requires how many numbers of container you're going to launch. Is it 5? Is it 10? Or is it just one running all the time? Now those kind of information goes in the task definition file. And then we can do some advanced configuration on ECS, like load balancers, and what port number you want to allow and you don't want to allow, who gets access, who shouldn't get access, and what's the IP that you want to allow and deny requests from, on and on. And this is where we would also mention the name of the container, so to differentiate one container from the other, and the name of the service. Is it an backup job? Is it a web application? Is it a data container? Is it going to take care of your data backend? And the desired number of tasks that you want to be running all the time. Those details go in when we try to configure the ECS service, right? And then you configure your cluster. You put in all the security in the configure your cluster step or configure cluster stage. And finally, we will have an instance and bunch of containers running in that instance. All right, let's do a demo. So here I have logged in to my Amazon portal, and let me switch to the appropriate region. I'm going to pick North Virginia. North Virginia, look for ECS. And it tells ECS is a service that helps to run and manage Docker containers. Well and good. Click on it. I'm in North Virginia. Just want to make sure that I'm in the right region. And go to clusters. And here we can create cluster. This is our Fargate, and this is our EC2 type launching for Linux and Windows environment. But I'm going to launch through this walkthrough portal. Right? This gives a lot of information here. So the different steps involved here is creating a container definition, which is what we're going to do right now, and then a task definition, and then a service, and finally the cluster. It's a 4-step process. So in container definition, we define the image, the base image we are going to use. Now here I'm going to launch an HTTPD or a simple HTTP web page, right? So a simple HTTPD 2.4 image is fair enough for me, and it's not a heavy application, so 0.5 gigabit of memory is enough. And again, it's not a heavy application, so 0.25 virtual CPU is enough in our case, right? You can edit it based on the requirement. You can always edit it, and because I'm using HTTPD, the port mapping is already port 80. That's how the container is going to receive the request. And there's no health check as of now. When we want to design critical and complicated environments, we can include health check, right? And this is the CPU that we have chosen. We can edit it. And I'm going to use some bash commands to create an HTML page, right? This page says that, Amazon ECS sample app, right? And then it says Amazon ECS sample app. Your application is running on a container in Amazon ECS. So that's the page, the HTML page that I'm going to create, right? Index.html. So I'm going to create and put it in an appropriate location, so those pages can be served from the container, right? If you replace this with any of your own content, then it's going to be your own content. ECS comes with some basic logs, and these are the places where they get stored. That's not the focus as of now. Right, so I was just saying that you can edit it and customize it to your needs. We're not going to do any customization now. We're just getting familiar with ECS now. And the task definition, name of the task definition is first run task definition, and then we are running it in a VPC. And then this is an Fargate mode, meaning the servers are completely handled by Amazon, and the task memory is 0.5 gigabit. And the task CPU is 0.25 virtual CPU. Name of the service. Is it a batch job? Is it a front end? Is it a back end? Or is it a simple copy job? What's the service? Name of the service goes here. Again, this you can edit it. And here's our security group. As of now, I'm allowing port 80 to the whole world. If I want to restrict to a certain IP, I can do that. The default option for load balancing is no load balancer, but I can also choose to have a load balancer and use port 80 to map that port 80 to the container port 80, right? I can do that. The default is no load balancer. All right, let's do one thing. Let's use load balancer. Let's use load balancer, and port 80 receives information on port 80 HTTP. What's going to be the cluster name? We're in the last step. What is the cluster name? cluster name can be Simplilearn ECS demo. Next, we're done and we can create. So it's launching a cluster, as you can see, and it's picking the task definition file that we've created, and it's using that to launch an service. And then these are the log groups that we discussed, and it's creating a VPC. Remember, ECS clubs well with the VPC. It's creating a VPC, and it's creating 2 subnets here for high availability. It's creating that security group, port 80, allowed to the whole world, and then it's putting it behind an load balancer. It generally would take like 5 to 10 minutes, so we just need to be patient and let it complete its creation. And once this is complete, we can simply access the service using the load balancer URL. And when this is running, let me actually take you to the other products or the other services that are integrated with ECS. It's getting created. Our service is getting created as of now. ECR repository. This is where all our images are stored. Now, as of now, I'm not pulling my image from ECR. I'm pulling it directly from the internet, Docker Hub. But all custom images, they are stored in this repository. So you can create a repository, call it app1, create a repository. So here's my repository. So any image that I create locally, or any Docker image that I create locally, I can actually push those images using these commands right here, and they get stored here. And I can make my ECS connect with ECR and pull images from here. So they would be my custom images. And as of now, because I'm using a default image, it's directly pulling it from the internet. Let's go to EC2 and look for a load balancer, because we wanted to access the application from behind a load balancer, right? So here is a load balancer created for us, and anytime I put the URL, so a cluster is now created. You see there's one service running. All right, let's click on that cluster. Here is the name of our application, and here is the tasks, the different containers that we are running. And if you click on it, we have an IP, right? IP of that container, right? And it says it's running, it was created at such and such time and started at such and such time. And this is the task definition file that this container uses, meaning the template, the details, all the version details, they all come from here, and it belongs to the cluster called Simplilearn ECS demo, right? And you can also get some logs, container logs from here. So let's go back. And there are no ECS instances here, because remember, this is Fargate. You're not managing any ECS instance, right? So that's why you're not seeing any ECS instance here. So let's go back to tasks and go back to the same page where we found the IP. Pick that IP, put it in the browser, and you have this sample HTML page running from an container. So let me go back to load balancer, EC2, and then under EC2 I'll be able to find a load balancer, find that load balancer, pick that DNS name, put it in the browser, and now it's accessible through the load balancer URL. Right now this URL can be mapped to other services like DNS. This URL can be embedded in any of your application if you want to make that application connect with this container. Now, using IP is not all that advisable, because these containers can die and then a new container gets created, and when a new container gets created, it gets a new IP, right? So hard-coding IP is hard-coding dynamic IPs are not advisable. So you would be using load balancer and putting that URL in that application that you want to make it interact with this container instance. It was a wonderful experience in walking you through this ECS topic, and in here we learned about what AWS is and why we're using ECS, and what is ECS in general, what is Docker in specific, and we also learned about the advantages of ECS, the architecture, the different components of ECS, and how ECS works when they're all connected together. And we also looked at the companies that use ECS and their use cases, and finally a lab, how we can launch ECS Fargate through the portal. I'm very glad to walk you through this lesson about Route 53. So in this section, we are going to talk about basics of AWS, and then we're going to immediately dive into why why we need Amazon Route 53. And then we're going to expand and talk about the details of Amazon Route 53, the benefits it provides over its competitors, and the different types of routing policy it has, and some of Amazon Route 53's key features. And we're going to talk about how to access Route 53, the different ways, the different methods you can access Route 53, and finally we're going to end with a wonderful demo in Route 53. So let's talk about what is AWS. Amazon Web Services, or AWS in short, is a cloud provider that offers a variety of services such as a variety of IT services or infrastructure services such as compute power, database, content delivery, and other resources that helps us to scale and grow our business. And AWS is hot, AWS is picking up, AWS is being adapted by a lot of customers. That's because AWS is easy to use even for a beginner. And talking about safety, the AWS infrastructure is designed to keep the data safe irrespective of the size of the data. Be it small data, be it very minimal data, be it all the data that you have in terabytes and in petabytes, Amazon can keep it safe in their environment. And the wonderful thing and the most important reason why a lot of customers move into the cloud is that the pay-as-you-go pricing. There is no long-term commitment and it's very cost effective. What this means is that you're not paying for a resource that you're not using. In on-premises, you do pay for resources you're not using a lot, meaning you go and buy a server, you do the estimate for the next 5 years, and only after like 3 or 4 years you'll be hitting the peak capacity, but still you would be buying that capacity before 4 years, right? And then you will gradually be, utilizing it from 40%, 60%, 70, 80, and then 100. So what you have done is that even though you're not using the full capacity, you still have bought it and are paying for it from day one. But in the cloud, it's not like that. You only pay for the resources that you use. Anytime you want more, you scale up the resource and you pay for the scaled up resource. And anytime you want less, you scale down the resource and you pay less for that scaled down resource. Let's talk about why Amazon Route 53. Let's take this scenario where Rachel is trying to open her web browser and the URL that she hit isn't working. A lot of reasons behind why the URL isn't working. It could be the server utilization that went high. It could be the memory usage that went high. A lot of reasons. And she starts to think, is there an efficient way to scale resources according to the user requirements? Or is there an efficient way to kind of mask all those failures and kind of divert the traffic to the appropriate active resource or active service that's running our application? You always want to hide the failures, right? In IT, kind of mask the failure and direct the customer to another healthy service that's running, right? None of your customers would want to see a server not available, or none of your customers would want to see your service not working. Not impressive to them. And this is Tom. Tom is an IT guy and he comes up with an idea and he's answering Rachel, yes, we can scale resources efficiently using Amazon Route 53. In a sense, he's saying that yes, we can mask the failure and we can keep the services up and running, meaning we can provide more high availability to our customers with the use of Route 53. And then he goes on and explains Amazon Route 53 is a DNS service that gives developers an efficient way to connect users to internet applications without any downtime. Now, downtime is the key. Amazon Route 53 helps us to avoid any downtime that customers would experience. You still will have downtime in your server, in your application, but your customers will not be made aware of it. And then Rachel is kind of interested and she's like, yeah, that sounds interesting. I want to learn more about it. And Tom goes on and explains the important concepts of Amazon Route 53. That's everything that I'm going to explain it to you as well. All right, so what is Amazon Route 53? Amazon Route 53 is a highly scalable DNS or domain name system web service. This service, this Amazon Route 53, it functions three main things, or it has three main functions. So the first thing is, if a website needs a name, Route 53 registers the name for the website domain. Let's say you want to buy google.com. You want to buy the domain name. Let's say you want to buy that domain name. You buy that through Route 53. Secondly, Route 53 is the service that actually connects your server, which is running your application, or which is serving your web page. So that's the service that actually, Route 53 is the service that connects the user to your server when they hit google.com in the browser, or whatever domain name that you have purchased. So you bought a domain name and the user types in your domain name.com, and then Route 53 is a service that helps the user to connect their browser to the application that's running in an EC2 instance or any other server that you are using to serve that content. Now, not only that, Route 53 checks health of the resource by sending automated requests over the internet to a resource. So that's how it identifies if there is any resource that has failed. When I say resource, I'm referring to any infrastructure failure, any application level failure. So it kind of keeps checking. So it understands it first before the customer notices it, and then it does the magic, kind of shifts the connection from one server to the other server. We call it routing. We will talk about that as we progress. So the benefits of using Route 53. It's highly scalable, meaning suddenly, let's say, the number of requests, the number of people trying to access your website through that domain name that you have bought, let's say it has increased. Route 53 is highly scalable, right? It can handle even millions and millions of requests because it's highly scalable and it's managed by Amazon. The same thing, it's reliable, it's highly scalable, it can handle large queries without the users, without you interacting, without the user who bought it interact with it. You don't have to scale up, when you're expecting more requests, it automatically scales. And it is very reliable in a sense that it's very consistent. It has the ability to route the users to the appropriate application through the logic that it has. It's very easy to use. When we do the lab, you're going to see that. It's very easy to use. You buy the domain name and then you simply map it to the application. You simply map it to the server by putting in the IP, or if you can simply map it to another load balancer by putting in the load balancer URL. You can simply map it to another S3 bucket by simply putting the S3 bucket name or the S3 bucket URL. It's pretty straightforward, easy to set up. And it's very cost effective in a way that we only pay for the service that we have used. So no wastage of money here. So the billing is set up in such a way that you are paying only for the amount of requests that you have received, right? The amount of traffic, the amount of requests that you have received, and a couple of other things. The number of hosted zones that you have created, right? And a couple of other things. It's very cost effective in such a way that you only pay for the service that you are using. And it's secure in a way that access to Route 53 is integrated with the Identity and Access Management, IAM. So you only have authorized users gain access to Route 53. The trainee who just joined yesterday won't get access. And the contractor or the consultant, the third-party consultant you have given access, or who is using your environment, you can block access to that particular person because he's not the admin or he's not a privileged user in your account. So only privileged users and admin gain access to Route 53 through IAM. Now let's talk about the routing policies. So when you create a record in Route 53, record is nothing but an entry. So when you do that, you choose a routing policy. Right? Routing policy is nothing but it determines how Route 53 responds to your queries, how the DNS queries are being responded. Right? That's a record, or that's a routing policy. So the first one is a simple routing policy. So we use simple routing policy for a single resource. In other words, simple routing allows to configure DNS with no special Route 53 routing. It's kind of one-to-one. You use a single resource that performs a given function to your domain. For example, if you want to simply map an URL to a web server, that's pretty straightforward, simple routing. So it routes traffic to a single resource, example, web server to a website. And with simple routing, multiple records with the same name cannot be created. but multiple values can be created in the same record. The second type of routing policy is failover routing. So we would be using failover routing when we want to configure active, passive failover. If something failed, right, you want to fail over to the next resource, which was previously the backup resource, now the active resource, or which was previously the backup server, now it's an active server. So you would be failing over to that particular resource or that particular IP. If you want to do that, we use failover routing. So failover routing routes traffic to a resource when the resource is healthy, or to a different resource when the previous resource is unhealthy. In other words, anytime a resource goes unhealthy, it does all that's needed to shift the traffic from the primary resource to the secondary resource. In other words, from the unhealthy resource to the healthy resource. And this records can route traffic to anything from an Amazon S3 bucket, or you can also configure a complex tree of records. Now, when we configure the records, it will be more clear to you. So as of now, just understand that Route 53 can route, or this routing policy, the failover routing policy, can route traffic to Amazon S3 bucket or to a website that has complex tree of records. Geolocation routing policy. Now, geolocation routing, just like the name says, it takes that routing decision based on the geographic location of the user. Right? In other words, when you want to route traffic based on the location of the user, that's your primary criteria for sending that request to the appropriate server, we would be using geolocation routing. So it localizes the content and presents a part or the entire website in the language of the user. For example, a user from US, you would want to direct them to an English website, and a user from German, if you want to send them to the German website, and a user from France, you want to send those requests, or you want to show content specific to a customer who lives in France, a French website. So this is, if that's your condition, this is the routing policy we would be using. And the geographic locations are specified by either continent or by country or by state in the United States. So only in the United States you can actually split it to state level, and for the rest of the countries you can do it on a country level. On a high level, you can also do it on a continent level. The next type of routing policy would be geo-proximity routing. Geo-proximity routing policy, when we want to route traffic based on the location of our resource and optimally shift traffic from resources in one location to resource in another location, we would be using geo-proximity routing. So geo-proximity routing routes traffic to the resources based on the geographic location of the user and the resources they want to access. And it also has an option to route more traffic or less to a given resource by specifying a value known as a bias. Kind of weight, but we also have weighted routing, that's different. So we've chosen different name, bias. You can send more traffic to a particular resource by having a bias on that particular routing condition. And a bias expands or shrinks the size of the geographic region from which traffic is routed to a resource. And then we have latency based routing. Just like the name says, we use latency based routing if we have resources in multiple AWS regions, and if we want to route traffic to the region that provides the best latency at any given point of time. So let's say if one single website needs to be installed and hosted on multiple AWS regions, then latency routing policy is what is being used. It improves the performance of the users by serving the request from the AWS region that provides the lowest latency. So at any given point, if performance is your criteria, and at any given point of time, irrespective of what happens in Amazon infrastructure, irrespective of what happens in the internet, if you want to route your users to the best performing website, best performing region, then we would be using latency based routing. And for using latency based routing, we should create latency records for the resources in multiple AWS regions. And then the other type of a routing policy is multi-value routing policy, where we can make Route 53 to respond to DNS queries with up to 8 healthy records selected at random. So you're not kind of loading one particular server. We can define 8 records, and on a random basis, Route 53 will respond to queries from these 8 records. So it's not one server that gets all the requests, but 8 servers gets the request in a random fashion. So it's multi-value routing policy, and what we get by this is that we are distributing the traffic to many servers instead of just one server. So multi-value routing configures Route 53 to return multiple values in response to a single or multiple DNS queries. It also checks the health of order sources and returns the multiple values only for the healthy resources. Let's say out of the 8 servers we have defined, one server is not doing healthy. It will not respond to the query with the details of the unhealthy server, right? So now it's going to treat it as only 7 servers in the list because one server is unhealthy. And it has the ability to return multiple health checkable IP addresses to improve availability and load balancing. The other type of routing policy is weighted routing policy, and in here we use to route traffic, or this is used to route traffic to multiple resources in a proportion that we specify. So this is an weighted routing, and weighted routing routes multiple resources to a single domain name or a subdomain and control the traffic that's routed to each resources. So this is very useful when you're doing load balancing and testing new versions of the software. So when you have a new version of the software, you really don't want to send 100% of the traffic to it. So you want to get customers' feedback about the new software that you've launched, new version or new application that you've launched. So you would kind of send only 20% of the traffic to that application, get customer feedback, and if all is good, then we would move the rest of the traffic to that new application. So any software launches, application launches will be using weighted routing. Now let's talk about the key benefits or key features of Route 53. Some of the key features of Route 53 are traffic flow. It routes end users to the endpoint that should provide the best user experience. That's what we discussed in the routing policies, right? It uses a routing policy, a latency-based routing policy, and geo-based routing policy, and then failover routing policy. So it kind of improves the user experience. And the other key feature of Route 53 is we can buy domain names using Route 53 console. We can buy it from here and use it in Route 53. Previously it was not the case, but now we can buy it directly from Amazon through Route 53, and we can assign it to any resources that we want. So anybody browsing that URL, the connection will be directed to the server in AWS that runs our website. Health checks. It monitors health and performance of the application. So it comes with an health check attached to it. Health check are useful to make sure that the unhealthy resources are retired, right? The unhealthy resources are taken away, or your customers are not kind of hitting the unhealthy resources and they see an service down page or something like that. We can have weighted round robin load balancing. That's helpful in spreading traffic between several services or servers via a round robin algorithm. So no one server is fully hit, or no one server kind of fully absorbs all the traffic. You can split and shift the traffic to different servers based on the weight that you would be configuring. And also weighted routing also helps with a soft launch of your new application or the new version of your website. There are different ways we can access Amazon Route 53. So you can access Amazon Route 53 through AWS console. You can also access Amazon Route 53 using AWS SDKs, and we can access it we can configure it using the APIs. And we can also do it through the command line interface. That's Linux type, Linux flavor, AWS command line interface. We can also do that using Windows command line, Windows PowerShell flavored command line interface as well. Now let's look at some of the companies that are using Route 53. So some of the famous companies that use Route 53 are Medium. Medium is an online publishing platform, and it's more like a social journalism. It's kind of having hybrid collection of professionals, people and publications, or exclusive blogs or publishers on Medium. It's kind of an blog website, and that uses Route 53 for the DNS service. Reddit is an social news aggregation or web content rating and discussion website that uses Route 53. So these are some websites that are accessed throughout the world, and they are using Route 53, and it's highly scalable. Suddenly if there is a new news, right, their website will be accessed a lot, and they need to keep their service up and running all the time, more availability, otherwise customers will end up in a broken page, and the number of customers who will be using the website will come down. So it's very critical. Now these sites, these companies are very critical, they're being highly available, their page, their site being highly available, and the internet is very critical and crucial for them, and they rely and use Route 53 to meet that particular demand. And Airbnb is another company, Instacart, Coursera is another company, Stripe is another company that uses Route 53 as their DNS provider for their DNS service. They use Route 53 so their customers get best performance. They use Route 53 so their website is highly available. They use Route 53 to kind of shift the traffic between the resources, so their resources are properly used with all the weighted routing. Their resources are properly used. Now let's quickly look at a demo. I'm in my AWS console and I'm in Route 53. So let me click on Route 53. So in this lab, we're actually going to simulate buying a domain name, and then we're going to create an S3 static website, and we're going to map that website to this DNS name, right? So the procedure is the same for mapping load balancer. The procedure is the same for mapping CloudFront. The procedure is the same for mapping EC2 instances as well. We're picking S3 for simplicity, right? But our focus is actually on Route 53. So let's go in here and we'll see if we can, right? We'll buy a domain name here. So let's first check the availability of a domain name called Simplilearn-demo-Route 53. Let's check its availability. It is available for $12, so let me add it to cart and then come back here. And then once you continue, it'll ask for personal information. Once you give the personal information, you finally check out, and then it gets added to your shopping list. Once you pay for it, Amazon takes like 24 to 48 hours to make that DNS name available. So the next stage would be contact details, and then the third stage would be verify and purchase. So once we have bought the domain name, it will become available in our DNS portal. And I do have a domain name which I bought some time back, and it's now available for me to use. So I can go to hosted zone and simply start creating. I can go to hosted zone, and then here it's going to list all the domain names for me, right? Click on the domain name and then click on the record set, and here I can actually map Elastic Load Balancer, S3 website, VPC endpoint, API gateway, and CloudFront, Elastic Beanstalk domain names, right? All that gets mapped through this portal. Quite simple, like 4 or 5 step button clicks, and then it'll be done. So I have an domain name bought, and then I'm going to go to S3, and I'll show you what I've done in S3. So I've created a bucket name called as DNS name. Let me clear the content in them. So I've created a bucket, and then permissions, I've turned off public access blocking, and then I've created a bucket policy. So this bucket is now publicly accessible. And then I went on to properties and created the static website hosting, right? And I've pointed that this is the file, that's my index file that I'm going to put, or name of the file that's going to be my index file that I'm going to put in this S3 bucket. So I've put the index file.html, saved it, and we're going to create a file now. We're going to create an index file. So this is a sample code. It says Amazon Route 53 getting started, routing internet traffic to S3 bucket for your website, and then a couple of other information. So I've saved it as an index.html file in my desktop. So let me upload that from my desktop into this bucket. So that's index.html, and it's in capital I. So let me go to properties and go to static website hosting and make sure that I spell it properly, right? It's case sensitive, and then save it. So now this means that my website should be running through this URL, and it does. It's running through the static website URL. We're halfway through. So now let me go back to Route 53. Go back to Route 53, go back to hosted zones, go into the domain name, and then create a record set. And it's going to be an alias record. And I see my S3 static website endpoint there. Right, so click on it and create. It has now created an record that's pointing my domain name to the S3 endpoint that I have created, and my static website is running from it. So let me test it. Right, so let me go to the browser, put the domain name in there, and sure enough, the domain name, when my browser queried for the domain name, Route 53 returned a response saying this domain name is actually mapped to the S3 bucket, static website hosting enable S3 bucket, and this is the URL for that static website hosting. And then my browser was able to connect to that S3 bucket and download the details and show it in my browser. Right, so it's that simple and pretty straightforward.
Today's session is on AWS Elastic Beanstalk. So what's in it for you today? We'll be discussing about what is AWS, why we require AWS Elastic Beanstalk, what is AWS Elastic Beanstalk, the advantages, disadvantages, the components of Beanstalk, along with that, the architecture and the companies that are primarily using the AWS Beanstalk. So let's get started and first understand what is AWS. AWS stands for Amazon Web Services. It's a cloud provider and that offers a variety of services such as compute power, database storage, content delivery, and many other resources. So we know that AWS is the largest cloud provider in the market, and so many services are available in the AWS where you can apply the business logics and create the solutions using the cloud platforms. Now, why AWS Elastic Beanstalk? Now, what happened earlier and that whenever the developer used to create the software or the modules related to the softwares, it has to be joined together to create a big application. Now, one developer creates a module that has to be shared with another developer. And if the developers are geographically separated, then it has to be shared over a medium, probably an internet. So that is going to take some time. It would be a difficult process, and in return it makes the application or a software development a lengthier process, the building of the software development a lengthier process. So there were challenges which the developers were facing earlier, and to overcome that we have the Beanstalk as a service available in the AWS. So why AWS Elastic Beanstalk is required? AWS Elastic Beanstalk has made the life of the developers quite easy in terms of that they can share the applications across different devices at a shorter time duration. Now let's understand what is AWS Elastic Beanstalk. AWS Elastic Beanstalk is a service which is used to deploy and scale web applications by developers. Not only web application, any application that is being developed by the developers. This is a symbol representation of the AWS Elastic Beanstalk. Now, along with that, the AWS Elastic Beanstalk supports the programming language, the runtime environments that are Java, .NET, PHP, Node.js, Python, RubyGo, and Docker. And in case if you're looking for any other programming language or a runtime environment, then you can make a request with AWS to arrange that for you. Now, what are the advantages associated with the Elastic Beanstalk? First advantage is that it's a highly scalable service. Now, when we talk about a scalability, it means that whenever we require the resources in demand, we can scale up the resources or we can scale down the resources. So that is kind of a flexibility we get in terms of changing the type of resources whenever we need it. And in that case, the Elastic Beanstalk is a highly scalable service. Now that is something which is very difficult to achieve in case of an on-prem environments, because you have to plan for the infrastructure, and in case if you're short of the resources within that infrastructure, then you have to procure it again. The second advantage associated with the Beanstalk is that it's a fast and simple to begin. Now when we say it's fast and simple, that means that you just have to focus on the development of an application, building an application, and then you can just deploy the application directly using the Beanstalk. What the Beanstalk is going to do, that every networking aspect is being taken care by the Beanstalk. It deploys your application in the backend on the servers, and then you can directly access your application using the URL or through the IP address. The third advantage is that it offers the quick deployment. That is what we discussed in the fast and simple to begin as well. So why it offers a quick deployment? You don't have to bother about the networking concepts. You just have to focus on the application development, and then you can just upload your application, deploy that, and then you are good to go. The other advantage is that it supports multi-tenant architecture. When we talk about tenants or multi-tenants, that means we can have a virtual environments for separate organizations or the divisions within the organizations that will be virtually isolated. So likewise, you can have virtually isolated environments created on the Beanstalk, and they can be separated, used as a separate entities or a separate divisions within the organization. And we know that it's a flexible service. Since it's a scalable, then it is a flexible also. Now, coming to the simplifies operations as an advantage. Now, once the application is deployed using the Beanstalk, then it becomes very easy to maintain and support that application using the Beanstalk services itself. And the last advantage that we can have from the Beanstalk is that it's a cost efficient service. The cost efficient, as we know that many of the AWS services are cost effective. The cost optimization can be better managed using the AWS Beanstalk as compared to if you are developing or if you are deploying any kind of an application or a solution on the on-prem servers. Now, there are some components that are associated with the AWS Beanstalk, and it has to be created in the form of a sequence manner. So AWS Elastic Beanstalk consists of few important components which are required while developing an application. Now, what are these components? These are 4 components. One is application, the second is application version, the third is environment, and the fourth one is the environment tier. And we have to progress while deploying our applications or the softwares using the same sequence. Now let's understand what are the different components of the Beanstalk are. The application. It refers to a unique label which is used as a deployable code for a web application. So generally you deploy your web application or you create your application, and that is something which is basically used as a unique label. Then the second component is application versions. So it resembles a folder which stores a collection of components such as environments, versions, and environment configurations. So all these components are being stored using the application version. The third most important component is the environment. In the environment, only the current versions of the applications runs. Now remember that Elastic Beanstalk supports multiple versions as well. And using the environment, you can only run the current version of the application. For if you wanted to have another version of an application to be running, then you have to create another environment for that. Then comes the environment tier. And in the environment tier, it designates the type of application that the environment runs on. Now, generally, there are 2 types of environment tier. One is the web and the other one is the worker node. And that's something which we'll be discussing later as well. Now, let's understand how does Elastic Beanstalk in AWS works. So first we have to create an application, and this is a task that would be done by the developers. And for that, you can actually select any runtime environment or a programming language like Java, Docker, Ruby, Go, Perl, or Python as well. And once you select that environment, you can develop your application using that runtime environments. Now, after that, once the application is created, then you have to upload the version of an application on the AWS. And after that, once the version is uploaded, and then you have to launch your environment. So just have to click on the buttons. That's it. Nothing more you have to do. Once the environment is launched, then you can actually view that environment using a web URL or using the IP address. Now, what happens in that case is when you launch an environment in the backend, the Elastic Beanstalk automatically runs an EC2 instance. And using a metadata, the Beanstalk deploys your application within that EC2 instance. That is something which you can look into the EC2 dashboard as well. So you don't have to take care of the security groups, you don't have to take care of the IP addressing, and even you don't have to log in into the instance and deploy your application. It would be done automatically by the Beanstalk. It's just that you just have to monitor the environment, and the statistics will be available there itself in the Beanstalk dashboard. Otherwise, you can view those statistics in the CloudWatch logs as well. Now, in case if you wanted to update any kind of a version, then you just upload a new version and then just deploy that and then monitor your environment. So these are the essentials to create a local applications for any platform, whether it's a Node.js, Python, etc. These are the things that you have to actually take care, and this is the sequence you have to follow while creating an environment. So you can say that it's a 4 steps creation of or deployment of your application. That's it. Now, after users upload their versions, the configuration is automatically deployed with a load balancer. Yes, and with a load balancer, that means you can access the applications using the load balancer DNS also. And apart from load balancer, if you wanted to put any other feature that includes the auto scaling. For example, if you wanted to create your EC2 instances where the application will be deployed within the virtual private cloud or in a particular subnet within the VPC, all those features that are available, and you can select them using the Beanstalk itself. You don't have to move out to the VPC. You don't have to actually go to the EC2 dashboard and select all those separately. Everything would be available within the Beanstalk dashboard. So that's what it says in the presentation, that after creating an application, the deploy service can be specifically accessed using the URL. So once the environment is created, there will be a URL defined. Now you can put a URL name also. That is something which you wanted to put for your application. You can define that. You can check for the availability of that URL, and then you have to use that URL to access your application over the browser. Now, once it is done, then in the monitor environment, it says the environment is monitored, provided capacity provisioning, load balancing, auto scaling, and monitor features. All those features are available there itself in the Beanstalk. Now let's understand the architecture of AWS Elastic Beanstalk. Now there are two types of environments that you have to select. You can select. One is the web server environment and the other one is the worker environment. So based on the client requirement, Beanstalk gives you two different types of environment that you have to select. Generally, the web server environment is the front end facing. That means the clients would be accessing this environment directly using a URL. So mostly web applications are deployed using that environment. The worker environment is the backend applications or the micro apps, which are basically required to support the running of the web applications. Now it depends on the client requirement what kind of an environment you wanted to select. Now in the web server environment, it only handles the HTTP request from the clients. So that's why we use the web server environment mostly for the web applications or any application which works on the HTTPS requests. So it's not only the HTTP, you can use the HTTPS as well. The worker environment, it processes background tasks and minimizes the consumption of resources. So again, it is just like a kind of a microservice or an application services that are running in the backend to support the web server environment. Now coming to the understanding of the AWS Beanstalk. So this is how the architecture of the AWS Beanstalk is designed, and you can refer to that image also. Now in the web server environment, let's say if we select a web server environment, and it says that if the application receives client requests, the Amazon Route 53 sends these requests to the Elastic Load Balancer. Now obviously we discussed here that the web server environment is primarily an environment which receives the HTTP requests. It's a kind of a client facing environment. Now if the application receives a client request from the Amazon Route 53, this Route 53 is a service which is primarily used for DNS mapping. It's a global service and it may route, you can route the traffic from the Route 53, matching your domains towards the load balancer. And from the load balancer, you can point that traffic to the web server environment. Obviously, the web server environment is nothing. It's just the EC2 instances that would be running in the backend. Now, here in the diagram, you can see that there are two web server environments and they are created in the auto scaling group. That means there is some kind of scaling options that are defined as well. And these instances are created in an availability zone, or they can be created in a different availability zone also for the redundancy as well. And these web application servers are further connected to your databases, which primarily will be in a different security groups. Probably it can be an RDS database also. So all these functionalities, all these features are basically available on the Elastic Beanstalk dashboard itself. Now what happens in that case is if the application receives client requests, Amazon Route 53 send these requests to the load balancer. Later, the load balancer shares those requests among the EC2 instances. How does that happen? It happens using a predefined algorithm. The equal distribution of a load is distributed to both the EC2 instances or n number of EC2 instances running in the availability zone. Now in the availability zones, every EC2 instance would have its own security group. They can have a common security group also. They can have their own security group as well. Now, after the security group, the load balancer is then connected to the Amazon EC2 instance, which are part of the auto scaling group. So that's something which we have discussed already. Now, this auto scaling group would be defined from the Beanstalk itself, and there will be some scaling options that will be created. It could be a possibility that it might be the minimum number of instances that would be running as of now, and based on the threshold defined, it may increase the number of EC2 instances, and the load balancer will keep on distributing the load to as many instances that will be created inside the availability zones. Obviously, there will be an internal health check that the load balancer will be first doing before distributing the real-time traffic to these instances created by the Beanstalk. Now what does auto scaling group does? It automatically starts the additional EC2 instance to accommodate increasing load on your application. That's something which we know that. And also it monitors and scales instances based on the workload as well. So depends on what kind of a scaling threshold you have defined in the autoscaling groups. And when the load of an application decreases, the EC2 instance will also be decreased. So whenever we talk about the autoscaling, generally it comes in our mind is that we scale up the resources. That means it increases the EC2 instances. In the autoscaling, you might have the scale down option also, scale down policy also created, in which if the load minimizes, it can terminate the additional EC2 instances as well. So that is something which will be automatically managed. All these features can be achievable using the Elastic Beanstalk. And with this feature accommodated, it gives you the better cost optimization in terms of managing your resources. Now it says that Elastic Beanstalk has a default security group, and the security group acts as a firewall for the instances. Now here in this diagram, it says about the security group autoscaling also. You might create it in a default VPC also. You might create it in your custom VPC also, where you can have the additional level of security is also created. You can have the NACLs, NACLs also defined here before the security groups. So that would give you the additional filtering option or the firewall option. Now it says that with these groups, with these security groups, it allows establishing security groups to the database server as well. So every database would also have its own security group, and the connection can be created between the web servers environment that is created by the Beanstalk to the database security groups as well. Now let's discuss about the worker environment. Now understanding the worker environment, what happens is that the client, the web server environment is the client facing. The client sends a request for an access to the web server. And in this diagram, the web server further sends it to the SQS, which is a simple queue service. And the queue service sends it to the worker environment. And then whatever the worker environment is created for doing some kind of a processing or some kind of an application that is running in the backend, that environment initiates and then send back the results to this SQS and vice versa. So let's understand the architecture of a AWS Elastic Beanstalk with the worker environment. So when a worker environment here is launched, AWS Elastic Beanstalk installs a server on every EC2 instance. So that is in the case of a web server environment also. And later the server passes the request to the simple queue service. Now this service is an asynchronous service. Instead of a simple queue service, you can have other services also. It is not necessary that you need to have the SQS also. This is an example that we are discussing about. And the SQS shares those messages via a post request to the HTTP path over the worker environment. And there are many case studies also with respect to this kind of an environment that is being created, that is being done on many customers. And you can search for these kind of a case studies available on the internet. Now the worker environment executes the task given by the SQS with the HTTP response after the operation is completed. Now here what happens is a quick recap. The client requests for an access of an application to a web server using an HTTP request. The web server passes that request to the queue service. The queue service shares the message with the worker. Probably a worker might be the manual worker, and generally it's an automated worker. So it would be shared via the worker environment only. And the worker sends back the response with the HTTP response back to the queue. That response can be viewed directly from the queue service by the client using the web server. So this is one of the examples. Likewise, as I said, that there can be many other examples also where you can have the worker environments defined. Now, what are the companies that are using the Elastic Beanstalk? These are few of the companies that are primarily using. One is Zillow, Jelly Button Games, then you have League of Women Voters, eBury. These are some of the few listed companies, and obviously you search on the AWS site and you'll find many more organizations that are using the Elastic Beanstalk primarily for deploying their applications. Now, the next thing is to go with the practicals, that how actually we use the Elastic Beanstalk. So let's look into the demo using the AWS Elastic Beanstalk. Now first you have to log in into the AWS console, and I'm sure that you might be having the accounts created, or you can use the IAM credentials as well. And then you have to select the region also. Now I am in the North Virginia region. Likewise, you can select any of the regions that are listed here. Now click on the services and you have to search for the Elastic Beanstalk. You can find the Elastic Beanstalk under the compute section. So here itself, you'll find the Elastic Beanstalk as a service. Now open this service and there it will give you an option to create an environment. You have to specifically select an environment, probably a worker environment or a web service environment. So let's wait for the service to open. So we have the dashboard now available with us. This is how the Elastic Beanstalk looks, and this is the symbol representation of a beanstalk. Now, what you have to do is we have to click on Get Started, and that will load, and you have to create a web app. So instead of creating a web app, what we'll do, we'll create a new application. So just click on Create a new application, put an application name. Let's say we put something like XYZ. You can put any description to your application. Let's say it's a demo app, and click on Create. Now it says you have to select an environment. Now the environment, the application name XYZ is created. You just have to select an environment. So click on Create One now, and it is going to ask you that what kind of an environment tier you wanted to select. So as we discussed, that there are two types of environments. One is the web server and the other one is the worker environment. Let's look into it, what is defined by the AWS. AWS says that it has two types of environment tiers to support different types of web applications. Web servers are standard applications that listen for and then process HTTP requests, typically over port number 80. Workers are specialized applications that have a background processing task that listens for message on an Amazon SQS queue. Workers application posts those messages to your application by using the HTTP response. So that's what we saw in the case of the Beanstalk slides also. Now the usability of a worker environment can be anything. Now we'll do a demo for creating a web server environment. So just click on select, and we have the environment name created. Now we can define our own domain. It ends with the region.elasticbeanstalk.com. Let's say I look for a domain which is XYZ only. That's the environment name. Now I'll check for the availability whether that domain name is available with us or not. And it says we don't have that domain name. So probably I'll try to make it with some other name, and let's look for the availability. XYZ ABC, and it says yes, it is available. Now once I deploy my application, I would be able to access the application using this complete DNS. So you can put a description, it's a demo app that we are creating, and then you have to define a platform as well. Now these are the platforms that are supported by the AWS. Let's say I wanted to run a Node.js environment. So I'll just click on the Node.js platform. The application codes is something which is basically developed by the developers, and you can upload the application right now, or you can do that later as well once the environment is ready. Now either you can select to create an environment if you wanted to go with all the default settings. Otherwise, if you wanted to customize it more, you can click on Configure More Options. So let's click on Configure More Options. And here you would be able to define various different features like the type of an instance. For example, what kind of an EC2 instance or a server that should be running so that the Beanstalk can deploy your applications over it. If you wanted to modify, just click on a modify button, and here you can modify your instances with respect to the storage as well. Now apart from that, if you wanted to do some modification in the case of monitoring, in the case of databases, in the case of security, or in the case of a capacity, let's look into the capacity. So here you can actually do the modification. So in the capacity, you can select the instance type also. By default, it is t2.micro, but in case if your application requires a larger type of an instance, then you can actually go for the instance type as well. Similarly, you can define your AMI IDs also, because obviously for the application to run, you would require the operating system also. So you can select that particular AMI ID for your operating system as well. Let's cancel that. Likewise, you have many other features that you can actually define here from the dashboard, and you don't have to go to the EC2 dashboard to do the modifications. Now let's go and create an environment. Let's assume that we are going with the default configuration. So this is going to create our environment. The environment is being created, and you can get the environment and the logs defined in the dashboard itself. So you'll see that the Beanstalk environment is being initiated, the environment is being started, and in case if there would be any errors or if it is deployed correctly, you'll get all the logs here itself. Now the environments are basically color coded. So there are different color codings that are defined. If you get the environment in a green color, that means everything is good to go. So here you can see that it has created an elastic IP. It has checked the health of the environment. Now it has created the security groups, and that would be an auto security groups created by the Beanstalk. And the environment creation has been started. You can see that Elastic Beanstalk as Amazon S3 storage bucket for your environment data as well. this is the URL through which you will be accessing the environment, but right now we cannot do that since the environment is being created. Let's click on the application name, and here you can see that it is in a gray color. That means right now the build is being done. It is being created. Once it will be successfully created, it should change to the green color, and then we will be able to access our environment using the URL. Now, if I move to the EC2 instances and see in the EC2 dashboard, if I see whether the instance is being created by the Beanstalk or not. So let's see, and let's see what are the differences in terms of creating an instance manually and getting it created from the Beanstalk. So click on the EC2. Let's go to the old EC2 experience. That's what we are familiar with. And let's see what's there in the dashboard. So here you can see one running instance. Let's open that. And the XYZ environment, which was created from the Beanstalk, is being initiated. The instance is being initiated, and that is something which is being done by the Beanstalk itself. We have not gone to the dashboard and created it manually. Now, in the security groups, if you see that, here the AWS Beanstalk security groups are defined. It has the Elastic IPs also defined. So everything is being created by the Beanstalk itself. Right. Now let's go back to the Beanstalk and let's look into the status of our environment, whether the color coding has been changed from gray to green or not. And here you can see the environment is successfully created, and we have that environment colored in green. We'll access the environment, and it says it's a web server environment. Its platform is Node.js running on 64-bit Amazon Linux AMI, and it's a sample application. Health status is okay. Now the other thing is that if you do not want to use the web console, the management console, to access the Beanstalk, then the Beanstalk offers you the Elastic Beanstalk CLI as well. So you can install the command line interface, and then you have the command references, CLI command references, that you can actually play with and get your applications deployed using the Beanstalk itself. So this is one of the sample CLI commands that you can actually look into. Now let's look into the environment. Let's click on the environment and we'll be represented with the URL. It says health is okay. These are the logs that you have to follow in case if there are any issues. The platform is Node.js. That is what we selected. Now the next thing is you just have to upload and deploy your applications. So just click on upload and deploy. Select the version label or the name. Select file, and wherever your application is hosted at, just select that, upload it, and deploy your application. You'll see that like your environment is created, similarly your application will be deployed automatically on the instance, and from this URL you will be able to view the output. It is as simple as just like you have to follow these 4 steps. Now let's see whether the Node.js environment is running on our instance before deploying an application. So we'll just click on this URL. Since the Beanstalk has already opened up the security groups on HTTP port 80 for all, we can actually view that output directly from the URL. So we have the Node.js running, that's visible here, and after that you just have to upload and deploy your application, and then from that URL you can get the output. Now this URL you can map it with the Route 53 service. So using the Route 53 DNS services, the domain names can be pointed to the Elastic Beanstalk URL, and from there it can be pointed to the applications that are running on the EC2 instance. Whether you wanted to point it to the URL directly using the Beanstalk, you can do that. Otherwise, as we saw in the slides, you can use the Route 53, point it to the load balancer, and then point it to the instances directly also once it is created by the Beanstalk. So that was the demo, guys, with respect to the Beanstalk and how we can actually run the environments. Apart from that, the operational tasks like system operations, you can manage all these things from the environment dashboard itself. So you have the configurations, you have the logs, you can actually check the health status of your environment, you can do the monitoring, and you can actually get the alarms and the events here. So let's say if I wanted to see the logs, I can request for the logs here itself, and I'll be represented with the full log report, and I can now download that log file and I can view the logs. So it's so we have this bundle logs in the zip file. Alright, so if you want to see some kind of logs with respect to Elastic Beanstalk activity, it's in the form of a notepad, and here you can see what all configurations the Beanstalk has done on your environment, on your instance. Similarly, you can go for the health, monitoring, alarms, events, and all those things.
Moving on to the top 10 cloud computing projects, we have divided this video into 3 parts. The first part is for beginners. Moving on to the first project for beginners, we have a cloud-based file storage. In this project, you will create a simple cloud-based file storage system similar to a Dropbox or a Google Drive. Users can upload, download, and manage files stored in the cloud. The part to create this project will start by choosing a cloud storage service. Select a cloud storage service provider like AWS S3, Google Cloud Storage, or Azure Blob Storage. The next step is creating an account. Sign up for an account with the chosen cloud provider if you don't already have one. The next step is to set up a bucket or a container. Create a storage bucket or container to store your files. The next step is to develop a web interface. Create a web-based interface for users to interact with your storage system. You can use HTML, CSS, and JavaScript for this. The next step is to implement file upload and download. Add functionality for users to upload and download files to or from their storage bucket using the cloud provider's SDK or API. The next step is user authentication. Implement user authentication to secure access to files. You can use services like Firebase authentication or build one of your own. The next step is testing and deployment. Test your file storage system locally, and once satisfied, deploy it to the cloud. Make it publicly accessible if needed. The key learning points of this project is you will learn the basics of cloud storage services, file uploading and downloading, and user authentication. Moving on to project number 2, we have a website hosting service. This project involves setting up an essential website on a cloud platform like AWS, Azure, or Google Cloud. You will deploy a static or dynamic website and make it accessible to users worldwide. Let's move on to the path to create this project. The first step is to select a cloud hosting service. Choose a cloud hosting platform like Amazon Web Services, Azure, or Google Cloud. The next step is to design your website. Create the content and design for your website. You can use HTML, CSS, and JavaScript for static websites or web frameworks for dynamic ones. Then register a domain name. Purchase a domain name from a domain registrar, for example GoDaddy, Namecheap, etc. The next step is to configure DNS. Configure the DNS setting to point to your cloud hosting server's IP address. The next step is to set up a virtual server. Create a virtual server instance on your chosen cloud platform, for example AWS EC2, Azure VM, and Google Compute Engine. The next step is to install web server software. Install and configure web server software like Apache on your virtual server. And the last step is to upload website files. Upload your website files to the server, and then you are done with the project. The key learning points of this project: you will learn how to configure a web server, you will deploy web applications and manage domain names, and finally you will ensure high availability. The next project we have for beginners is a cloud-based calculator. Create a simple web-based calculator application and deploy it on a cloud platform like Heroku. Users can perform basic calculations using this calculator. Let's talk about the path to create this project. You will start by selecting a cloud platform. Choose a cloud platform like Heroku, AWS, or Azure for deployment. Then develop the calculator. Create a simple web-based calculator. You can use HTML, CSS, and JavaScript for this. Then set up a development environment. Install necessary development tools and libraries on your local machine. Then move ahead with version control. Use version control systems like Git to manage your project. Then create a cloud account. Sign up for an account with your chosen cloud platform. Then comes the deployment part. Deploy your calculator application to the cloud platform of your choice. For Heroku, this might involve pushing your code to a Git repository. And then comes the testing part. Ensure that the calculator functions correctly on the cloud server. Let's talk about the key learning points of this project. You will gain experience in setting up cloud server environments, deploying web applications, and understanding server-client interactions. Moving on to intermediate level projects. These projects are for people with decent knowledge of cloud computing basics. The first project we have in this category is an IoT data analytics project. Build a system that collects data from IoT devices, sensors, smart devices, etc. and stores it in cloud databases, for example AWS DynamoDB or Azure Cosmos database. Implement analytics to gain insights from the collected data. Let's talk about the path to create this project. The first step is IoT device setup. Set up IoT devices or sensors to collect data. Then choose a cloud database. Select a cloud database service, for example, AWS Dynamo Database, Azure Cosmos Database for data storage. Then comes the data ingestion part. Write code to send data from IoT devices to the cloud database. Then comes data analytics. Implement data analytics tools or scripts to analyze the collected data. Then comes data visualization. Create visualizations to present insights from the data using tools like AWS QuickSight or data visualizations libraries. And then the last part is monitoring and scaling. Implement monitoring and scaling mechanisms to handle increased data volumes. So let's talk about the key learning points of this project. You will explore IoT data ingestion, cloud database management, data analytics, and of course, data visualization. Moving on to the next project, we have a video streaming service. So you will create a video streaming service where users can upload and stream videos from the cloud. Implement features like video encoding, content delivery, and user authentication. Let's talk about the path to create this project. You will start by selecting cloud services. Choose cloud services for video storage, for example AWS S3. For encoding, you can choose AWS Elastic Transcoder, and for content delivery, you can choose AWS CloudFront. The next step is to design the application. Plan the architecture of your video streaming platform, including user interfaces for uploading and streaming. The next step is user authentication. Implement user authentication using services like AWS Cognito. Then comes the video uploading part. Allow users to upload videos to the cloud storage. And then comes the video encoding. Implement video encoding to create different quality versions of uploaded videos. Then comes the content delivery. Use a content delivery network or CDN to distribute videos efficiently to the users. And the last step is testing and scalability. Test video streaming and ensure it scales to handle concurrent users and varying network conditions. Let's talk about the key learning points for this project. You will learn about video processing, content delivery networks, and secure user access control. Moving on to the next project, we have cloud-based e-commerce website. Build an e-commerce platform hosted on cloud. Develop features like product listing, shopping carts, and secure payment processing. Let's talk about the path to create this project. You will start by selecting cloud platform. Choose a cloud platform, for example AWS or Azure, to host your e-commerce application. Then comes the e-commerce framework. Choose an e-commerce framework, for example WooCommerce or Shopify, or build a custom solution. Then comes the product listings part. Add product listings and descriptions with images. Then comes the shopping cart. Implement a shopping cart functionality for users to add products. Then comes the secure payment processing. Set up secure payment processing using payment gateways like Stripe or PayPal. Then comes the user authentication part. Implement user authentication for customer accounts. And finally, the testing and security. Thoroughly test your e-commerce website, ensuring it's secure and capable of handling transactions. What are the key points of this project? You will gain experience in building scalable web applications, handling online transactions securely, and managing customer data. Talking about advanced level cloud computing projects. For advanced level cloud computing projects, you should master cloud infrastructure and cloud services. The first advanced level project we have for today is machine learning with cloud. Develop a machine learning model and deploy it on a cloud server for scalable processing. This project involves working with large data sets and real-time data analysis. The first step is machine learning model. Develop a machine learning model using libraries like TensorFlow or scikit-learn. Then comes the data preparation part. Prepare and clean the data for training and testing. Then choose a cloud machine learning service. Select a cloud machine learning service, for example AWS SageMaker, Google AI Platform, and etc. Then comes the model deployment part. Deploy your machine learning model on the cloud platform. And finally, the scalability. Ensure the model can handle real-time predictions and scale as needed. Let's talk about the key learning points of this project. You will delve into machine learning, cloud-based data processing, and model deployment. The next project we have in this list is the cloud-based virtual desktop. Create a system that allows users to access virtualized desktop environments hosted on the cloud. This project focuses on remote desktop solutions. Talking about the path to create this project, you should start by selecting cloud service. Choose a cloud service for virtual desktop. For example, Amazon Workspace, Windows Virtual Desktop, or Azure. Then comes the configuration part. Configure virtual desktop instances with desired specifications. User management. Create and manage user accounts for accessing virtual desktops. Security. Implement security measures for data protection during remote desktop access. Then comes the access control part. Set up access control policies to restrict user permissions. And lastly, testing. Test the remote desktop access from different devices and locations. Talking about the key learning points of this project, you'll learn about virtualization, remote desktop technologies, and user management in a cloud-based context. Moving on to the third advanced level cloud project, we have a cloud gaming service. Build a cloud-based gaming service similar to Google Stadia. This project involves GPU virtualization, low latency streaming, and multiplayer game server management. Talking about the path to create this project, you should start by selecting cloud infrastructure. Choose a cloud infrastructure. You can either choose AWS or Azure for hosting game servers. Then comes the game server setup. Set up game servers for hosting games. Then comes the low latency streaming. Implement low latency streaming technologies for gameplay. Then comes the multiplayer support. Add multiplayer support for users to play together. Then comes the user management. Create user accounts and manage players' profiles. And finally comes load balancing. Implement load balancing to handle increased player loads. Talking about the key learning points of this project, you will explore cloud-based gaming infrastructure, server management, and real-time multiplayer networking. Moving on to the last cloud computing project, we have a healthcare data management system. Develop a cloud-based system for storing and managing healthcare-related data such as patient records. Ensure compliance with healthcare industry standards, for example HIPAA. Talking about the path to create this project, you should start by ensuring compliance with healthcare industry standards. HIPAA compliance. Understand and adhere to HIPAA compliance regulations. Cloud platform selection. Choose a HIPAA compliant cloud platform, for example AWS Healthcare APIs and Azure for healthcare. Then comes the data storage part. Create a secure cloud-based data storage system for healthcare records. Then comes the access control. Implement strict access controls and encryption for data security. Then comes the audit trials. Maintain audit trials for data access and modifications. And then at last comes the user training. Ensure staff are trained on HIPAA compliance and data handling protocols. Talking about the key learning points of this project, you will gain expertise in cloud security, data privacy, and compliance while addressing real-world healthcare data challenges. These projects provide a progressive learning path allowing individuals to start with basic cloud concepts and gradually advance to more complex and impactful cloud computing applications. Each project offers valuable experience and skills that can be applied to real-life scenarios and career development in the cloud computing field.
Hello folks, welcome to yet another exciting video from Simplilearn. Are you ready to unlock the doors to a thriving career in cloud computing? The job market for AWS is booming, and companies are on lookout for talented individuals like you. AWS holds a significant 32% share in cloud computing job listings, making it the go-to choice for many businesses. What makes AWS so appealing? Well, it's known for its cost-effectiveness, scalability, and rock-solid security features. However, to stand out and succeed in the job market, it's essential to be fully prepared to ace those interviews. In this video, we have compiled the top 20 AWS interview questions that will not only sharpen your knowledge, but also boost your confidence when facing those crucial interviews. As a bonus in this video, along with the top 20 frequently asked questions, we will also cover 5 questions based on case studies that you can definitely expect in your AWS interview. So the first question is, what is AWS and what are its key components? AWS or Amazon Web Services is a cloud computing platform offered by Amazon. It provides a wide range of services like computing power, storage options, and networking capabilities. Key components include EC2, Elastic Compute Cloud for virtual servers, S3 or Simple Storage Service for scalable storage, RDS, Relational Database Service for managed databases, and IAM, Identity and Access Management for security. You can also imagine AWS like a huge toolbox which has everything you need to build and run your applications without worrying about the infrastructure. You have EC2, which is like the section for renting virtual computers, S3 for storing your files securely, RDS for managing databases, and IAM for controlling who can access what. Now, what is the difference between EC2 and S3? EC2 provides resizable compute capacity in the cloud, allowing you to run applications. S3, a simple storage service on the other hand, is storage for the internet. EC2 is like having a computer in the cloud, while S3 is more like having a hard drive in the cloud where you can store files. Think of EC2 as a rented computer in the cloud. You can install software, run applications, and do pretty much anything you would do on a regular computer. Now, S3 on the other hand is more like a giant external hard drive. You can store all your files there, like images, videos, or backups, and access them from anywhere on the internet. Now, let's move on to the third question. Explain the concept of elastic load balancing, or ELB. Now, ELB automatically distributes incoming application traffic across multiple targets, such as EC2 instances, containers, and IP addresses, to ensure no single resource is overwhelmed. ELB is like having a traffic manager for your website or application. It automatically spreads incoming visitors or requests across multiple servers so that no single server gets overwhelmed. It's like having a multiple cache registers open at a store during rush hour. Let's move on to the next question. What is auto-scaling in AWS? Auto-scaling automatically adjusts the number of EC2 instances in a group based on demand. It helps maintain application availability and allows you to only pay for the resources you actually need. So auto-scaling is like having a magical elastic band around your servers. When there's a sudden spike in traffic to your website or application, auto-scaling automatically adds more servers to handle the load. And when the traffic slows down, it removes those extra servers so you don't waste money on unused resources. Now, describe the difference between IAM users, groups, and roles. IAM users are individuals within your AWS account, while groups are collections of users. Roles are similar to users, but they are meant to be assumed by other AWS services or users for specific tasks. Okay, imagine you're the boss of your AWS account. IAM users are like your employees. They can log in and do stuff, but only what you allow them to. Groups are like teams of users with similar permissions, and roles are like special hats that users or even other services can wear to do specific tasks. Now, the sixth question is, what is Amazon RDS? Amazon RDS, or Relational Database Service, is a managed relational database service that makes it easier to set up, operate, and scale a relational database in the cloud. Amazon RDS is like having a personal database expert on the call. It takes care of all the basic details of setting up, operating, and scaling a relational database like MySQL or PostgreSQL, so you can focus on building your app instead of worrying about database management. Now, explain the difference between Amazon RDS and Amazon DynamoDB. RDS is for relational databases and SQL Server, while DynamoDB is a fully managed NoSQL database service provided by AWS. RDS is like a traditional database with tables, rows, and SQL queries, while DynamoDB is more like a super fast, super flexible storage system for all kinds of data, from simple text to complex JSON documents. It's like comparing a filing cabinet to a magic box that can hold anything you throw at it. Now, what is Amazon VPC? Amazon VPC, or Amazon Virtual Private Cloud, is like having your own private corner of the AWS cloud. It's a virtual network that you can set up and customize to keep your resources isolated and secure. Think of it as creating your own little neighborhood within the vast city of AWS. Now, what is the difference between public and private subnets in Amazon VPC? Imagine public subnets are houses with doors facing the street. They're directly accessible from the internet. Private subnets, on the other hand, are like houses with backyard entrances. They're shielded from direct internet access, making them perfect for storing sensitive data or running internal services. Moving on to the 10th question. How does CloudFront work and what are its benefits? CloudFront is like having a network of delivery trucks all around the world, ready to bring your content closer to your users. When someone requests a file from your website or application, CloudFront finds the nearest delivery truck or edge location and serves the file from there, reducing latency and speeding up the overall experience for your users. Now, what is the difference between Amazon S3 and EBS? Amazon S3 is a giant storage locker in the cloud where you can dump all your files and they'll be safe and accessible from anywhere. EBS, on the other hand, is more like renting a hard drive that you can attach to your virtual server. You can install your operating system and applications on it just like you would do on a regular computer. Now, the next question. Explain the difference between the stop and terminate actions in EC2. When you stop an EC2 instance, it's like putting your computer to sleep. All the data and settings are saved and you can start it back up later without losing anything. But when you terminate an instance, it's like shutting down your computer and throwing it away. You lose everything and you can't bring it back. Now, what is AWS Lambda and how does it work? AWS Lambda is like having a team of tiny workers waiting in the cloud to execute your code whenever you need them. You just upload your code to Lambda, define when you want it to run, and Lambda takes care of everything else. Scaling, monitoring, and billing you only for the compute time you actually use. So let's move on to the next question. How do you secure your data at rest in AWS? Think of securing your data at rest like locking it in a safe. AWS offers various encryption options to keep your data safe from prying eyes, whether it's stored in S3 buckets, databases like RDS, or even on your EBS volumes. You can use AWS managed encryption keys or bring your own keys for added security. Moving on, what is CloudFormation and how does it work? CloudFormation is like having a blueprint for your entire AWS infrastructure. Instead of manually setting up each resource, you define everything you need in a template file using simple JSON or YAML syntax. Then, with a single click, CloudFormation creates and configures all the resources for you, saving your time and ensuring consistency. Now the next question, explain the differences between Amazon S3, EBS, and EFS. Amazon S3 is a versatile storage solution for the files of all types, accessible from anywhere. EBS or Elastic Block Store is more like a traditional hard drive attached to a single EC2 instance, perfect for storing data that requires low latency access. Now, EFS or Elastic File System, on the other hand, is like a shared network drive that multiple EC2 instances can access simultaneously, making it ideal for shared file storage across multiple instances. Now, what is Amazon SQS and how does it work? Amazon SQS or Amazon Simple Queue Service is like having a virtual queue for your messages in the cloud. When one part of your application sends a message, SQS holds onto it until another part of your application is ready to receive and process it. It helps decouple different components of your system, making them more resilient and scalable. Now the next question is, what is the difference between Amazon S3 and Glacier? Amazon S3 is like having a storage locker where you can quickly access your files whenever you need them. Glacier, on the other hand, is more like putting your files in cold storage. It's cheaper but slower to retrieve. It's perfect for data that you don't need to access frequently, but still want to keep for archival purposes. Now, what is AWS Elastic Beanstalk? You can relate AWS Elastic Beanstalk to a personal chef who takes care of all the cooking and serving while you focus on enjoying your meal. So it automates the deployment and management of your web applications, handling all the heavy lifting of provisioning servers, load balancing, and scaling. So you can just upload your code and let Elastic Beanstalk take care of the rest. Now coming to the last question on our list, how do you monitor AWS resources and services? Monitoring AWS resources can be explained as having a dashboard that shows you how your applications and services are performing in real time. AWS offers various monitoring tools like CloudWatch, which collects and tracks metrics, logs, and events from your resources, and AWS Trusted Advisor, which provides recommendations for optimizing your AWS environment based on best practices and cost efficiency. And that wraps up our rundown of the top 20 AWS interview questions. But wait, let's have a look at those 5 bonus questions now. Number 1, you're setting up a website for a small shop using AWS. How would you choose the right AWS tools to make sure the website stays fast and reliable, whether there are only a few visitors or a lot of people shopping at once during a big sale? Your second question, imagine you are like a tech detective investigating why a website's database is slow for a busy online shop. How would you use AWS tools to find out what's causing the problem and make the database super fast again? Number 3, as the hero for a startup, your mission is to control their AWS costs while still allowing them to grow. How would you do this, making sure they can expand without spending too much money or slowing down their operations? Now your fourth question, a non-profit organization needs help migrating their data to AWS. What steps would you take to ensure a smooth transition, considering their limited budget and technical expertise? And the last question you have, a startup wants to store their customer data securely on AWS. How would you recommend they do this, considering both cost and security? Try answering these questions in the comment section. Let's have a discussion there.
So that's a wrap on AWS Full Course. I hope this full course was informative. Do like, share and subscribe to the YouTube channel for more such content. Thank you and keep learning with Simplilearn.